Welcome to this video guys, and today we dive into the coolest trends in technology. We are exploring something that has taken the world by storm in 2024, generative AI. Now whether it's ChatGPT, image generators or voice cloning tools, generative AI is reshaping how we live, work and create. But here's the exciting part, you're not just here to watch, you're here to build. In this video, we will dive into some amazing hands-on Python projects that will give you practical skills to harness the power of AI. From face detection and chatbots to real-time data analysis and a full-blown virtual assistant, these projects are designed to keep you engaged and help you learn how to apply Python like a pro. Of course, we are going to start with the basics, what is Python and why it has become a developer's best friend. Well then, gradually level up to build AI-powered apps using Python, Numpy, OpenCV and more. You are guaranteed to find these projects fun, insightful and super beneficial for your career in tech. So let's get ready to dive right in, because by the end of the video, you will not only know Python, but you will have built tools that can predict, detect, analyze and create like never before. Let's jump right in.
Let me tell you what is Python. Python is basically a very popular high-level, object-oriented and interpreted language. Okay, when I'm saying high-level, what does that mean? Suppose you have no idea about the coding language, how you can use a code, how you can do a code, right? So if you start your journey with Python, it is just like a normal English you wrote, right? The normal way you write your English, the same way you can do the code as well in Python. Okay, so this is how Python is very flexible and beginner friendly, right? And using Python, you can have so many libraries. I will show you all the libraries, what you can do with Python. So these are the main reason why Python becomes so popular with days, right? Now we will see, why should you learn? Why should you learn Python? What is the reason that, we have multiple options that you can learn Java, Python, C, C++. But why we are saying that you should learn Python? The main reason is that Python is simple and beginner friendly language. Okay. And if you think about a coder, the first thing came into our mind that they will work with thousands of lines of code, right? But for Python, no, that's not the case. You can write your code in a very short way, right? Your code can be very short using some predefined function, predefined library that we have in Python. Okay, so these are the main reason why Python becomes so popular. Okay, and if you go for a data science data science domain, that in that part we need to use so many mathematical computational. If you want to do some exploratory data analysis, we need some stats concepts. So in that case, we have some library in Python who actually help us to do that mathematical computational easily, right? So these are the main reason why we want Python as our language. Okay, and if you are a gamer, if you want to have some good cool graphics for your game, yes, Python has some good graphics, some cool graphics that you can use for your game. And if you are a web developer, if you are a software developer, if you want to develop software, that is also can be done using Python. Okay, so basically you can use Python in a multiple ways, in multiple domains. So this is how Python is getting the popularity. Python is so popular because of its largest community for learners and the collaborators. It has the largest community, right? Where all the members are actually investing or doing some of kind of a research for Python, and one language become more popular for its community, right? So this is why Python is so popular, and Python is easy to learn and it has a usable flexibility, right? And it supports big data, machine learning and cloud computing. All the new upgrowing technologies are supported by Python. So you can say this is the main reason why Python becoming so popular, because it is supporting all the new upcoming upcoming technologies, right? Python is open source. You don't need to pay for Python. It is free of cost. You can use at any time. Okay, it has a huge number of Python libraries and framework. We have lots of framework. We can use it. That is also for free, and it has a huge number of libraries. Suppose you need to do a mathematical computational, you can use a library. Suppose you need to visualize your data, you can go for some library that is already Matplotlib or Seaborn, that is already predefined in Python. If you want to do a deep learning code, if you want to build your model, that's also possible using Python libraries, right? This is why Python becoming so popular. Okay, and Python supports automations as well. So this is the reason the Python is basically now it's the heart of the software engineers, you can say, right? Now we will see how can you install Python. So installing Python, what you need to do, you need to go to their official website, that in python.org, and there you will get the link and you just need to download. That's all you need to do. It's very simple to download Python in your local system. Okay, but yeah, we use some integrated development environment for Python. If you want to use some integrated development environment in your local system, for that you need to install Python first to your local system. This is the main criteria. Okay, so for IDE we have PyCharm. PyCharm is one of the most popular IDE, you can say. And now comes Anaconda. Anaconda is basically used for the data science purpose. If you are a data scientist or if you are an aspiring data scientist, you can use Anaconda as well, right? And there comes the Google Colab. Google Colab is provided by Google, and where you don't need to install anything, right? You can do it online, and it provides you a good amount of RAM. It provides you GPU and TPU as well. So some of the time we use Google Colab for the deep learning purpose, where we need to use GPU. So in our code, we will use Google Colab, right? Now I will show you what is the statistical measurement of Python user. Right, I was saying that Python is so popular, Python is so flexible, everyone is using Python, but why you guys should believe me, right? So let's see on the graph that how actually Python is becoming more popular with days. So you can see in the graph after 2016, there is a straight increasement in the graph, right? Where you can say it's showing till 2018, the Python is continuously increasing. Number of Python users is continuously increasing, right? So this is actually proving that Python is becoming more popular day by day because of its all flexibilities. Now we will see some of the Python projects. First, we will start with word count. But there is a business problem we have. For that, we need to make the project. Okay, so basically a content company who works with multiple stakeholders to make their content, right? And according to that, they have so many freelancers as well who are actually writing the content for them. Okay, so now they want to pay them according to the word they have written. Okay, let me give you an example, right? Suppose you are a technical content writer, or you are a blog writer, travel writer, right? So the company has different types of stakeholders for them, right? Suppose you want some technical content that will be done by the company, and company has some freelancer worker, right? Maybe they write thousands word, and they say for each word we are going to pay you 50 paisa, right? So for that, they actually need to have a word count. Okay, so counting the word, it's manually counting the words. It's very time consuming and it's very hectic, right? So they want to make a program which actually accepts the text file and it will count all the words it has, right? According to the count, that company is going to pay the freelancer. Okay. Now you can see, so the solution is, so they want to make an automatic system which can count the word from a text file automatically, right? So what it will do? First, it will read the text file using Python. So how can we solve the case study? So for that problem solution, first we need to read the text file, okay, using Python libraries. Then we need to store the whole document in a variable. Okay, we can store the whole document in a variable, and then we need to split the document using split function. Okay, so we will use split function. Again, this is a predefined function in Python that we are going to use. Then we will count the number of words in the variable, right? This is how we are going to use word counting for that particular company. Let's see how we can do that in the Google Colab. So now we are going to use word count from a text file. Okay, the project we are going to implement. To implement that project, first we need to have a data set. That data set is a text file data set. So I use the Harper's ASCII text file data set and I upload that text data in my Dropbox. So how we are going to fetch it? Using wget command, right? Let me fetch my data first from the Dropbox. You also can use that. Okay, so you can see we got Harper's ASCII.txt that is fetched in my content folder. You can see this is done. Okay, now what we are going to use? We are going to use open command, right? We are going to use open command to open our text file, right? So yeah, just let me do that. Maybe this part we will do later. First, let's understand how you can open the file, a text file, right? Okay. See, I give open function, then I put the path of my file, right? And then how you want to use it? I want to read it, right? I use R. Okay, if you want to write it, there is a separate option for that. If you want to write and read both, you will get other options as well. Okay, so using open function, you can write in your text file, you can read it in your text file, all of the thing you can do it. Okay, now what I did, I want to take a list, empty list, and I want to add some elements after some time in that list, right? So I use a C list, right? So you can see how you can use, you can actually initialize an empty list, that is C is equals to which bracket, right? That square bracket I'm going to use. This is how you can initialize an empty list. Now I'm going to use a for loop that will iterate through my documents, right? Through my text file, that if variable. So what I did, for x, that index in if, and then I just want to print text, that I want to see that what we have basically. So maybe, okay, fine. Let me do that. Okay. So I will see that what actually I am getting in part index, and then whatever I am getting, I just want to append them. How we can append them? C dot append. Okay. Then we are going to split the data, right? In X, we are getting all the sentences, right? But now I want to split them. How can I split them? Through each word, I use dot split function, and in the split function, in the parenthesis, I actually pass the space. For each word, we use a space, right? So the space will be my indicator that if there is a space, please cut it through, right? This is how we are going to count the word. Let's see. So you can see for X, we are getting all the lines, right? Sorry, for the X, we are getting all the lines. Now we will see what actually we store in C. Okay? Right. These are the full file I have. That text file. Right? Now let me try and print C. What actually I have splitted. Here you can see what I got. We got project, and each and every word we got separately. And this is how actually you can count the data you have in your data set. Okay. Now what I did, I use a counter, that is T. Okay. In using counter, we are going to count how many words do we have. Okay. So what we will do, we will again use a for loop, that is for I in range, and I'm going to take the length of the C. Right? If I told you, if you want to take the length of the list, we use length function. So length of the C, and I just want to increment my counter. That is D is equals to D plus 1. Right? After the execution, we will get how many words we have in the text file. Right? Let me just execute that. Yes, we got 3939. Total word count for our text file. See? Okay, again we got the total. So for each and every freelancer, for that what they can do, they just need to put the path of the file and everything will be done by the program, right? And according to the count, they can pay to their freelancer. This is how we can solve their problem. And this is the first project we have done in Python. And we will see a couple of more projects in Python to understand Python more easily, more deeply. Okay, so in our last project, we have seen that how you can count the word using Python, right? It was simple, I guess. That is how you can build a game using Python, right? So there is a young game developer who is basically a beginner in the Python, but he actually feels good when he start doing something regarding game. So he wants to make up his first game using Python. Okay. So he decided to make a word guessing game using Python. Let's see how we can actually implement a guessing, like you need to just guess your word. How can we do that, right? So first we need to import random. Why we need to import random? Because random help us to pick the word randomly. I will show you why when we are using random in our project, right? Now I have a words that is Apple, Oracle, Amazon, Microsoft, or maybe Orange. I'm going to add one more. And if you have more words in your list, you can add them. But for the sake of the simplicity, I am using least amount of data in our list, right? I have cat as well. I have dog as well. So this is my list, right? Word list. So you can say the vocabulary we have for our game. So it's going to give you a data in between that only, right? Now we will use guessed word. Guessed word is a variable where you will just choose a random word, right? You are not going to say use Apple, take Oracle, or take Amazon, right? The random dot choice is actually using this function to take a random data from your data set. Okay, so let's see what actually that guessed word we have. You can see it take orange. Let me execute one more. It will take something different. Yeah, it took dog, right? This is how random dot choice function is actually working in Python. Right? Now we are going to use the hint. What that hint is going to give you? I told you guys that for guessed word is basically a variable, right? And if you want to take a first element from that variable, you can use a indexing. So for my first word, for your hint, it will give you the first word and the last word. For the last word, maybe you can use the length of that, and I use -1, the negative indexing. Okay, so let's see. It took dog, right? It is supposed to give D and G, right? It give me D and G, right? Now we are going to take a list, that is store _G_L, where we are going to store all the guessed word, right? I am going to show you how we can do that. And we have try P variable where I am going to give you 6 times chance you can guess the word. If you can't guess the word within 6 chance, you are fail, right? Now what I am using input. Input function is basically used in Python to take a user input. In the word game, we really need to take user input, right? It's all about the user, right? So we use input, and then in the input, we are going to pass a message that it will going to show in the console. So I said, please enter your name. Now I am going to print that welcome to the game world, and I am going to print your name, right? I am going to welcome you to our new game. Okay, and print 6 attempts. So we are going to give you 6 attempts, right? So let me write it. We are going to give you 6 attempts for the casing. Okay, so let me just execute it. Okay, so it's asking what is my name. So my name is Sampriti. So I'm going to add Sampriti, right? So that time it's going to give me a output that welcome to the game world, Sampriti. We are going to give you 6 attempts for the guessing, right? Okay, right. So this is how your program will take the user input. So you can see, yes, we are going to give you 6 items for the guessing. Now we are going to use a for loop. You can see for our indexing is guess in range. We are taking range because it will go till 6, right? And I am using while true. When we use while true, when your condition is true. So when my try p is 6, right? When my guess index, like it will iterate through all the like till 6, right? Till my guess is 6 and my condition is true, then what it will do? It will take a variable that is later and give you that user input it will take, right? I'm going to say input and then guess the later, right? I'm saying please guess the later. Okay. Now, if length of later is equals to 1, then we will break it, right? So otherwise else, oops, the guess a later, right? This is what actually we are checking when we are saying 1, right? I give D. Okay, so that time the later length will be 1. But if I give Sampriti the full word, right, that time the length of the later is not 1. So first we need to check that whatever the input we got from the user, the length of that is 1. If it's 1, then break, and otherwise it will say sorry. This later, please give a later, right? And we are breaking from the while loop, right? Good. Next, if later in guessed word, print yes. So if you have the later, okay, so this later we are getting, right? So you can see in the guess later, right? The guess later what we have, wait a second, sorry, the guess word. So guess word is the random word, right? Suppose for dog, okay, in the guess word, if we have that particular alphabet, then we will print yes, right? And we will append that later to our list store GL, right? And otherwise it will going to say print no, sorry, that later is not there. Okay, so this is how you will get all total 6 chance, right? Maybe this is a dog, you are writing A, B, C, D, E. So when you write D, it will again say, okay, this is yes, and now you can go forward. But if you are printing, like if you are giving all the wrong words, still 6, it will say, sorry, there is your chances are finished, right? Now after you see, okay, this is dog, you write D, right? So again we are using if loop. We are saying that if guess is equals to 3, right? What is guess? This index number. Okay, when my guess is equals to 3, that time I am going to print, would you like to have a clue? I mean, you already guessed 3 times, maybe 1 time you are right, maybe twice you are wrong, right? So now I am asking, would you like to have a clue, right? If you say it, and again, if you like to have a clue, so that time we are taking Y and N. Okay, that Y can be in capital letter or the small letter. So what we are doing, we are taking that if clue request, that variable, the user is giving yes or no, that clue request dot lower. We use lower function to smaller our, maybe you put a capitalized word, right? So I make it in the smaller one, right? So dot lower we are using to small your alphabet, right? Then we use that dot start with Y. If you write yes, okay, so it starts with Y, it will check the first character. Okay, you can use Y and you can use yes as well. So at any way, it will take the first character of your input, right? User input. So if it's Y, then print clue, okay? And the hint, I told you for the hint we have the first letter and the first character and the last character of the guessed word. Like for the dog, we have D and G, right? We then print the hint, okay? Else, I'm going to say, if you say no, I don't want any clue, for that I'm going to say you are confident, right? Okay, fine, okay, good. So this is how we are going to execute our code. Lastly, what you will see now, let's see what you have guessed so far. And you have guessed, then what we will do, we are actually using a list that is stored underscore G underscore L. That list, we are going to length of the list, and we will say this is the length of your list and this is the word you have said correctly, right? Now we are going to print the letters are, okay. Now I want to show you that what are the letters you have actually guessed, right? That is stored GL, right? In the stored GL I have that, it will print, okay. Then what we will do, we will just, now we will say write the whole word, okay. As you already guessed this letter, so it's expected that you got the word, right? So I will ask you to write the whole word. When you write the whole word, we will again convert it to dot lower, and we will actually see that that word you have given in the user word is equals to the guessed word. The random word is chosen by our program, right? Suppose for my case it is dog. If you write dog, it will convert it to the smaller one, that dog, and then it will check if these two variables are same or not. If yes, it will say congrats, you are correct. Else it will say sorry, the answer was the actual answer, and print the actual answer, that's all, right? And then it need to just print press a enter to exit, just to get out from the program, right? Now we will execute the whole program. Let's see what we get. Right, now I need to write my name, so I'm going to write, sorry, not my name, guess the letter, right? So I'm going to guess the letter, maybe E. I know this is dog, but this is being a gamer, I don't know what the word is, so I'm going to write random word E. So it says no E. So maybe I'm going to use D. It's saying no. Why? Okay, fine. I'm going to use O. Yes, O is there. So I'm going to use R. No. Okay. So again, I'm going to use O. Okay. Right. Fine. So it's asked me, would you like to have a clue? I said O, but it does not understand. I don't write yes, right? So it said you are confident. It's it actually takes no. I don't want a clue, right? Again, guess the word. Let's just try using O. Okay. Now they are asking to guess the letter. Maybe orange. I don't know. Okay, so it says the guess the letter. I write orange. Is it oops? Please guess a letter. Okay, let me again do that. No. Okay, fine. What is giving me? Now let's see. What have you guessed so far? You have guessed 2 letters correctly. Okay, I have used the OO, right? I don't know what is it. So maybe again. What we have in O, right? Let's just do the maybe oracle. I'm just cheating basically, as I know the vocabulary of that. So I am cheating, but for the gamer, no. Still, I am not right. So the answer was dog, and please enter to leave the program. Okay, right. So this is how the whole program is going to act. So let me play the whole game again. So again, we have word, we have case word. I know this is dog. I don't want dog. Let me add something. Okay, this time this is Microsoft, right? Let me get the hint. That is M and T. Okay, let me give my name. Sorry, Preeti. Okay, so yes, thank you for coming to the game. Now let me just use it. The first letter. I know this is Microsoft. In. It's a no. Why? Okay. I see one more thing. So when I'm giving a capital letter, it's a no. So I don't use dot lower over there, right? So for that, it is saying no. It's not that, right? I use I is saying yes. I said C. It said yes. I said R. Okay. So they were asking for the clue. Again, I missed it. Fine. Fine. Let's see. Again is okay. Let me add. Okay. Now I already used MICRO. Right? They are asking me to write the whole word. So I am going to write Microsoft. Okay. They said congrats. You are correct. And then I'm going to just put enter just to leave the program. So this is how we actually use the word counter. Right? How can we use word counter? This is how we are actually make the guess the word. I hope you guys can understand how we make the word count project and how can you make the game that guess the word, right? Face recognition using Python. So here is the statement we have that Olivia, being a final year student, wants to make a face recognition using Python. The system will automatically detect all the faces from the given input. But how can you do that? Actually, she is in a confusion. How can I make a project which detect face from images, right? So here is the solution that we can use OpenCV. But before start this project, let me give you a small introduction what is face recognition is in Python, right? So facial recognition is a part of computer vision techniques. And when I'm talking about computer vision, what does that stand for and how is related to our life, right? Let me give you an example for that. Our generation is quite familiar with social media platforms, right? And we all share our memories with our virtual friends, and we love to do that. But did you ever think when you upload some new photos in those social media sites, how they give you the suggestion to tag your friends automatically without doing any extra efforts? Here comes the computer vision technology in the scenario, right? So what is computer vision? Computer vision is a process to give the ability to the computer to see as a human. It is the part of computer science which is focused on replicating the integrate parts of human visual system. It helps to identify and process the objects in images through the computer. The whole idea for the computer vision is to make an automatic replica of the human eye, which is more efficient than human eyes, right? Before we jump into the how computer vision works, let's see what is the library we are going to use over here, right? There are some predefined packages and libraries are there in our Python, right? One of the most important and popular libraries is OpenCV. It helps us to develop a system which can process images and real-time video using computer vision. So basically, if you want to do some real-time video object detection also, that you can do using OpenCV, right? It's a vast library. You can do so many things using OpenCV, right? OpenCV focused on image processing, real-time video capturing to detect faces and objects, right? So let's see a background of OpenCV. What is the background of OpenCV? How it actually invented? OpenCV was invented by Intel in 1999 by Gary Batsky. The first release was in the year 2000. OpenCV stands for Open Source Computer Vision Library. Okay, the library is based on the optimized C++, and it supports Java and Python along with C++ through interfaces, right? So these are the language is supported by OpenCV, that is C, C++, and Python, right? OpenCV is one of the most popular and successful libraries for computer vision, and it has an immense number of users because of its simplicity, processing time, and high demanding computer vision applications. Right? OpenCV Python is like a Python wrapper around the C++ implementation, and OpenCV has more than 2,500 implemented algorithms which are freely available for commercial purpose as well. So these are the main reason why OpenCV is getting popular day by day, and it is very easy to use for OpenCV. When I'm going to show you the project, you will understand how easy OpenCV is, right? So that time you will feel like using OpenCV rather than other algorithm or other libraries. Okay, so let's have a look at the application of OpenCV, right? So OpenCV is widely used in medical image analysis as well, right? So medical industry is very popular for the image processing purpose. So we use OpenCV over there as well. So suppose we need to identify the brain tumor, right? So every single day, almost thousands of patients are dealing with the brain tumors. There are many software using OpenCV to detect the stage of the tumor using image segmentation technique. And one of the application is RSIP vision, which builds probability map to localize the tumor and uses the deformable models to obtain the tumor boundaries with zero level energy, right? So these are the main application we are using OpenCV, widely using, and actually it is helping our everyday's life. It is actually helping us to reduce the manpower and the cost as well, right? And now comes the object detection. Detecting object from the images is one of the most popular applications. So let me give you an example what actually I'm talking about object detection. So you want to detect a person sitting on a two-wheeler vehicle, right? So we all know that if we want to, if you are just riding a two-wheeler, so you have to wear a helmet, right? So if you want to detect that what is the percentage of people they are actually using helmet when they are riding a bike or a two-wheeler, right? So in that case, we can make a system to detect helmet when that person is in a two-wheeler, right? Now, your model is going to check that what are the person they are actually traveling without helmet. Okay, so it's actually a defensible crime. So you can make a proper system when you can detect that some of the person is not using helmet. So you can just find them, right? This is a online application you can make that can help the traffic police as well and the and our society as well, right? So these are the applications we can use using OpenCV. Right now, how can you install OpenCV? I will show you how can you install OpenCV. It's a normal pip install OpenCV Python, right? So let's go to the code and see how we can do the whole project. Today we will use Google Colab, right? As we are using Google Colab, I hope you guys become quite comfortable with Google Colab. So Google Colab also supports OpenCV. Okay, so here first we need to use Google Colab.patches import cv2_imshow. So it is basically particularly for Google Colab, but if you want to go for some other ID like Anaconda or PyCharm, that time you need to use cv2.imshow to print your respected photo, the images, right? So yeah, and now first we will see how images can be read by a OpenCV, right? So machine convert images into an array. Okay, so first you need to do, let me do it for you. First, you need to write pip install OpenCV. Right, but for Google Colab, this is already there, so you don't need to do this. It's not matching distribution found for OpenCV. It's showing because for Google Colab they're using some other parts as well. So if you are using OpenCV in Google Colab, you need to just write import CV2 and you need to import from google.colab patches import CV2 underscore I am show. Right? Now, if you want to read the image, how can you do that? To read the image, you need to write CV2. CV2 is the library dot IamRead function. A IamRead function is actually help you to read your images. It converts your images into an array. Right? And these arrays are pixels, the pixel you have in your data. Okay, and you can read your image as a RGB value, that red, green and blue. Otherwise, you can read your picture as gray as well. Right? These are the two options we got. Right? Okay. So now let's see that how we can do that. So here already I have uploaded my images, right, in the Google Colab. Now I want to read them. So if you want to read them, you can see I just give the path. Like first write cv2.imread and the path of your image. I give that, right? Now I want to just print that. If you want to print that, what you need to do? You need to write cv2 underscore I am show, and then you need to find, like, give the the variable of your image, right? Let me execute that. Okay, now you can see I got the image. This image I take as my input image. Now if you want to see that what we have in IMG, right? So what actually they did? So it will be an array. Okay, you can see this is the array of your image, right? Input image. Okay, so this is how actually OpenCV reads a image. It converts your image into an array, right? Now if you want to convert your image into grayscale, how you can do that? So for that, what we do, we use cv2 color, and then we pass the CVT color is our function, and then we pass the image. Then we pass the image that I already stored that into image variable. So I write img, then comma cv2 dot color underscore bgr to gray, right? So what I want my image into grayscale, right? So that time we use cv2 dot color underscore bgr to gray, right? So let's see. So grayscale is basically will convert your image into a grayscale, right? So let's see what we got. You can see we got this. So grayscale in this array and this array are not same, right? This array you can see all over the colors that are RGB colors, and here you can see these are the grayscale colors, right? Now I want to see the grayscale image. So how can I do that? Again, cv2 underscore I am show, and you need to pass your gray, your variable name gray, right? Okay. You can see we got it that as a grayscale. But if you don't want to use cv2 dot color bg to gray, right? So I want to use my cv2 dot imd like to change your image into grayscale. How can you do that, right? So let me show you that as well. So these are the options you have. At any way you can change your image into grayscale. So what I need to do, maybe I am going to write gray2, that is a new variable. Then I am going to write cv2 dot, right, I am read. Okay, now I am going to pass img comma 0, right? Let's see what I'm going to get, and then I'm going to print, or I'm going to show my new grayscale data, right? Okay, I am getting an error. So let's see why I am getting the error. Okay, let me just. Okay, I'm so sorry. I need to pass the path, right? I told you for I am read, you need to pass the path, not the variable name, right? Okay. Okay, right. Let's see. Yes, you can see we got our image into grayscale. So this is how you can use cv2.color as well, or cv2.img. Or if you this is the parameter. Basically, if you put 0, it will return a grayscale image, and if you put a 1, it will return a colored image, right? You can see this is a colored image. So this variable, this parameter is basically used for which one you want to, right? One is RGB, one is 0 to, when you put that in a 0, so your array will be under 0 to 1, right? Let's see, let me just bring the gray to, so you will get what I am getting over here. So we got the grayscale colors, right? These are the grayscale color. Okay, and before that we used to get the RGB color. So this is how you can use OpenCV. Okay, now we will see how you can detect a face using OpenCV, right? And one more thing, if you want to just shape your image, right? How can you do that? If you want to reshape your image, right? I don't want this shape of my image. Okay, so how can you do that? So reshaping image is also can be done using OpenCV, or you can see the shape of your image as well, right? So let's see. I want to see the shape of my image first. So let's see how can you do that. Yes, you can see I got image.shape. So I got 427, 500 and 3. This 3 is basically showing you that your image is a RGB image, right? So image, okay, fine. Let me just show the image as well, for that you guys can understand which one I'm talking about. I'm taking so many variables, right? So let's see. Okay, so you can see I just print the colored image, right? So colored image is there and we got the shape of it. And for the shape, we got 3. This 3 stands for the RGB value, right? Let's see about the next one, the gray one, right? So we have gray as well, right? So CV2 underscore I am show, and I'm going to pass the grayscale image, right? Okay. And now I want to see the shape of the image. Yes, so you guys can see we don't get any RGB value over here, right? We only get the 427 and 500. This is how you can understand that your data is basically, your image is basically a grayscale image, or your image is basically a RGB image, right? So suppose now I want to detect the face of the image, right? So it will detect the face we have in the image. How can we do that? Okay, so here we are going to use a predefined file that is already defined in the OpenCV library. So we are going to use her cascade file. I know you guys have a doubt that what is a her cascade file. So basically, her cascade file is a machine learning object detection algorithm which is used to identify object in an image or video, right? And also it is a machine learning based approach where a cascade function is trained on a lot of positive and negative images, and then it is used to detect the object in other images, right? Now, her cascade file in OpenCV is basically a classifier. This classifier is used to detect particular object from an input image. Okay, and now we are going to use the frontal face default.xml. This her cascade file comes in a .xml file, right? And I already upload that XML file to my code, and you will get all the code in the description as well, and you will understand that what XML file I was talking about, right? So using, just to upload her cascade file, what you need to do, we need to use cv2 dot cascade classifier method, right? This dot cascade classifier method is going to read the her cascade .xml file, right? Let me do that. Okay, now we are going to detect the face in our image. How can you do that? We use faces variable, and then we use that face cascade which reads the XML file, right? Because I want to detect my front face. Okay, so for that we use frontal face default.xml file, right? Now I said I want to take that variable where I read the XML file. So face cascade dot detect multiscale. Okay, so this function we are using when we are actually trying to take the multiscale value, right? So we are going to use dot detect multiscale and we will pass gray image, right? It only works with the gray image. You can't do these things with the RGB image, right? I'm passing gray. Now I'm going to use a for loop where I will get this 1, 2, 3, 4, right? This part. So let me show the presentation. You can see we used to take this part, this part, this part and this part. Okay, so these 4 part we take when we try to like recognize or detect a face, right? So what we will do, we will take 4 variable for that. So I take for x, y, w, h in faces, right? Now what I will do, I will use cv2 dot rectangle. So dot rectangle is used for just to take this 4 part of your face. Okay, now I'm going to pass my image. Okay, so I'm going to pass my image and then I'm going to write xy comma x plus w comma y plus h, and then I will write 255 as we know the range of the image and range of the RGB is 255. I will write 255 00 and then 2. Right now I'm going to write cv2 underscore imshow and then img, right? And then we will write cv2 dot wait key because maybe it will kill all other cv2 components we have, right? So let's see what we will get over there. Yes, we got it, right? You can see our program is able to find properly what is the face we have in the whole picture, right? So it's able to find it out where is your face in the whole picture, right? This is how actually it's a pre-trained model. So we don't need to do anything. We just need to write the code that how can you use that hard cascade XML file, right? Now I'm going to show you if you have a multiple face in the picture, how can you do that? So I have a picture already. I downloaded a picture that has almost 6 different expressions, right? And with 6 different face. So let's see in one image if we have more than one face, is it able to understand that these are the also like face we have in the image, right? So let's see how can we do that. So first we will again load the image into img and then we will just show the image first. So let's see our image is loaded. Okay, our image is loaded, right? Now we are going to again convert that picture into grayscale using cv2.color bg2 gray, right? Okay, so let's see. Okay, and let me just print that as well. Yes, we got our image into grayscale. Okay, now I'm going to do the same thing what we did. That face is equals to face cascade dot detect multiscale. The multiscale I want to capture for my face, and then I will use a for loop, right? And then we are going to print it. Okay, right? So yes, you guys can see our model is able to find the different faces in one pictures as well. It is quite a good model, you can say. This is why OpenCV is becoming popular every day, right? So this is how we are going to use OpenCV if you want to use like just to detect a face from your particular image, right? You can use OpenCV if you want to just detect face from videos as well. For that you just need to do some extra lines of code. You can do that as well, right? So now we will look at that how can you generate password. I hope you guys are quite okay with the string, right? So here we are going to use the string only to string and the digit and some of the special characters as well to create passwords. Okay. Now we will have a look at how can you do that. So first we will actually create 3 password, right? One is a small string password. Let me give you that. What is the how can you do the small string password? Right, so doing the small string password, what we need to do, we need to import random and string. what is random, right? Random is basically, it will help you to choose random character or random digit from your list. Okay. Now comes the string. String is basically the normal string that we have talked about. We are going to use that normal string over here. We just need to import string, like import string, right? Okay. Now we will have to see how can you do that. To create a password, I just use a function. So what is function, right? So function is basically a code block which help you to do some of the specified part of the code. So doing the password, I don't need to write the same thing again and again, right? So using function, it will help me whenever I'm going to call the function, my task will be done, right? So this is why I'm going to use this function. To generate a strong password, to generate the function, what we need to do? We need to first write def. Def is basically used to create a function. This is one of the syntax you can say of the Python. Def is used to create the function, and then in the bracket you can say I am just passing a parameter, that is length. Okay, so length is my parameter, that what length I want to be my password, right? Now I just have a variable called alphabets, right? In this variable, what I will have string, that is my string. I am calling a lowercase function, that is a ASCII value lowercase function, right? So you will get all the lowercase values like A, B, C, D, E, F, G, H, right? All the lowercase one. Okay, fine. So string dot ASCII lowercase, we will get all the lower value. And lastly, what is actually returning? Returning, if you want to have like, for list, if you want to add something, we use dot append. For set, if you want to add something, we use dot add. But for string, if you want to add something, we use dot join, right? In the dot join, in the bracket, what I'm passing, I said random dot choice. So randomly choice any alphabets, right? So here I will show you what I have in the alphabet, right? So you guys will understand it. So let me just print this part, not the function, right? I will just break down the function for that you guys can understand what actually we are doing. So yes, let me just print it alphabets. Okay, you can see what I got. I got A, B, C, D, E, F, A to Z in a small letter, right? So we use dot ASCII lowercase to get all the lower values A to Z. Now what I want to see, what I am getting in random dot choice, right? So maybe I'm having a variable called AV is equals to, what I'm going to see, random dot choice, and I'm going to provide my alphabets, right? Let's see what I will get. You can see I said I want one random choice number. It's giving n. And let me just execute one more. This time it will be something different. So you can see I got D. So first time I got n using random dot choice. Now I'm get D, right? So basically this is used to get a random number. So for the password, we want the random one, right? We don't want to create same password again and again, right? How Google create the password? Can you ever think when you are going to log in and that time Google actually suggests a password for you? And that is never be a same password. And that is a very strong password, right? We will make a password like that as well. Okay. So how Google do that? Using this random function. Like I'm just saying that random function can be used to get random number for that. Okay. So you can go back, like we can go back to the function. Let's see. In the join, we are actually joining what? The random dot choice alphabets, right? It is going to choose the alphabets randomly from our list of alphabets, right? Now I am going to use for loop for I in range of length. Okay, so here I am giving the range of length. I am saying I want a 9 length character password, right? So it will take that much of character from the alphabet, random like character from the alphabet to get the password, right? This is why we are using for I in range length. Okay, okay. Okay, so let's see how it's going to, so let's see. Okay, I got a, okay, so it's actually, okay, let me just, I think it's, okay. Okay, so let's see what we will get over here. So I see that the length of the A is 9, right? So now what I want my generate strong, I'm calling my function that is generate strong password, right? And I'm passing the length of that, like length of that password, right? I want 9. Maybe I can change it to 8, right? Now what I get IHDDCGDIX, right? Now what I want to do, I want to just change it to 8. Let's see what I will get, right? But this password only have the small character. You can see I got EFUQACGY. Every time if you use this function, it will generate a new password, right? So this is only using a small like small words, right? Now let's see, have a look at how can you use small and capital letter both to actually get a password. How can you do that? So again, I'm going to use some small and capital letter. And in this case, we are changing the function of string. Here what we are taking dot ASCII letters. Before that, what we take ASCII lowercase. In this case, we will get the uppercase value. For that, we are using ASCII underscore letters, right? And the same thing, it's going to use random dot choice and alphabets for I in range length, right? Let's see how it's going to work. And here again, I'm giving the length of 9. Maybe here I'm going to giving the length of 7. Let's see what we will get over here. You can see I got A, B, B, N, Q, R, A, right? In the ASCII letters, what it has small and the capital letters both. You don't know which one is they are going to choose, right? So maybe I can do the same thing for you to understand what actually this ASCII, okay. Let me just have this code. Okay. So yes, let me just show you what it actually contains. So you guys will understand that why this ASCII, what is the difference between dot ASCII letters and what is the difference between dot ASCII lowercase, right? Okay, let me just print this. Yes, you can see I have A, B, C, D, A to Z and A to Z, like one capital A to Z and a small A to Z, right? Okay, so this is why actually we can use, okay, right. So if we want to see the small and capital letter and numbers, how can we do that? To doing the number, we use string dot digits, right? String dot digits actually will like return you all the digit, right? So let me just get one more code cell. Okay, so let me give you what we are having right now in alphabets and numbers, right? So here in this password, we will have a combination of small and capital letter and like numbers as well, right? So let me just execute this so you guys will understand this. So Badal, again, which one you want to take, right? So if you want to actually, you say that random function you don't want to use. If you want to go for some hardcore data structure one, you can go for it. That's not a problem, right? So you can see, now we are going to see what we have in alphabets and numbers. You can see what I have. I have A to Z for small, capital A to Z and 0 to 9, right? So this is how now we are having these characters, right? So let me check that what actually we got from this. Okay, so I'm getting a, okay, I didn't execute this. Okay, fine, let me do that. Fine, and let me see what password we got. Yes, we got a password that actually contains J2, S2, J, small d, 6, small p and small h, right? This is how you can create a combination password, right? Okay, right. Now let's have a look at how can you make the small capital letter, symbol and number, both. How can you do that, right? So for that, we are going to, this is actually going to be our most strong password. So in that password, they actually mention that in your password, they should have some special character, they should have digit, they should have alphabets as well. So maybe your alphabets should contains the capital letter, small letter, you should have string, you have the punctuation. That's some the special characters, right? So calling the special character, we use string dot punctuation functions, right? So this is how actually we can get our strong password, right? So for that, I just want to show you guys what we have in password, right? Okay. Let me just execute that and it will show you what we have in the, like it contains in the password, right? Okay, so in the password you can say what we have. We have A to Z, right? We already know we have small a to z, we have capital A to Z. You can see we have 0 to 9, right? You can see we have 0 to 9. We have all the special characters, that is hash, dollar signs, percentage, and sign, greater than, later, less than, at the rate, everything, right? So your password will be strong right now, right? For in this case, you can make a strong password, right? So in this case, what we need to do, the same function we are going to use, that generates strong password, and we are passing the length of the password, right? And in the password, we are using string.ascii letters that will have all the letters of small and the capital. We have digits, that is dot digits, right? Okay. Then we have punctuations to get the special character. We use dot punctuation function, right? And then we will use the return function. Someone is asking about the return function, right? So return function, what actually does? So return function help us to return what we want from the function, right? Suppose you did a plus b and you want to return something in that a plus b and return that the sum of that a plus b, right? So in that case, what we will do, for you guys, I will show you a simple function that will help you to understand the return function. Okay, so suppose I'm writing dev demo, and that's all, right? Maybe, or maybe you can pass two numbers, that is 2, 3, or maybe you can pass a, b as well, right? And you want to sum of them, right? Then I write a variable, that is c equals to a plus b, right? And now I want to return them. So what return helps me? Return is helping me to get the result. So we are using return function. It's not a void function, right? It's a return function, like it's a normal function which actually returns something. Like def function returns something. Okay, so in this case we are returning the sum of that two particular a and b sum. Okay, now what I'm going to write, I am going to write suppose print, and I am calling the demo function, right? Demo, and I'm passing what? I'm passing 2, 3. Let's see what we will get. You see, I got 5. How I got 5? This C is returning me 5. In this demo, 2, 3 is actually giving me 5, right? Right. So this is how actually return function works. Now I told you that get back to the generating strong function. So I already give that, right? So generate strong password. So in this password we have this whole lot of things, right? This numbers, alphabets, and the special characters, right? Now what I need to do, I just need to call my function. Let's see what my function makes. Yes, you can see my function makes all the like strong password. Maybe I can do it once more. Maybe this time it will be something different. Yes, you can see I got U, V, then square bracket, XP, and again closing square bracket, JLB, right? These are the strong password we are getting, right? Right. So this is how you can use your strong password, and the same way Google is also using their strong password technique.
We'll create a new notebook over here, new Python 3 notebook. And let me quickly write down import numpy as np, and let's just wait for this library to load. Now I will create an array. So I'll write down np.array, and inside this I'll just pass in a list of values. So this will be let's say I just pass in 1, 2, 3, 4, and 5, and then I go ahead and store it in this object called as n1. Then I print it out. So n1 is what I have. Then let me just go ahead and check the type of it. So type of n1, I hit on run. You would see that this is a numpy nd array. So here, what is nd array? Nd is n-dimensional array. And what is the dimension over here? It is a single dimension. So now let me go ahead and create a two-dimensional numpy array. So the same process, what I'd have to do is write down np.array, and inside this I will create this outer list. Then I will create this inner list over here, and I will create also the second list. Now in the first list, let me just pass in maybe some random values over here. So I've given 53731. Inside this also, I'll just pass in some 5 random values, which are 46123. And I'll go ahead and store it in this object called as n2. I'll hit run. So this has to be small. Now I'll again execute this, and let me print out n2 for you guys. And as you see, I have created this two-dimensional array. The values which are there in this first list have been stored as the first row over here, and the values which are there in the second list have been stored in the second row over here. So extremely simple stuff, nothing complicated over here. So we've just learned how to create a simple numpy array. And now we'll see how to create a numpy array where all of the values are equal to 0. So let's say if you want a numpy array with a particular set of dimensions and all of the values have to be equal to 0. For this purpose, we will be using this method called as zeros. And here, as you see, again, we'll import the library. Then we will be using the zeros method. So I write down np.zeros, and inside this, as you see, I set the dimensions. So the dimensions are 1, 2, which basically means I would want a numpy array of which the dimensions are 1, 2. So 1 row, 2 columns. And this I go ahead and store in this object called as n1. Then I print out n1 over here. And as you see, I have created a 1 cross 2 numpy array where the values are equal to 0. Then similarly, if I would want to create a 5 cross 5 numpy array, here as you see, np.zeros, inside this I pass in 5, 5. And when I print this out, you would see that I have created a 5 cross 5 numpy array where all of the values are equal to 0. Let me go back and I'll just quickly add a comment over here. I'll write down np.zeros. And what I'll do is, let me actually use this now inside this. Let's say if I would want to create a 3 cross 3 numpy array where all of the values are equal to 0. And maybe I'll just store it in this object called as n0. Now let me print out n0 for you guys, and you would see that this is a 3 cross 3 numpy array where all of the values are equal to 0. So extremely simple stuff over here. And I'll add a comment over here. I'll write down Pandas series, and I'll have to import Pandas over here. So I'll write down import Pandas as PD. Now again, let's just wait for a brief while for this library to load. And while this is loading, let me just also write in the next line over here. So I need to create a series object. Inside this, again, I'll just randomly put in some values. So let's say I have 52497. And I'll go ahead and store it in S1. I'll quickly hit on run, and let me just print out S1 for you folks. Then I'll go ahead and check the type of this. So type of S1, when I hit on run, you would see that this is a series object. So again, at index 0, you have the element 5, index 1, element 2, index 2, element 4, and so on. And this is how this is progressing. So simple stuff, isn't it? But then we have something called as a data frame. Let's just head back. I'll add another comment over here. I will write down Pandas data frame. I'll hit run. And what I'd have to do is create a data frame. So I'll write down pd.dataframe, and inside this I'd have to pass in dictionary. So I'll quickly give in these curly braces over here. First, I need to give in a name. So I'll write down name over here. Then I need to pass in a list of values. So let's say the name of the first student is Liv. The name of the second student is Daniel. Name of the third student is Phil. Then I'll go ahead and give in a list of marks. So I'll create another key called as marks, and let me add in their marks. So let's say Liv has scored 89 marks, Daniel has scored 95 marks, and Phil has scored 72 marks. And if I just quickly hit on run, you would see that I've created this data frame. Now, there's one more library, but then again, I guess we can learn that library through the case study itself. So I just wanted to give you guys a brief intro to the libraries which we are working with. We have the FIFA 20 dataset, and we'll be performing exploratory data analysis on top of this dataset. And now we'd have to import all of the required libraries. So we are importing Pandas for data manipulation, obviously. Then we have Matplotlib and Seaborn. So Matplotlib is a library which is used for data visualization. Seaborn is also a library which is used for data visualization. So Seaborn you can consider as it's an extension of Matplotlib. Extension in the sense that Seaborn is built on top of Matplotlib. So these are the three libraries which I would need. And what I'll do is I'll actually restart the kernel so that you're not able to see the output initially. So for you, it will be much more easier to understand. Now I'll hit on run, and let's wait for these libraries to load. All right, so we have loaded the required libraries. Then going ahead, we have this file called as players20.csv. So this is a file which I have already loaded in Jupyter Notebook. And to read a CSV file, we would need this method called as read_CSV. And this method read_CSV is a part of the Pandas library. So here, since I have loaded Pandas, so I'll write down pd.read_CSV, and inside this, I will give in the name of the file, which is players20.csv, and I will go ahead and store it in this object called as FIFA. And I'll just hit on run. Now, if I would want to have a glance at the first 5 records which are there, so I need to use the head method. So by default, this head method gives you the first 5 records which are there in this data frame. So FIFA.head. And here you would see that you have all of these different columns. So you have the FIFA ID, you have the player URL. So if you would, this is a column which just gives you the home page or the description of this player over here. Then you have the short name of this player. So here you have El Messi, obviously Messi. Long name is Lionel Messi. You have Cristiano Ronaldo, and you have Cristiano Ronaldo's long name. You have Neymar, you have Oblak, you have Eden Hazard. And here this column obviously tells you the age of this person. Here you have the date of birth. Then you have the height in centimeters of this player and the weight in kilograms of this player. Then you have the nationality. So Messi is obviously from Argentina. Ronaldo, we all know, is from Portugal. Neymar is from Brazil. Eden Hazard is from Belgium. And these are the clubs for which these folks play. Cristiano Ronaldo, he plays for Juventus. Messi plays for Barcelona. Neymar plays for PSG. Eden Hazard plays for Real Madrid. Then you've got all of these different stats over here. So for now, we'll just leave out those stats. Let's actually see how many columns are present in this particular data frame right now. So what we'll do is I will start a for loop, and I would want to know all of the columns which are present. So what I'll write down is for call in FIFA.columns, and I will print out each of the column which is present in this entire data frame. So for call in FIFA.column, so what will happen is it will iterate from the first column. So it will start from this first column and it will go to the last column over here, and we are printing all of the columns which are present over here. So for call in FIFA.columns, print of call, when I hit on run, you would see that these are all of the columns which are present. You have FIFA ID, player URL, short name, long name, age, date of birth, height in centimeters, weight in kg, and so on. So you have a lot of columns over here. Now I'd want to know how many records are there and how many columns are actually present in this data frame. So for that purpose, I will use this shape method. I'll write down FIFA.shape and I will hit on run. And you would see that there are 18,278 records and 104 columns. So this is actually a huge data set. For performing a simple case study. So here 18,278 records would mean that you have a list of 18,278 players in this entire data frame, and 104 columns are just the different features with all of these different players. So we've looked at the shape, and there is this column called as nationality in our data frame. So here, if you go up, you would see that there's this nationality column, and I would want to see how many players belong to which particular country over here. So since nationality is a categorical column, and if I'd want to understand more about a categorical column, I can use the value counts method. The value counts method gives me a frequency count of the different categories which are present. So what I'll do over here is first I'll give in the name of the data frame, which is FIFA. Then inside the parenthesis, I'll give in the name of the column, which is nationality. Then I'll use the dot operator and use the value counts method. And when I run this is what I get. So you see that in this particular data frame, most of the players are from England. So you have 1,667 players from England. Then you have 1,216 players from Germany, and you have 1,035 players from Spain. Then you have 984 players from France, then followed by 886 players in Argentina. So this basically tells you that in this data set, you have a lot of players from England, and that could also be a reason because you have more number of clubs participating in the English Premier League. So you also have all of these relegation zones. So you have tier 1 clubs, you have tier 2 clubs, you have tier 3 clubs. So maybe this data frame comprises of all of the players belonging to tier 1, tier 2, as well as tier 3. And that could tell you why there are more number of players belonging to England. Then let's say from this entire result, if I would only want to have a glance at the first 10 records or the top 10 countries where most of the players belong to, what I'll do is I'll write down FIFA nationality dot value counts, and again I'll just give in 0 to 10 inside this, and when I hit on run, you would see that so most of the players belong to these 10 countries over here. Again, at the top, you have England, Germany, and Spain. Then let's say instead of top 10, if I would only want to have a glance at the top 5, so over here, I'll write down 0:5. And you would see that I have these 5 countries. I have England, Germany, Spain, France, and Argentina. Now, I would want to make a bar plot for these top 5 countries where most of the players come from. So if I would want to make a bar plot, I would need to use this library called as Matplotlib. And we have seen that we have imported the submodule, which is pyplot, and we have given it an alias of plt. So here, first I need to set the figure size. So as you see, I'm setting the figure size over here, plt dot figure, and inside this fig size is a parameter inside this method, and using this parameter I set the dimensions of the image. And as you see, I set the dimensions to be equal to 8, 5. Now once I set the dimensions, then I go ahead and create the bar plot using plt dot bar. And when I write down plt.bar, you have all of these different parameters over here. So when we are creating a bar plot, the first parameter which we give inside it should be the categorical values. Now, after that, what we do is we give in the numerical entries over here. So what we do is first, if we say categorical entries, these are the categorical values over here. Now, if I only use dot value counts method, that gives me these categorical values along with these numerical values. But what if I only want the categorical values, only the names of the countries? So in that case, what I can do is I can use the keys method. So here, as you see, till here, the command is the same. FIFA nationality dot value count 0 to 5. Then I am using the dot keys method over here, and I will hit on run, and you would see that I am able to extract the names of these top 5 countries without the values. And since I need to pass in categories as my first parameter, this code is what I'm passing in as the first parameter over here. Then going ahead, the next value is the same command without the keys method. Then going ahead, I have another parameter called as color, and I set the color to be equal to green. So G is, again, it's just a short form for the green color. So I have first passed in the categorical entries, then I've passed in the numerical entries, then I have passed in the color over here. Then I hit on run. So here you see that this is the bar plot which we have created, and it's pretty evident, isn't it? This is what we saw in the list as well. So most of the players, they are from England. Then you have around 1200 odd players from Germany. Then you have 1000 odd players from Spain. Then you have France and Argentina falling behind. So guys, again, to the folks who have just joined, if you haven't yet subscribed to our channel, please do subscribe and also hit the bell icon, because that would be, very helpful to us. And that is how we'll be able to reach more people. Great. So right now we have looked at the nationality column. Now we will go ahead and do some more analysis. So we have the wage in euro column. Now I'll just show you if we can. So now, as you see, like some of the columns wouldn't be listed over here because this is a huge data frame, but we have this column called as wage underscore euro. So this tells me the salary of these players in euros, and I'd want to see, I'd actually want to see over here which player gets, what is the salary of some of these players. So what I'd want to do is from the entire FIFA data frame, I'd want to extract only 2 columns. The first column would be the short name of the player, and the second column would be the wage in euro. And this I will go ahead and store in this object called as player salary. Now that I have created this sub data frame from my original data frame, then I would want to have a glance at the first 5 records of this. So here, player salary dot head, I will click on run. here you see that in the first column, I have the short name of the player, and in the second column, I have the salary of the player. And here, as you see, Lionel Messi, his wage is you have 65,000 euros. Then you have Ronaldo with 405,000 euros. Neymar is at 290,000 euros. Oblak is 125,000 euros. And Eden Hazard is at 470,000 euros. So I'm not sure if these are the latest salaries which these players get, but according to this particular data frame, it would seem that Eden Hazard and Lionel Messi actually get more salary than Cristiano Ronaldo. And now, what we will do is I'd want to see who is the highest paid football player. So from this data frame, from this sub data frame, what I'd want to do is I would want to sort this with respect to the wage column. So what I'll do is I'll write down player salary dot sort values, and inside this I have this parameter called as by. And what I'm doing is I'm just sorting this data frame with this column called as wage underscore euro. And I'll set ascending is equal to false because I would want that player with the highest salary at the top, and that is how it will proceed. And this again, I'm storing it back in the same object called as player salary. And I'll go ahead and hit on run. Now I will have a glance at the first few records of this. So when I say player salary dot head, so obviously, as you see over here, Lionel Messi is the highest paid football player at 565,000 euros. Then you have Eden Hazard at 470,000 euros, Ronaldo at 405,000, Kevin De Bruyne at 370,000. You have Griezmann at 370,000 euros. So quite an interesting analysis, isn't it? So again, we will do the same thing. We will make a bar plot for these top 5 football players with the highest salaries. And since we have these categorical entries over here, we would have to make a bar plot. So you'd have to understand why we're using a bar plot. So normally, whenever we do want to understand the distribution of a categorical entity, that is when we go ahead and make a bar plot. So here, what we are doing is first, the same thing, we will set the figure size. So Apurva over here is asking me to repeat the bar plot again. So that is what I'm doing right now. So this time we are creating a bar plot for the players with highest salaries. Here, as you see, first I am setting the figure size. So I'll write down plt.figure. Inside this, I'm setting the figure size using this parameter called as fig size, and I given these dimensions. So the dimensions are 8, 5. 8, 5, 8 is the width, 5 is the height. So I've given the dimensions of the figure. Now, after I set the dimensions of the figure, I can just go ahead and create a bar plot. So to create a bar plot, I'd have to write down plt.bar. Inside this, so in a bar plot, always remember that the first parameter which you given has to be the categorical entries. The second parameter which you given has to be the numerical entries. So here, the first parameter, since it has to be capital, it has to be categorical. What I do is I would have to, so we have a categorical column, we have a numerical column. So obviously it is the names of the players which will be passing in over here. So this basically is your x-axis. So on the x-axis, we would need the names of the players. So I'll extract this particular column. So this short name column is from player salary data frame. So I'll write down player salary, and I given the name of the column, which is short name. And obviously I'd want only the top 5 records. So I'll given 0 to 5 inside this. Then I will go ahead and in the next parameter, as you see, I have a wage in euro. So again, since it has to be numerical, this time I'm extracting the wage in euro column, and I'll go ahead and set the color over here. So color, as you see, is equal to red. Then I will go ahead and plot it out. I will hit on run. And as you see, this is the result which we get. So on the x-axis, we have the names of the players, and on the y-axis, we have the salaries. So Lionel Messi obviously is leading the chart. Then you have Eden Hazard, Cristiano Ronaldo, Kevin De Bruyne, and Annie Griezmann. Now let's say if I would want different colors for all of these different bars over here. So that is something which we can also do. Now let's say instead of just keeping this as red, if I would want different colors, so what I'll do is I'll pass in a list of colors over here. So for Lionel Messi, let's say I give in blue color. Then for, let me just keep it small, B. So for Lionel Messi, I'm keeping blue color. For Eden Hazard, I'll give green color. Then for Cristiano Ronaldo, maybe I'll give in red color. Then for Kevin De Bruyne, I'll give, let's make it pink. And finally for Griezmann, let's keep it, let's say, orange. And let's hit run. Seems like we have an error over here. The spelling which I've given is incorrect. So let me just keep pink and I'll hit on run. And as you see, this is the result which we get. So we can change the colors which are there in all of these bars as well. Now what I'd want to do is I'd want to do a simple analysis for the players who belong to Germany. So what I'm doing is, so let's say if I, from this FIFA data frame, if I set the nationality is equal to Germany and I hit on run, I get a bunch of true and false values. So when you have these bunch of true and false values, what does this actually mean? So if you have a false over here, this means that in that particular record, the nationality of the player is not equal to Germany. And if it is actually equal to true, then it would mean that the nationality of the player is Germany. So what I'd want to do is, from this list, I would want to extract all of those records where the value is actually true. So I will take this command and I will paste it again inside the FIFA data frame, and I will store it in this object called as Germany, and then I'll print it out. So I'll write down Germany.head. And if I would want to have a glance at the first 10 records of it, so Germany.head, inside parenthesis, I'll write down 10 and I will hit on run. And this is the result which we'll get over here. So as you see, this is the list of all of the players whose nationality is Germany. And now what I'd want to know is, I would want to see who is the tallest German player. So Germany.sort values, I will use by, and I would want to sort this with the height in centimeters column, and I will set ascending is equal to false. And I would only want to have a glance at the top 5 records. So I would want the top 5 tallest players of German nationality, and I'll hit on run over here. And as you see, so you have Aaron Seidel right now as the tallest player of German nationality. His height is 199 centimeters. Then you have Michael Esser, whose height is 198. You have Lars Unestal, whose height is 198 again. Then you have Dominic. Then you have Lucas. So these are the players with the, these are the tallest players. Then similarly, let's say if I would want to sort these German players according to their weight, I would want to see which player has the maximum weight. So again, this will be similar. I'd have to write down Germany.sort values, and I would have to sort it with respect to weight, and ascending, I'll set it to be false, and I'll hit on run. This time you would see that weight over here. So it's Lucas Woltowiak, who has the highest weight of 103 kgs. Then again, you have Lars Unestal, whose weight is 103 kg. Then you have Ralph Farman. Then again, you have Michael Lesser, and you have Nicholas Sule. And then I would want to see who is the highest paid German player. So this time I have the wage in euro column, and I am sorting it with respect to the wage in euro. Ascending is equal to false, and dot head method. Now if I show you these players, let's see what are these names. So Tony Cruz is the highest paid German player, and he plays for Real Madrid. So obviously, if you're playing for Madrid or Barcelona, you would be paid a lot. Then you have Marc-Andre Stegen, and he plays for Barcelona, so he's the second highest player. Then you have Leroy Sané, who plays for Manchester City. Then you have LK, who plays for Manchester City as well. Then you have Thomas Müller, who plays for Bayern Munich. So top 5 players of German nationality who have the maximum wages. Now, again, what I want to do is I just want to make a simple data frame again. So I just want what I want is I would want 2 columns. The first column should have the name of the player, the short name of the player. The second column needs to have the wage in euros, and I would want to sort this with their salaries. So Germany, from this data frame, I'm selecting only short name and wage, and then I'm sorting this data frame by their salaries. And obviously I'm sorting this in descending order, and I would want to have a glance at the top 5 records. Now, if I click on run, you would see that this is what I get. So obviously, it is Tony Cruz, who has whose salary is 330,000 euros. Then Stegen has 250,000. Then you have Sani at 195, and at 5th place you have Müller at 170,000 euros. Now, after this, what I want to do is, from the original data frame, I would want to see who has the best rating for his shooting skills. So what I'll do is, from the FIFA data frame, I'll extract only 2 columns. The first column is short name. The second column is shooting. And I'll extract these 2 and I'll store them in this object called as player shooting. I'll hit on run, and I'll go ahead and sort it again. Now, when I hit on run, you would see that Cristiano Ronaldo has the highest rating for his shooting skills. So he's got a rating of 93. Then you have Lionel Messi, then you have Harry Kane, then you have Sergio Aguero, and you have Quagliarella. So these are the top 5 players with highest shooting skills. Now, similarly, I'd want to see which player has the maximum defending skills. So player defending. So this time, from the original FIFA data frame, I'll be extracting the short name, the defending column, which would tell me his defending skills, the rating for his defending skills. I have his nationality, and I also have the club for which this person plays for. Player defending. And now I would want to sort this by his defending skills. So obviously, player defending dot sort values, by is equal to defending, and this has to be in descending order. Then I'll hit on run. So you see that you have Cielny, who plays for Juventus, and he's from Italy. He's got the maximum defending skills. Then you have Van Dijk. Van Dijk plays for Liverpool, and his nationality is Netherlands. Then you have Koulibaly, then you have Gordon, and you have Hummels over here. So Hummels plays for Dortmund. And then finally, what I'd want to do is I'd want to analyze the list of players who play for Real Madrid. So Madrid is one of the topmost football clubs across the world, and I'd want to see what makes this club so special. I'd want to analyze the some of the features of different players over there. and that would be the final analysis for today. So what we'll do is, from the original data frame, which is FIFA, I will set the club value to be equal to Real Madrid. So from the original data frame, we are extracting only those records where the value is equal to Real Madrid, and that I'll go ahead and store in this object called as Real Madrid again. Now I would want to see who is the highest paid player in Real Madrid. So Real Madrid dot sort values, and I would want to sort it with respect to the wage in euro column. And when I hit on run, you would see that Eden Hazard is the highest paid player in Real Madrid currently. Then you have Luka Modric. So Luka Modric is the second highest paid. Then you have Toni Kroos, Sergio Ramos, and Karim Benzema. So Eden Hazard plays for Belgium, Luka Modric plays for Croatia, Toni Kroos plays for Germany, Sergio Ramos plays for Spain, and Benzema plays for France. And now we have looked at who are the highest paid players in Real Madrid. Now let's also see who has the best shooting skills in Real Madrid currently. So Real Madrid dot sort values, and I would have to sort it with respect to the shooting column. Ascending is equal to false because again I'd have to sort it in a descending order. And as you see, Gareth Bale has the best shooting skills currently in Real Madrid. Then you have Jimmy Rodriguez, who is the second best shooter, followed by Eden Hazard. Then you have Karim Benzema. Then you have Luka Jovic. Finally, I'd want to see who are the best defenders in Real Madrid. So Real Madrid dot sort values, by is equal to defending, and I'll hit on run. And here, as you see, so it seems that Sergio Ramos is the best defender in Real Madrid currently. Then you have Casemiro. After that, you have Varane. Then you have Carvajal, and finally you have Militao. So these are the top 5 defenders currently who are playing for Real Madrid.
Let's go to the actual project. In this case, what we are going to use, like you can use Jupyter Notebook or that Anaconda, basically you can use that as well. Now we are going to import some of the libraries. The libraries like BS4, that is Beautiful Soup comes from BS4 library. Then we are going to use SMTPLIB, right? Basically this library, I will explain you why we are using this. This is actually sending a mail. Okay, so we are going to send a mail if that price is dropped. Okay, then we are going to import Pandas, Numpy, Matplotlib, Seaborn, right? If you want to visualize your data. Now comes the URL part, right? So let me go to Amazon first. So this is my product. So for my case, I love to go for buying Oppo Reno 3 Pro. Fine. So my case, I am going to go for Oppo Reno 3. And if you guys want to go for some camera, if you guys want to go for some other parts as well, so you can go for that. So what you need to do, you need to take this URL properly. So I copied that URL. Okay. Now I will go to my code, and what I'm going to do, let me just do that. Okay. Fine. Now what I'm going to do, I am going to write a variable that is URL. Fine. Okay, so I'm going to do the URL, the variable, and then I'm going to provide the link for that particular product. Okay, so for my case, you can see http amazon.in, that Oppo Reno 3, that model website link is this, right? We are going to store this in URL. Let me just execute that. Okay, now what I need to do, I need to mention a header right now. So what will be my header? Okay, so in this case, I'm going to write headers is equals to user agent, right? And then I'm going to provide this, that Mozilla 5.0 Windows NT 10.0, right? Now, what I need to do, okay, now I need to pass the request, right? How can I do that? I'm going to write before that I need to install request as well, right? So I have installed pip install request. Okay, so in this library basically help us to request for any particular URL. Now I write a variable called page equals to request, that library I'm calling, and then dot get. What I'm passing my URL and the headers. What is the header, right? Fine. So basically header is nothing which browser you are using, right? For my case, I am using Chrome. Okay. Now, what I need to do next step is to create a beautiful soup object from the HTML. Okay. So this is done by passing the HTML to the beautiful soup function. The beautiful soup package is used to parse the HTML, that is take the raw HTML text and break it into Python objects. The second argument is basically HTML. Like if you want to just break that, if you are going to say I don't want that tags, right? So for that we are going to like say that dot parser, right? So for my case I said page dot content. So basically the page request is already there in my page variable. Now I am going to say I want all the content from that page. Okay, so I'm going to use page dot content and then HTML dot parser. Basically this is used to say I don't want any tags, give me only the website, or like only the content from that particular website. Okay, fine. Then what we are going to do, then the soup objects allow you to extract interesting information about the website you are scraping. So you can see the, if you want to see the title, right? Let me break it down for you guys. Okay, so I want to see the title of that particular product. Okay, so let me just do that. Okay, so you can see I got the title Oppo Reno 3 Pro, and this is the no cost EMI, and this is the actual title of that product. You can see if I go to, yeah, you can see this is the title of my website and I got this over here, right? Oppo Reno 3 Pro. Okay, now let's have a look at the title name. Okay, so already I have printed the title. Now I want to see the title name. So if you want to go for any title or title name, anything if you want to go for, how can you do that? Just calling that beautiful soup object. Okay, so you can see this title dot name, that is title. Now if you want to see the string, if you want to see the parent dot, like when you are making a website, right? When you are making a website, that time there will be some header, some parent, or some of the title will be there. So basically it helps you to get those information out from the website, right? In this case, this title dot name will give you that title, and then title dot parent dot name, what is the parent class of that, if there is any parent class, so it will show that. And like lastly we will have the specific values, that shoop dot p. Let me just execute that. Okay, so you can see for Oppo Reno 3 we got the title name. For the last one we get delivery associate will place the order on your doorstep and stay back to maintain 2-meter distance because of the COVID, we all know. So this is what you will get when you go for scraping the data from Amazon. Now if you go for using find all, what actually that find all will give you? This find all will give you that whatever the data that particular page consists of, right? So you will get all the data from there. Okay, so you can see I got all the data from there. Okay, and if you want to see line by line for that data, how can you do that? Using for loop, right? Okay, so you can see I got all the data from the website, that delivery associate, no customer signature are required, find answer in product info, right? So these are the data we will get when we go for using dot find all function. Okay, now we will have a look at that URL. So if we have any URL in that particular website, how can you get that? So in that case, you will need to write URL dot get href. Href is basically give you that how many links you have in that particular page, right? Let me do that. Yes, you can see these are the href, or you can say the link I have in my page. Okay, now then we are going to say I don't want all this href or that, I just want all the text from my particular page. How can you do that? Okay, so you can see I get all the data using that particular tags as well, right? You can see I get all the data using get text method. Okay, now what I need to do, now there comes the product title. Now if you want to get the proper ID, right, and if you want to check the proper price for that particular thing, how can you do that? In that case, okay, so in that case, what we need to do, we need to go to that website. So you can say I came here. Now I'm going to write, I just want to check the HTML tags for my particular website. How can I do that? Control Shift and C, right? So you can see I got this. Okay, now what I need to do, I need to go to that price. I want that my price should be, I want to see what ID they are going to use for the price, right? So in that case, my price will be, just a second. Okay, so you can see over here, my price will be price block underscore outright our price, right? So this will be my ID to fetch the, okay, so this will be my ID to fetch the price from the website, right? So in this case, you can see I have already give you the like screenshot over here. If you like look closer, that TD ID is equals to price block underscore our price underscores label, right? So this is your ID to fetch the particular price from that particular website, right? Now, okay, so now what I need to do, you can see I have write that price block our price, right? So this will be my ID. Okay, let me just do that. Okay, yes, you can see I got my price is 29,990. Okay, but this is a string. This is not a proper integer number or a float number. Okay, so here you can see I just slice that to, it will start from 2 to 10. I want that, and I want to take, okay, sorry. Okay, fine. So basically I want my price only, not the other tags. Okay, so in this case, I know my price is 29,990. Okay, so in that case, I want to see that, okay, fine, this is my price. If it's reduced from 2,990, then please send me a OTP for that. Okay, now you can see what I need to do. Before I go for any sending OTP or sending mail, I need to make my Google account that less secure access. Okay, otherwise your Google is going to block you for that, right? So if your mail is in high priority or your mail is in high like secure priority, that time your mail will not receive any mail from the SMTP, right? So how can you do that? In that case, what I need to go for, less secure app access. How can you check that? Okay, just write less secure app access from the website, like from Google, and if you click on that, you will get the first link. Now you need to go there and change your account respectively, right? For my case, maybe I'm going to use machine learning, this one, right? So in this case, you need to, you can see I said allow less secure apps on. So if it's off, that time you will get those, like you will not receive any mail. So now I'm going to, okay, so now I'm going to like answer the, now we will come to the SMS part, right? The emailing part. So in this case, what we need to do, we are going to use the simple main transfer protocol, that is SMTP. That is basically a protocol which handles sending email and routing email between mail servers. Okay, so Python provides SMTP lib module which define an SMTP client session, so that object can be used to send mail to any internet machine with an SMTP or ESMTP listener daemon, right? So basically we use this library in Python. Okay, so we can use this library in Python to send a automatic email to the particular user, right? So what it has host, it has port. What is host? This is a host running of SMTP server, right? The server will be in SMTP, and you can specify IP address of the host or a domain name like some other thing. and this is an optional argument, right? Suppose comes the port. So what is port? If you are providing host argument, then you need to specify a port, right? Where SMTP server is listening. Okay. So these are the basic part when you go for any sending a mail to the particular server, right? So first what we are going to do, we are going to write a function that is send mail. Okay. Now what we need to do, we need to create an object of SMTP lib, right? So SMTP lib dot SMTP, right? Then what you need to provide, you need to provide smtp.gmail.com, right? And then comma 587. This is same for all the cases. Okay. You can see that smtp lib.smtp and smtp.gmail.com and 587 number, these are in like default for all the system, right? So it will be same for all the cases. Now we are going to use server.ehlo and server.start_ttls. So these are functions we use to call a server, right? Now we are going for a server. It's not a internal server, right? So we are going for the server, normal server, Gmail server. So in that case, we need to call this function to understand that I am providing this mail ID, that machine learning dreams positive @gmail.com. This is my mail ID. Please log in this mail ID, and the password is machine learning 1234. Right? Now you need to provide the subject of your mail. So what will be your subject of the mail? I say that my mail subject will be price down. Okay. Lastly, I'm going to write a body for a particular mail. Okay. Fine. So in this case, you can see what I did. I just gave my email ID, that machine learning dreams positive @gmail.com, and I have seen the password of my email because it's going to actually access my email. Before doing anything, be sure guys, you are going to use this less secure app access, right? And you are actually making it on. Otherwise, it will not send any email to your mail ID. Okay. Now comes the body. So for my body, I am going to write that check out the Amazon product link, right? Or if you want to add something else, you can add that. Then providing the link. So basically, I am saying this is your new link. The price is down. So you can go to this link and you can buy this particular product. Okay. Now I'm going to write with that the message will become the combination of both the subject and the body, right? The subject and body. Then server.send mail. This is what you need to do. That's all. Nothing more than that. Now I provide two of my email ID, right? That Chatterjee Sampriti 21 @gmail.com and Sampriti Chatterjee 21 @gmail.com. Or if you want, you can use this as well, right? This mail. So I am going to write this mail. Okay. So this is two optional. If you want to add more, yes, you can add more as well. Okay. Now I said this too will be my mail address and send my message. Okay. And if you send the message, then please print send mail. Okay. Lastly, be sure if you use server.quit. Otherwise, the server will be still in a running position, right? So it can be the cause of crash of your website or something like that. So be sure that you use .quit function. Okay. Now, in this case, the price is not going to down for my case right now. So what I say that if that C value I already stored, you can see over here, C is equals to 29990, the price. So if C is equals to the same value, then please send a mail. Okay. So for your case, what will be the reason? It will become, if it's less than, okay, if it's less than 2990, then please send a mail. But just to show you the example that how it's working, for that I said if the price is equals to 29,990, then please send me a mail. Let me execute that. Okay. Okay. I did not execute this part. Okay. Right. Let me just execute this. Okay. So you can see it's showing me that mail is sent. So let's go to that particular email and let's see that it's in the mail or not. Okay. Okay. For my case, let me just check. Okay, you can see I got this, right? That price down and check out the, okay, yes, new message, show. Okay, so you can see that check out the Amazon product link and then it will redirect to you the, okay, fine, it's not going, yeah, then it will redirect to you the product place, right? Okay, so this is how we are actually going to make the product. If your product price is low, then it will going to give you that, okay, I'm sending you a mail, you can see the normal product price is 32,990, already it's less, right? So if it's less, more less, like maybe 27, 28,000, if it's there, then please send me a mail that I can come to that particular website and I can see that, okay, fine, this product is now, the product range is less, so I can go for buying it. So what we will do, first we are going to import our library. So we are going to use Pandas for the data manipulation, and we use AskPD as a alias, right? It's an alias for Pandas. We don't want to use Pandas every time. So in that case, we are going to use AskPD. And for the, we are going to use linear regression model, we will get from the scikit-learn library. So from scikit-learn, that is sklearn dot linear model, we are going to use linear regression. So you don't need to put logistic regression, you can just remove it. And we are going to import linear regression. We are going to use Numpy for the mathematical calculation. We are going to use Matplotlib for the data visualization, and Seaborn is also for the data visualization, right? So let me just do that, execute that. Okay, we have already downloaded. Okay, so we are going to use two data over here, that is weather.csv and cabrights.csv. You will get these two data from Kaggle itself, and I have already uploaded those data in the Dropbox for my convenience, right? But if you want to use the data, that is also available in Kaggle. Okay, so to fetch the data from the Dropbox, what we need to do, we need to use wget function, right? That's all you need to do. Your data will be fetched, and the amount of the data is big. We are going to use two data CSV, right? So the amount of the data is actually a huge data. So in that case, we are going to use a memory saving function that is also taken from Kaggle. To, you can see I have provided the link as well. So we are going to use that, will actually reduce our data size, because using a huge number of data over here, it will take a long time. As we have a time crunch in the session, we are not going to we are not able to use the full data, right? So we are going to use reduce memory uses. So we have already defined a function that is def reduce memory uses, that is taken from Kaggle as at will. Okay, so let's see how can you take the data. Already we have fetched the data from the Dropbox, right? Now what we need to do, using .csv function, we are going to store our data in a variable. So first we are going to store our data in a cap data. So our variable name is cap data, and then we are going to use pd.readcsv, and then you need to give the path of the data. For my path is content and cabrights.csv, right? And then we are going to use reduce memory uses function, which is actually going to show how much it reduced our data set. Okay, then the same thing with the weather data as well. Let me just execute that. And guys, please, getting more exciting sessions like this, please subscribe Great Learning channel, and you will get so many exciting exciting sessions from them. Okay, so let's see. So you can see our data was for the first data was 52.88 MB, and it is decreased by 15%, and now it's 44.95, right? And for our weather data was 0.38 MB, it was not that big, but it was also decreased by 43.7%, right? Now let's see what data we have. To get the first 5 rows from your data, we use .head function, right? So we already stored our cap data in cap data variable. Now I am just writing .head. It will just give me the first 5 rows of my data. So I got first 5 rows. So what we have, let's have a look at what are the columns we have, right, for cap data. So first, I told you, first you need to understand your data very well. Okay, so let's see what are the columns we have. Okay, so first we have columns like distance. What is the distance they are traveling? Cap type. What is the cap type? We are using Uber and Lyft. Lyft is basically a American based company. Okay, then we are having timestamp. What is the timestamp they are traveling? The destination and the source for like particular user. Then we are getting the price, and we get surge multiplier. We used to see some of the time in the cab application that the surge is actually, it's because of the high demand, the surge is actually added, right? So in that case, we will get the surge multiplier. We are going to get an ID for each and every entries in the data that is actually required to understand how many like distinct data you have, not the repeated data, right? And the product ID and the name, right? These are the columns we have in CapBright's data. Okay, fine. Let's see what we have in weather data. So to get the columns, we use columns function. So it will return all the column you have in your data set. In weather, we have temperature, we have location, clouds, pressure, rain, timestamp, humidity, wind, right? So basically this helps us to understand maybe in the rain, the price of the cab is maybe high, or maybe if it's the weather is fine enough, so the price will be not that high, right? So for that we are going to use these attributes over here, right? So before start the any analysis, we need to change our timestamp into date time, right? We need to have a, like, before that timestamp is a string, but if we have using string on timestamp, we are not able to get the proper date and the time from that, right? Maybe in the base of time, maybe in the base of date, the price varies, right? Maybe we don't have idea that what actually our how our attributes are related to each other. For that, we are going to use dot to date time. It's going to convert a string to the date time value, right? So we are going to use from pandas pd dot to date time, and we are going to pass the particular column in the cap data, that is timestamp. And the same thing with the weather data as well. We have a timestamp in weather data, we will convert into date time. Okay, fine. So let me just execute that. Okay, so now we are going to check the shape of the data. For the shape of the data is basically how many rows we have, how many columns we have in the data, right? So we are going to use dot shape function. Let's see. So we are having 693071 rows and 11 columns in cap data, right? So let's see for the weather data, what we have. For the weather data, we have 6276 rows and 9 columns, right? So if you want to check your data shape, you can go for using dot shape function, right? Now we are going to use dot describe. So dot describe is basically it's a basic part or the initial parts of exploratory data analysis. We use dot describe to understand the standard deviation of our data. What is the count we have in the data? How many data we have actually? We get the IQR, interquartile range, that is 25%, 50%, 70%. So these are the concepts of stats you will get, right? Okay. So fine. Let's see what actually we have for particularly cap data. So you can see for the cap data we have almost 693071. These are the total rows we have, right? So we have mean for each of the column, we have standard deviation, we have minimum, and interquartile range for 25%, 50%, and 75%, right? Okay. So for the weather data also, we are going to see the describe. So you can see count, mean, standard deviation, mean, all the things we get for weather data as well. This actually help us to understand our data more intuitively, right? If you don't understand your data, how can you do modeling, right? Okay, now as we have the two data, now we are going to use dot concat function. Dot concat function is basically used to join two data frame, you can say, right? So I have two data frame. One is cap data, one is weather data. I just want to join them. So to join them, I am going to use dot concat function. Okay, right, fine. So okay, fine. So you can see, let me just do that and just let me print it. So I'm going to use which function we are going to use to get the first 5 rows. Please let me know in the comment section so that I can understand you are actually listening to my session. Which function we use to get the first 5 rows from the data frame? Just let me know. So yes, we are going to use dot head function to get the first 5 rows from the data frame. Please guys, please be attentive. Otherwise there is no point of doing the analysis, right? You need to have an idea about these basic parts of the data. So yes, you can see I got my A. So A is basically the combination of cap data and the weather data. You can see, right? This we got. Okay, right. So now we are going to see that we are just going to make a column for day. So I just want from timestamp what's a particular day it was or what's the hour it was, right? For date time, Python provides us a function that is dot day that actually help us to get the day from the timestamp. And they actually provide hour function as well, which provides us the hour, like at what particular hour it was in the timestamp, right? So these are the actual flexibility with Python when we go for using Python, right? So you can see, yes, let's see what we have in that. So let me print a dot head, right? So what we get in the day and in the hour, right? Let's have a look at that. So let me just, okay. So for the, okay. So most of the cases it is NaN. So we need to understand that how can you solve that NaN value as well, right? So we can't go with the NaN value because it will going to affect our model, right? Okay. Okay, so when we are going to use dot tail, you can say it will give me the last 5. Okay, so last 5 column of my data set. So you can say in the day we get some of the values over here, that is day 1.0, 1.0, 1.0 and 1.0, right? So this is how we are going to use dot day function or dot hour function, right? So now as you see, there are lots of NaN values we have in our data set, right? So we cannot go with so many NaN values, right? So in that case, what we need to do, we need to use dot fill function. So dot fill function is basically give you that 0, like dot fill is basically going to fill your NaN values. So I want to fill my NaN values with 0. So I'm going to write 0 and in place equals to true, right? Okay. Right, it's going to take a little bit of time. Okay, and then we are going to see our data e dot head. So I have just shown you the basic how can you go for data manipulation, but trust me, what you need to do to go for a good data manipulation part, you need to you need to add so many things. These are the basic things, right? So you can see whatever the NaN value I used to have, it actually converted with 0. So day and hour becomes 0, 0, 0, right? So this is how you can remove NaN value from your data set. Okay. Okay. So let's see what are the columns we have in A. So we have column like distance, we have column like cap type, timestamp, destination. These are the column we have after concat your two data frames, right? Now we are going to use group by function. Why we need to use group by function? So basically group by function is going to return you the group based on the column you have provided. So I have cab type 2, right? One is Uber, one is Lyft. So I want to see how many data are from Lyft and how many data are from Uber, right? So I just, okay, I got a question from Gautam. If the columns has more null values, why can't we remove that column? Yes, we can remove that column. It's up to you. I just want to fill that nan values with 0, right? So these, everyone has their own type of handling data set. So I just don't want to lose any data, so that I use 0. I just want to fill that null values with 0. So if you want to drop those columns, you can go for it. It's up to you, right? But be sure that you are not going to lose any data. You are not going to lose any data from your data set. They are actually giving some good good part of your data, right? So be sure when you are actually working with that. Okay. So again, I got a question from Sumit. Can I get the dataset and the code? Yes, you will get the dataset and the code from Great Learning Academy. Just go for registering on the course, in the same course, and you will get all the materials over there. Okay, fine. So let's see, after group by what we will get. It I said I want to group by cab type. So I have a cab type Lyft and Uber. In that case, I am going to see how many count. I want to see dot count, right? How many data we have for Lyft, how many data we have for Uber, right? So you can see I got 307408 for Lyft, and Uber, for Uber I have 385663, right? So this is the way we are going to use group by. So group by is used for that. And I want to visualize my data. How can I just want to see a bar plot? So using bar plot, I just group by my data according to cab type. So I said a dot group by, and then I have provided the which column, right? For cab type, I want to do that. So cab type and dot count, the same, it will going to give me the count of how many cab we have for Lyft and we have for Uber. And then I'm going to plot bar plot. To plot the bar plot, what we need to do? Use dot plot and dot bar function. Then you will get the data set like this. You can see we get different color for different attributes. For distance we have blue, for timestamp we have orange. This is like this, and this is for Lyft and this is for Uber. So you can see in in the visualization, Uber is high because we have high number of data for Uber, right? Now we are going to see that price. What is the price we have, right? What is the fluctuation of price we have? For that, what we need to do? We need to specify the column. So for A, price is the column, and then dot value counts. What is the value it has? And dot plot, and I want which type of a plot? That is bar plot, right? So you can see we got it, right? It will take some time because of the data set. Yes, you can see this is the plot we got for price. This is the fluctuation we have in the price, right? Okay. And if we want to see which hour is the peak hour for the cab, right? So I want to see which hour is the peak hour. So for that, I'm going to use our column, right? Okay. So I'm going to use our column and then the value. And then again, I'm going to plot bar plot. Let me just execute that. In between that, I got some of the question that, could you please repeat group by concept? Okay. So basically, Srikanth, group by is basically if you want to group your data according to the category you have. I have two categories in my data, that is Lyft data and the Uber data, right? For Lyft data, so I just want to see how many data I have for Lyft and how many data I have for Uber, right? In that case, we are going to use group by function for that, right? Okay. So please keep coming your question, for that I can answer them and I can solve those doubts as well, right? So here I'm just going to use a dot plot function normal. So I want to see how price and hour is varies with each other, right? So I'm going to use dot plot function for that. So in the X, I took the hour. In the Y axis, I took the price. Okay. And I'm going to plot that using X dot comma Y, right? Okay. And again, I want to see if it's rain. What's the difference? What's the connection between rain and price? Again, I'm going to plot them, right? Using the same value. Okay. Right. Now we will see how can we actually make our model. Now there comes the basic interesting part. How can you make your model? So for my case, I thought maybe distance, temperature, cloud, pressure, humidity, wind, rain, day, hour, surge multiplier, and clouds. These are the, I use clouds twice, so I can remove that. Okay, so these are the main call attributes for my data to train my model, right? So in that case, I want to use these data. Okay, so this data will be my training data, and my label data will my price, right? So this is the label data, this is the supervisor for supervised learning, right? So let me just take that. Okay, so in X1 we have all the columns, and in Y we will have only the label we have for the data, right? And sklearn is basically a scikit-learn library where you can use all the machine learning that's already predefined, it's written in the from the scratch. You can just need to call the function for that, right? Okay, now we are going to use train, test, split. So this function is used basically to split your data into training part, into testing part, right? I have a data, but I just don't want to put all the data to my model, right? I want to give a specific maybe 80% of the data for training and 20% data for the testing, right? So I gave my X1 and Y1, and test size I gave 0.25. I mean 85%. Yes. So 75% of my data. 75% of my data will be test data, and 25% of my data will be 75% of my data will be test data, train data, and 25% will be my test data, right? Okay, and we use random state equals to 42 is basically just to, it will take the data randomly. Okay, now we are going to call linear regression function. So calling linear regression function, you just need to write linear regression and then the bracket. This is how you can call the linear regression function. And you need to feed, you need to actually train your model using dot feed function, and I'm going to provide xtrain and xtest data for my model to learn. You can see my model is already learned, right, from the xtrain and xtest. Xtrain contains all the attributes and xtest has the price, right? Now I'm going to see the prediction. What is the prediction for my model? Okay, fine, let's see. Okay, so let me just print it, the prediction for you guys. So this is the prediction, this is the array we got for the prediction. Let's see what is the actual and what is the predicted value, right? So for that I'm going to create a data frame, calling pd.dataFrame, and then we are going to write the name of the column, that is actual. Then we are going to provide the actual value, that is y test, and the predicted one, that is already comes under predictions, right? Now we are going to see that. So you can see actual is 42.5, predicted is showing 32.54. Our model is good but not best, right? So we can, now this comes the part of fine tuning. How can you tune your model? So here you can see I got 13.5 is the actual and the predicted is 15.51, right? And here you can see the actual is 7.5, right? And there is predicted is 10.70. So you can see our model works pretty well, but if you want to make your model more perfect, you can go for using some fine tuning techniques, right? Right, now we are going to see the visualization of how can we actually our predicted and actual value works. For that we are going to use grid function, right? And we are going to use plot. So here I said, if our model is actually, which is in the blue, they are the actual, and what are the in the orange, they are actually the predicted. So see the graph, guys, you can see this is the actual, this is the predicted. In here my model is not working pretty well, but here you can see our model is working pretty well. There is a very few difference between these two, right? So yeah, this is our actual graph according to the actual and the predictions, right? Now what we need to do, we need to import our libraries, that Pandas and Numpy. You can see we are going to use Pandas and Numpy. And we are also going to import Matplotlib for data visualization. We are going to use scikit-learn. That scikit-learn is basically we use for machine learning purpose, right? And then what we need to do, we are going to import all the scikit-learn parts. Okay. Now already you can see this is my link, right? I think you guys can see that what's the link. You can see this is the link. You guys can get the link over here. Fine. Now what I did already, I have uploaded my data. Now what I need to do, I need to go for reading those data. So reading those data using Pandas, we need to use .read CSV function, right? From there, I need to give the path of that file that contain credit card to CSV. Okay, let me just do that. So what is contains? So this data set contains 285000 rows. Okay, and we have 31 columns. In those columns, what we have, the important columns in time, amount and class. Okay, so if you want to see what's the data you have, so in that case, okay, why we use CSV file? So CSV file is basically stand for comma separated file, right? So in that case, we use to store our huge number of data. Okay, now we are going to use .head. So why we use .head? I have already explained that why we use .head function. I want answer from you guys. Thank you. I can see that you guys are saying I'm audible. So I want answer from you why we are using .head function over here. So I have already explained that why we are using .head and why we are using .tail. Right. So basically we are going to use .head to get the first 5 rows from your data set. Right. So this is our data set. You can see we have time and this many columns. Now if you want to see the shape of the data set, that how many rows and how many columns you have, you need to write .shape function. Now I am going to use .describe. What is this .describe stands for? So this .describe is basically going to give you some of the statistical measurements, right? What's the count of your data? What's the mean, median and standard deviation for your data set? Now comes the IQR, right? Interquartile range. That is for 25%, 50% and 70%. So basically this will help you to understand your data set more deeply. Weekly to view the first 6 observations from the data set, to see the first 5 observations from your data set. Head returns 5, right? If you are not right in there, not 6, not 5, it's 5. Yes, Raj, I'm going to show you if there is any missing value. How can you do that? Okay. Right. So over here you can see we are going to take the description for amount, time and class. Okay. So these are the basic main columns we have in our data set. Now if you want to see how many columns you have in your data, you can use .columns function. Okay. Now as we are talking about the unstructured data, so first we need to go for checking our data. Okay, my data is unstructured or structured, or how many null values I have in our data set. Because we all know making model with null values, that cannot give you a good prediction. So always we try to remove null values from our data set, or to replace those null values with some other 0 or nan, something like that. So to check the nan value in your data set, you need to use .isNA function, right? But why I use .any? So basically .isNA is going to give you a Boolean value. Okay. So when you're going to have a Boolean value, that time what you will get for each and every row and column, you are going to get this Boolean value. But I want to see for each and every column, if there any nan value, let me show that. Okay. So in that case, I say .any. .any is basically if you have one nan value also, it is going to give you true, right? So in that case, this is how you can check your data set. You can see for my cases, there is no nan value. So I can say my data is well prepared. I don't need to check, or I don't need to do lots of things to understand my, to change our data to use my data. But most of the cases, you have data where you will have lots of NaN values, right? So in there are lots of functions you have in Python who will help you to handle those missing values, right? I hope I cleared your doubts, right? Okay. Now what I need to say, I'm going to check the null value with a percentage. So here I just use the percentage formula over here, right? And I said, okay, is there any percentage? What's the percentage of null value I have? This is the rechecking. So you can see I have 0%. Okay. So I can say my data is good to go. Now I want to see the class. So what is class? Before going to class, we need to check some of the machine learning concepts as well. But in that case, now in my data, I want to see how many of my data transaction I have in my data set, which is fraud transaction, and how many data sets I have which are not a fraud transaction, right? Now we can like implement them in the actual data set. Okay. Let's answer me some of the question and then I will complete those. Okay. Okay, logistic regression is a supervised learning, so we do not need to have an input data labeled as false and genuine transaction. What could we do in case we do not have input data labeled? So agreed, if you don't have an input data labeled, you can go for using unsupervised learning. So if you don't have data set where this is already the data is labeled, you can go for using unsupervised learning. Okay, Shovik, but how we put the labels, classification? So basically, putting labels, you don't need to do that. Already available data you will get. And if you are going to make your own data set, then you need to write manually. Now, what I am going to do, I am going to write a for loop over here, right? So in this for loop, I said if my class, right? So if you guys can see over here, right. Let me just go up. You can see, yes, you can see there is a column called class. Okay, let me go up. Okay, so in this you can see we have a column called class. So in class, what we are going to check, this class is basically our label. That 0 is for what? 0 is for the not fraud transaction or like genuine transaction. 1 is for the fraud transaction, right? So I am going to use a simple for loop that whenever my data is equals to, my class is equals to 0, I'm going to count that and I'm going to say, okay, this is my, like the number of, I'm going to use this, you can see over here, the normal average formula that, okay, the percentage of fraud transaction, not fraud transaction in my data set or the genuine transaction. If you can see over there, you can see 99.8% data I have, that is basically a genuine data set. So I have very few data that is our actual fraud transaction, right? Now, the same thing I did for the fraud transaction as well, that I take that if my class equals to 1, then please add them. And lastly, I'm going to take the average of that. Okay. Now, what I'm going to see, you can see the fraud transaction is 0.172% for my data set. Now, I want to see a proper, like the proper graph, right? So proper graph, how can you make that? So this is something, it's going to give you a dataset visualization. So I am going to use a bar plot over here using SNS, that is Seaborn. So Seaborn is also a same like Matplotlib. You can use Matplotlib as well for like, sorry, for the bar plot. So here I use Seaborn, right? Now what I say, now I already have X axis will be my fraud transaction and Y will be my genuine transaction, right? Now I am going to plot my data and there I said the color of that palette, that is blues. If you want to use something else, you can go for doing that as well, right? Okay, now I am going to execute that. Okay, let me do that. It is going to take some time or few time. Okay, you can see. So you can see 0 and 1. Okay, so this is how I got my like bar plot. Now what I need to check, I am going to check my amount. What is the like relation between amount and time? Okay, so in that case I am going to plot that. You can see amount is this and time is in a milliseconds over here, right? This is the relation between time and amount. Now, in this graph, we are going to check the amount distribution, right? What's the amount is basically when a person is going to take a transaction. What's the normal amount? So in this distribution graph, you can see there is a very little, if you guys can see over here, right? So for the most of the cases, okay, so for the most of the cases, the amount is like very low amount, right? But here, if you can see, there is a, can I just do that? No. So here you can see there is a little graph changing, right? So this basically is saying when your amount is getting higher, there is a possibility that your transaction is a fraud transaction, right? So this is the way your graph is trying to communicate with you. So your graph is going to give you a intuitive that maybe when the amount is high, the transaction is becoming more, you can say the transaction is become more fraud. There is a chances of probability is high. Okay. Now, we see some of the outliers or anomaly detection. So in my case, I want these outliers or the anomalies, right? So this is basically when I have a huge transaction, right? Maybe this is my outlier on the analysis on the, sorry, or the anomaly in my data. But this is where I can find, okay, so when my transaction is very high and when these attributes are changing, that time maybe my transaction is a fraud transaction. So in this project, we are going to keep our outlier. You can see these are our outliers, right? You can see over here, the amount is high. The outlier, you can say, okay, they can be my, these three to are my for sure outliers. But you can see these are, can be outlier, can be like the normal genuine transaction as well, right? Fine. So, okay. So here you can see this is how we actually find our outlier. Now we came to the what? We came to the correlation matrix. But why do we need correlation matrix? So basically we need correlation matrix to understand how our each and every attributes are connected to each other, right? To get that correlation matrix, we are going to use dot core function. Okay. Now, what I need to say, I am going to provide my data. So if you can see in the data, you can see over here, if I can write over here, equals to true. It's going to be like this. Okay. No, anode will be there, I think. Okay. Let me just do that. Yes. If you can look at this, you can see the class. Okay. So you can see over here, class and V90 is quite correlated, right? And there are some time and maybe if you can see over here, time and amount, right? Time and amount is also very correlated. So this is how we can understand our correlation for the data. Now it comes the machine learning part. Now, as I said, I am going to give 80% of my data to train our model. But 20% of my data will be not seen from my model, right? This will be the new data for my model. How can I do that? In the X variable, I am going to take all the attributes except the class. And in the Y variable, I am going to take only the classes. So here you can see I have X train, X test, Y train and Y test. So I have two parts of the data. One is containing attributes, one is containing class. So I have divided them into two parts. So I will have 4 variables, right? So here I'm going to use train, test, fleets function. And there I need to provide my data, that X and Y. Here I said my test size equals to 0.2. That is means that 20% of your data. And random state equals to 42. Why do we use random state? Is basically it will take randomly data for the making, testing and training part of your data set. There is no hard and fast rule when you say, okay, I want to have a random state. So basically there is no hard and fast rule that it will take the first 80% for your training and second 20% for your testing. So it can be any data, right? Now we are going to call our logistic regression. And if I want to feed my model, to train my model, I am going to use dot feed function, and I'm going to provide X train the attributes and Y train the classes. Okay, now I am going to predict my data. How can I do that? Using ypred equals to logistic. Let's do that. Okay, so here you can see I am going to write logistic.predict function. This will help you to give the prediction. But when we are going to give the prediction, we are not going to give the label. We are going to only give the attribute. You can see X test. Now I want to see my accuracy. So in accuracy check, we use confusion matrix. Is one of the concept that when you go for checking your accuracy, you can calculate your accuracy from the confusion matrix. But here we have a direct function called accuracy, where you will get the direct accuracy for your model. You can see my model is working with 99.85%. So we can say my model is working quite fine, right? So you can use this model. You can use some other testing data set as well, and then you can deploy your model. So your model is ready to deploy. All right. So now we are going to do the recommendation, basically a movie recommendation system using machine learning. So already I got my data from Kaggle and I have uploaded them to Dropbox. So I have two data set. One is ratings.csv, one is movies.csv data set. So all the data set you will get in the Kaggle itself. Otherwise, you will get the notebook as well, and you don't need to go for downloading the data. Directly, it will fetch the data from Dropbox. So I have used wget function. So it will directly, and I need to give the path of the data set, right? So from that, it will directly fetch the data set from the Dropbox. So let me just execute that. Okay, now you can see, I just want to see my ratings.csv, what we have in our data set, right? So in that, we are going to use Pandas data frame. This is a library of Python. Well, like using Python, using Pandas, you can go for many data mining course, like data mining techniques. So Pandas is one of the most popular library in Python, you can say. Okay, so in that case, we are going to use read CSV function to read ratings.csv, right? So I got a question from Nikhil. This coding is done in Jupyter Notebook. Yeah, you can do the same thing in Jupyter Notebook as well. For me, it's quite handy to use Google Colab. So it's up to you which ID you want to go for, right? So you can see, I'm going to just store in ratings detail variable to the ratings CSV file, right? So you can see I use .head function. It will return the first 5 rows of your data. So I got user ID, movie ID, rating, and timestamp. Okay. So I have the movie ID. I have rating, that how much rating the user gave, and the user ID for the respective user, right? So now I am going to take the movies.csv from the Dropbox itself. So it will fetch the data same way. Yes, you can see it's already fetched the data. Now I will do the same thing. So I am going to use movie details in the variable name, and I will store the movies.csv on that variable. And with the head, I will get the first 5 row from that. So I have movie ID, I have title, I have genres for each of the movies, right? Now I'm going to, as I have the both data, let's have a look at what are the shape we have for each of the data set. So I have ratings.csv already in the ratings details, right? So if you want to see the shape of the data set, what you will do, you just need to write .shape function, right? Yes. So you can see I have 100836 columns and 4 rows. Okay. So I got a question from Ria. Can you please explain wget method? So we use wget to fetch a data from any, suppose you have a link, the data link. So we use wget to fetch that data from that link. It will directly fetch that. It's a command line command, you can say. Okay, so I got a question from Ankit. What is the use of Panda? So Panda is basically used for data mining techniques. If you want to manipulate your data, if you want to clean your data, or if you want to learn your data easily, you can go for Panda. So Panda is one of the most important library in Python, right? Okay. Now let's see. We already got the shape of the rating details, and we just want to see the shape of the movie details, right? Yes. So yes, we have 9742 columns and 9742 rows and 3 columns, right? Okay. So this is the shape of our data set, and now we are going to use dot describe function to have a good understanding of our data. Okay, so dot describe is basically will return you all the basic statistic part of your data, right? So dot describe, yes, you can see I got this, and if I want to see this in a data frame, that is also available. Yeah, so I got count, the mean for each of the column, standard deviation for each of the column, 25%, 25 percentile, 50 percentile, 75 percentile, and the max. We got these are the basic statistic for our state data set, right? Now we are going to see the same for the movie data set. Okay, so if you want to add some new code in your notebook, you just need to click on the plus sign on the Google Colab, right? So movies, we have movies details dot describe. Okay, so I got an error. Okay, it's movie details, right? Okay, I got a question from Prashant that from where we get this data which you are using. You will get this data from Kaggle, Prashant. You don't need to go for any other well. We all use the data from the Kaggle. Okay. From Gulam Murtaja, yes. Can you give this data set? Yeah, you will get the data set. You just need to go to Great Learning Academy and you just need to go for registering the same course, and you will get all the presentation and the notebook as well. That is also free of cost. Yes. So yeah, we see the describe for the movies details as well. So we have a movie ID and we have this. You can see, right? These are the describe we already got for this. Okay. Okay, so yeah, let me just execute this once. Okay, so yes, now we are going to merge the data set. We have the ratings, we have the movie details. Now we are want to use merge the data set, two data set. But how can you merge that? To merging the data set, you need to go for dot merge function. We use Pandas dot merge function to merge two different CSV file, right? So we have ratings details, we have movie details, right? But we want to merge those two data sets on the basis of which column, right? So on the basis of movie ID, we want to actually merge those. We want to concat, you can say, we want to actually merge those data set, right? So basis of movie ID. So movie ID will be our basic primary key for this data set when we are going to merge them, right? Okay. So yes, you can see we got, so if you want to get the last 5 rows from your data set, we are going to use dot tail function for that, right? So basically to get the last 5 rows of your data set, you actually need to use dot tail, and getting the first 5 rows from your data set, you need to use dot head, right? Okay, so already we have merged our data, right? We have in our data set, we have user ID, we have movie ID, we have rating, we have timestamp, we have the title of the movie, and we have the genres of the movie, right? Now what we need to do, we just need to change our timestamp into the proper date time. So how can you do that? So doing that, we need to use date time function or date time library, and we can just say that pd dot, that is also part of pandas, pd dot to date time, and you need to provide the data set of the which column you need to change. So I want to change my timestamp column to the date time, right? So I'm providing that data set of timestamp column, right? Okay, so let me just execute that. Okay, now let's see what we have in the data, like what is the shape now we have in our data set, right? So as we merge our data, we actually add a one date time column as well. So now we have almost 100836 like rows and 7 columns. Okay. So I got a question from Prashant that when do we use scikit-learn in this scenario? Basically, scikit-learn we use to split our data set to make the model from the, like the make model and machine learning. That's all the predefined algorithm is there in scikit-learn. Okay. Fine. Okay. Avinash is asking why can't we use concatenate? So yeah, if you want, you can use concatenate. I use merge function. It's up to you which one you want to go for. Okay, fine. So let's see. Now we want to see what are the non-unique. What are the actually using n unique. So it will actually return you how many unique data you have. Maybe we have the same user for just to rate the different movie or for that, right? Just I want to see how many unique customers we have in our data set, right? So let me just use, and for that we use dot n unique function, right? So you can see for user ID I have 610, for movie ID I have 9724, but our data is more than that, so we have repetitive data as well. So maybe a one user can see lots of movies, so they are going to rate for that movies as well, right? Okay, so let's see the describe of the dataset, merge dataset. What we have for the count, we have 100836. We see that we have mean value, standard deviation 25 percentile and 50 percentile and 75 percentile, right? Now what we need to do, now this data manipulation part came, right? So now what we need to do, we need to group by our data to see the average rating for each movie. Now I want to see, suppose I have Joker movie, right? I want to see what is the average rating we have in our data set for that particular movie. So how can you do that? So I actually take a variable. In that variable I have stored our full data set. Now I want to group by my data. So a dot group by function is used to group your data according to the column. Suppose I have a title of Joker, right? So in the title I have Joker. So what it will do, it will actually group all the ratings and all the data we have according to Joker, and it will do same for the each and every title I have, right? So this is why we use group by function. Okay, fine. So in that case, you can see I'm going to provide title and rating. I want to see title like first Joker and then the rating, how many rating it has, and then I want to take a mean of that just to get the average, in order to get the average for that particular movie, right? So you can see I already got that. For title Hellboy, I got 4 rating, right? For XXX2002, for that I got 2.77 ratings, right? So this is how you will get the average rating for each and every like movie we have in the data set, right? Now we are going to see the short, we are going to short our data set, right? So we are going to see how many movies has actually 5, how many movies has 4, how many movies has 3. We want to just short our data set in a descending order, right? It will start from 5, 4, 3, 2, 1. Okay, so to get the data set in the, like sorting the data set in a descending order, in order to, what you need to do, you just need to write ascending equals to false, right? This is how you will get the descending order data, right? So let's see. Yeah, so already it's stored in sorted ratings wise movie. Okay, so let's see what we will get. Yeah, we get like Curlson returns is 5, and the Beast of Hollow Mountain is 0.5, right? So you can see we already got the data, which is actually in a, like the first 5 we got the 5 ratings data. Now we got the less, right? This is how the descending order works. Okay, now we are going to see the total number of rating for a particular movie. for a particular movie, how many numbers of rating we have. Maybe some of the movie is actually getting a high ratings, but the rating of the rating of the customer is not high, right? Suppose a movie is rated by a customers, like 10 customer, they rated 4, right? And one movie is rated by 2 customers 5. So obviously the movie rating for that two movie will be high, right? So for that we need to check what is the count of the users we have for each and every movies. Okay, for that we are going to use the same technique, dot group by. Okay, we are going to use the dot group by, and then we are going to group by title and the rating. Okay, and we are going to use dot count function for that. Okay, so you can see for XSS 2002 we got 24, for State of Union we got 5, for existence we got 22, right? So I just get the last 5 rows of my data set, but for all the movies it's actually giving me the rating, how many ratings it has particularly, right? Now we are going to make a new data frame, right, where we will have the average rating, we will have the title of the movie, and we will have the count of the total rating. It will actually help us to analyze our data more easily. So in that case we are going to make new record. I got a question from Avinash. Can we use print A in group by syntax? I didn't get you. Can you just more explain it? Like, can you give more explanation on that? I didn't get your answer. Okay. Okay, fine. So I got a question from Likhit that shouldn't we use mode here instead of mean? So maybe it's something like up to you. If you want to use mode function just to understand your data, yeah, you can go for it. So I use mean for that. Okay. Okay. So now we are going to see how can you make a new data frame. To making a new data frame, we just need to call pd.data frame. Okay, pd.data frame, that how you can call a new data frame. And the new column of my the new data frame has a column called average rating, right? So I want a column average rating, and I'm going to provide the A has the all the average rating for each of the movies, right? So let me do that. Okay, and for the new record data frame, I'm going to again add the count of total ratings, right? So in this data frame, I will have 3 columns, right? One is title, one is average rating, one is count of total ratings, right? So let's see our new data frame. Yes, we got title, we have got average rating, and we have count of total ratings, right? So for 712104, I got ratings of 4.0. For around midnight we got rating for 3.5, right? And count of total rating is 2, this is 1, right? We have in our data set. Now what we need to do, we just want to see and we just want to visualize our data. For that we are going to use Matplotlib library. Okay? So we are going to use Matplotlib library and the Seaborn library both. Okay, fine. So in that case, first let's see what are the columns we have. So you can see I got a column for average rating and the count of total rating, but where this title goes, the title is basically the part of index. Your index is titles, right? Now I want to see what is the graph of my count of total ratings. So let me just, okay. So from the output, you can see the most of the movies has received less than 50 ratings, right? Most of the ratings like less than 50. While the number of movies having more than 100 rating is very low. I mean, more than hundreds we even can see them, but more than 50 is also very less, right? So this is how you can judge your data. So 0, 1, 2 are more. You can see these are the more, right? Almost 6,000 data are almost 0, 1, under 0, 1. And 50 and you can see 30, 40, maybe it can be under 30, 40. These are also more, but more than 50 is very less. So maybe for that you can use more like a big data set. I'm not using a big data set. So if you want, you can use a big data set for that to just to get a proper like efficient model, right? Okay. So now I'm going to see the average rating. I want to see a histogram of the average rating. To get the histogram, what we need to do, we need to use .hist function. Okay, the .hist function actually return us the histogram for that. So I use the average rating column, and I am going to use dot his function for that. Let's see what we will get. So you can see this graph. For we have the integer value have a taller burst than the floating values. Since the most of the user assigns rating as an integer value, that is 1, 2, 3, 4, or 5. And furthermore, it is evident that the data has a weak normal distribution. So using this data visualization part, you can understand your data more efficiently. You can say your data is weak in the normal distributions, right? With the mean of around 3.5, and there are few outliers we have in our data. So if you want to remove those outliers in your data, you can do that, because when you actually remove your outliers from the data, your model will start performing very well, right? So it's actually data visualization is one of the most important part in your when you are going to build a model, right? So yes, from the graph itself, it will start saying so many things to you. Okay, so yeah, so you can see, like, I'm going to plot one more thing, that is using joint plot, that is the part of Seaborn library. So for the X, I'm going to use average rating, and for the Y, I'm going to use count ratings, right? So let's see. Yeah, so we got this graph. So this graph actually shows that the general movies with higher average ratings actually have more number of ratings, okay, compared with the movies that have lower average ratings. So from that, you can see this is actually saying the same thing. The movies with the high average ratings actually have more number of ratings, and the compared with the movies that have lower average rating, like suppose a movie is actually getting 1, right? So in that case, you can see the number of ratings is less for that movie. So you can see in this count of total ratings and the average ratings, right? Okay, fine. So now we are going to use actually how can you make your recommendation system. So in before this part, we are actually understanding our data, what actually our data wants to tell us, what actually the spread of our data set, right? So now I am going to show you, we are going to use dot pivot table, right? In that pivot table, we are going to use user ID, title, and the rating. Okay, and what we are going to do, we are going to check all the columns and the head as well. So first, let me just print that. You will guys get that what we have in movie matrix. So you can see in the columns, we get all the movie name, right? We make a pivot table where the column is actually with the movie names, right? So you can see, I am going to again execute that. Yes. So we have the columns, right? We have the columns. Now what we need to do, we actually need to take that XXX2002, right? So we are going to use the movie name XXX2002, where actually you will get all the ratings and the average ratings for XXX2002, right? So we are going to check what are the similar movies we have like XXX2002, right? Okay, so yes, for that, I'm going to take all the ratings from movie matrix to XXX2002 ratings variable. Okay, just now let me check what we get in that. Yes, we get that 3.5, 2.0, the ratings we have for each users they have given, right? Now we are going to find the similarity. What are the similarity we have for other movies like XXX2002? So checking the similarity, we use dot core with function. It actually give us the correlation with the same movies we are actually passing to it. So in that case, we are using XXX2002, right? So it's going to give me that what is the similar movies we have in this data, in this movie list, right? Okay, so let me just execute that. Yes, you can see we got that Hellboy, and these are the actually correlated movie we got. That is, you can see State of Union, and yeah, and you can see XXX2002 is actually getting the most correlation. Like correlation is 1. Suppose correlation with 1 with the similar one is always 1, right? So you can see that XXX2002 we get the correlation is 1. So this is how you can see actually it is working perfectly when you are going for checking the correlation of the particular movie with the other one, right? So here we are going to use the heat map just to check the correlation in a visualized way, right? So here we are using Matplotlib for that. You can see all this are 1 1 1. Suppose rating के साथ rating is always 1, right? And user ID with user ID is always 1. This is how we actually calculate all the correlations. Okay, right. Now we will see what is the correlation we got in a data frame. Okay, so here we are going to pass our movies similar to XSS 2002 and we are going to use a correlation column for that. And we want to drop all the nan value from the data frame, right? To dropping all the nan value from the data frame, we use drop in a function, right? So you can see XSS 2002 correlation dot drop in in place equals to 2. So let's see. Yes, you can see 500 days of summer has a correlation with the XSS 2002 that is 0.83, right? And 10 items or less 2016 has a correlation of 1. So this can be the next recommended movie for the particular user who have actually watched XXX 2002, right? And maybe the next one can be 500 days of summer. Okay, so we actually got I actually print the head. So if I'm not going to print the head, if I'm going to print the whole part, so let's see. Yeah, you can see some of them have the minus as well. So there is the meaning of minus is basically there is no correlation between that two language.
So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be Numpy because we would want to create our data with this Numpy library. Then we would import this pyplot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import pyplot as PLT and the alias which I'm giving for pyplot is PLT. Then I'll create two NumPy arrays over here. The first NumPy array will be X and I'm creating this NumPy array with the help of this np.arange method and the range will be from 1 to 10. And then I'll create the next NumPy array which is basically 2 times of X. So all I have to do is multiply X with 2 and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6 and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this pyplot module. So this takes in two parameters which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create a first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as plt. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have X and this I'll be creating with np.arange and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out X for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create Y, Y will just be 2 times of X. So here I'll have 2 into X and then let me print out Y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in X. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in two parameters, which are x and y. So this data would be plotted onto the x-axis. This data would be plotted onto the y-axis. And I'll just show this as a result. So as you guys see, we have this object x mapped on the x-axis, this object y mapped on the y-axis, and this is the corresponding line plot. Now that we have created this, we can also add the title, X label and Y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add X label and Y label by using these two methods. And as you guys see, we have added these two labels over here. So let me add the title, X label and Y label, plt. So I'll copy this entire code over here and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title and I'll just give the title as first line plot. Then I'll have X label. So here I'll have plt.x label, and here I'll give the X label as x-axis. Then I would have the Y label, so plt.y label, and inside this I'll give the Y label as y-axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the X and Y-axis labels. Now with the help of these three methods, we have added the title, the X-axis label and the Y-axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color. And as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default, also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot, and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here, and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line, and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10. But I'll have 2 y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make 2 plots because I'd want 2 line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which you are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again, we have the title, X label and Y label. And we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here. But when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between X and Y2. And this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have X. Now let me just print out X for you guys over here. These are all of the numbers which are present in X. Now Y1, I'll set it as 2 times of X, and then I'll have Y2, which will be equal to 3 times of X. So I have Y1 and Y2 ready. Now after this, I would have to make a plot between X and Y1. So I'll have plt.plot, and onto the X-axis, I'll obviously have X. Then onto the Y-axis, I'll have Y1. And the color for the first line, I'll have green. And let's say the line width, I'll set this to be equal to 2. Then I'll have the next line, which will be between X and Y2. So here I'll just write down X comma Y2. And for this line, I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it'll be plt.show, and I would also want a grid over here. So before this, I'll set plt.grid, and I will set this to be equal to true. Let's hit run. And as you guys see, I have 2 lines in the same plot. Now in the earlier example, we had 2 lines in the same plot. But if we actually want 2 subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have X, Y1 and Y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have 2 plots over here. And those 2 plots would be present in this way. So I'll have 1 row, 2 columns. As you guys see, I have 1 row and 2 columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between X and Y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between X and Y1. Then we'll have plt.subplot, which is our next subplot, and the first 2 parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between X and Y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have X, Y1 and Y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between X and Y1, and I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot, and the first two parameters will be 1 and 2 because I'd want these two plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2, and over here I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between x and y1, and the color of this line is yellow. The next subplot is between x and y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys. And I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names, and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now, the plot which we had created earlier was very bland, and we can go ahead and add the title, X label and Y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the X label and the Y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names and the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now, after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar. And we are adding a color as well. So by default, we had the blue color. And if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis we'll have names. Let me change this to names. And as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we'll head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities. And these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in X, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have Y, and in Y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x, y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same X and A. These are the same list which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot, where we had two lines in the same graph, we can perform a similar sort of thing over here, where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters. And since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1, and the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. A categorical column, but when it comes to a histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv, since this is a CSV file. So inside read_csv, I am passing in the name of the file, and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now, after that, to create the histogram, we'll just use plt.hist, and inside this, So here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column and I'll set the number of bins and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now, in the while it is loaded, I'll go ahead and write in the head method as well. Now, if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal width, and the species column. And now, I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small. It'll be petal length. And I'll set the number of bins to be equal to, let's say, 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list. The minimum value will be 4. The maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1. And inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly give in 9 numbers. And again, I'll have L3. And also in L3, I'll just randomly give in some numbers over here. Now, once we have L1, L2 and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2 and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these three box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the violin plot. So the only difference is to create a violin plot, we'll be using violin plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.violinplot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have two lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie, and here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show out the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create two lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. The third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples. I've got 43 mangoes. I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to give in the categorical object. So I'm mapping fruit onto the labels. Then I would just have to show out this pie chart. So plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here For this auto PCT attribute, I am using 0.1f. Now, what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here I'll have to use %0.1f. Let me add %%. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now, when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute. And it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entities. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5. It is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4. The radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually. And let me keep this as 1. And this is the resultant donut chart. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset. and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need pipeline. So I'll have from Matplotlib import pyplot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have sns.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI. And let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present. And I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. sns.line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event, and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2. and when it came to Q, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal Q, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of Q event is much higher when compared to the increase of the stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the Q event is being represented with this dotted line, and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the Q event, the markers are crosses. So that was all about line plot with the help of the Seaborn library. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as PD. Now, once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this, I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this is legendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this is legendary column and then the speed column. So I'll be using SNS dot bar plot, and onto the x-axis I would have to map is legendary, and then onto the y-axis I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon data set. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between is legendary column and weight in kg column. So is legendary column is again mapped onto the x-axis. It's just that here for the y-axis, we are mapping weight kg column. And this time it is very, very obvious that legendary Pokemons, their weight is much, much higher when compared to non-legendary Pokemons. I'll cut this out. I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column. And we already know to do that, we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this, I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary. This denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much, much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plot is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette. And we can directly use different predefined palettes. So first we have the Blues D palette with a capital B. This is how it looks like. Then we have the Rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is Blues D. And as you guys see, this is the Blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the Rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between two numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up, then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add 2 more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis, and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital. And when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column. And you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses. And for Virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head. And these are the different columns which are present. So I've got caret, which obviously tells us about the caret of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters. And Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot. And since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.distplot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt.show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute, and add this. So this was the distribution plot which we had created. And to this, if I want to add color, I'll use this color attribute. I'll assign it red. And you would see that I have assigned it the red color. Now, if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set his to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10, and I'm just setting the color to be equal to green. I'll select this over here, I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now, if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50. And as you guys see, I have only 50 bins. Now, let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now, let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now, we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here. And here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now, I'll have to use sns.jointplot, and onto the x-axis, I'll be mapping sepal.length, and onto the y-axis, I'll have to map something. So onto the y-axis, I'll be mapping petal.length. And that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, That is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Once I have done this, let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company. And on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, and then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column, which would go on the y-axis, and this churn column, which would go on the x-axis. SNS.boxplot, and onto the x-axis, I'd have to map obviously the tenure column. Onto the y-axis, I am mapping the churn column. Then I'd have to use the data, which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go onto the y-axis and churn will go onto the x-axis. Now we get this box plot, and we've already seen the inference. It seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these 3 different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have, or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these 2 boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here. but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service, and this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have three different types of contracts: month-to-month contract, 1 year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order. And inside this, I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here, I'll remove the line width, and instead of line width, I'll use this attribute called as order. And first, I'll have 2 year. After that, I'll have month to month. Then finally, I'll have the last box, which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here, I'll add this attribute called as hue. And I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories. So we have an interesting case study now. We have a IPL data set, and we'll be thoroughly analyzing this IPL data set with the help of the Pandas library and the visualization library, which is Matplotlib. So our first task would be to import all of the required libraries. So what we'll do is we'll go ahead and type in import pandas as PD. PD is the alias for pandas. Then we'll also go ahead and import the pyplot submodule from the matplotlib module. So here we'll have from matplotlib import pyplot as plt, and plt is the alias which we are giving for pyplot. And finally, we'll also include one more visualization library, which is Seaborn, and that is why we will have import Seaborn as SNS. Let me just go ahead and click on run, and let's wait for all of these libraries to be loaded. So it'll take a bit of time. So these are the three important libraries which we'll be needing to thoroughly analyze this data set. So now that we have loaded all of the required libraries, we would have to load the CSV file. And we have the CSV file called as matches.csv, which has all of the details of the different IPL matches. And we already know that to load a CSV file, we would need to use pd.read_csv. And inside this, we will given the name of the file, which is matches.csv. And that we will store in this object called as IPL. So now that we have loaded this matches.csv file and we have stored it into the IPL object, let me go ahead and have a glance at the head of this data frame. So I'll have IPL.head, and we also know that the head method gives us the first 5 records of any data frame. So if you see over here, I have 1, 2, 3, 4, and 5. So these are the 5 records, or the first 5 records from this IPL data frame. So let's just look at the different columns which are present in this data frame. We have the ID column, which would tell about the unique match ID. So here each record represents one unique match, or one match which was played between different teams. So here, as you see, the match ID is 1, and this match ID 1 represents that particular match in 2017 between Sunrisers Hyderabad and Royal Challengers Bangalore. Then we have match ID 2, which would represent the match between Rising Pune Supergiants and Mumbai Indians. So this is how, or this is what the ID column tells you. Then we have the season column, which would tell you in which season or in which year this match had been organized or this match was played. So as you see over here, the first 5 records, these represent the matches which were played in the year 2017. Then you have the city over here, in which city was the match played in. So this match between Sunrisers Hyderabad and Royal Challengers Bangalore was played in Hyderabad. Then you have the date column over here, and the date tells you the exact date on which this particular match was played. So this match was played on, you have 2017-04-05. So this would be 5th of April 2017. So team 1, team 2, this just indicates who were the, or what were the two teams playing against each other. Then you have the toss winner. Which team had won the toss? So between these two teams, Royal Challengers had won the toss. And after winning the toss, what did the team decide to do? So here you have the toss decision column. And this column tells you that after winning the toss, Royal Challengers Bangalore had decided to field. Then you have the result column. So in result column, we have 3 categories, and those 3 categories will look at them later on. Then you have DL_applied. This DL_applied tells you if the Duckworth-Lewis method was applied or not. And Duckworth-Lewis method would obviously only be applied if there was rainfall. After that, we have the winner column, which tells us which team has won the match. So this match between Royal Challengers Bangalore and Sunrisers Hyderabad, this match was won by Sunrisers Hyderabad. Then you have win by runs and win by wickets. So this column over here tells us that since Sunrisers Hyderabad had batted first, they have won by 35 runs. Over here, you have the win by wickets column. Now, you'd have to understand this interesting thing over here. So, if a team bats first and wins the match, then it will be winning by a certain number of runs. But on the other hand, if the team batting second wins the match, then it will be winning by a certain number of wickets. So here, since the team batting first has won the match, that is why you have a value in this column and you don't have a value in this particular column over here. Let me give another example to make you understand it better. So let's say the team batting first has scored 100 runs and the team batting second was all out on a score of 75. Then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column. Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit sixes on a well, was the man of the match. Then you have the venue over here. And this match was played at Rajiv Gandhi International Stadium, Uppal. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636, 18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method. And that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL. And inside parenthesis, I will give in the name of the column, which is player of match. After that, I will give in the dot operator. And then finally, I will use value counts method. And this will give me the frequency. So here, as you see, Chris Gale, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 man of the match awards. After that, you've got AB de Villiers, who's got 15 man of the match awards. And you have David Warner, who's got 15 man of the match awards, and so on. Now, from this list, I would want to get only the top 10 players with most man of the match awards. So here, the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis, I will give in 0:10, which will give me the 10 players with most man of the match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gale, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most man of the match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most man of the match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most man of the match awards. Going ahead, what I'd want to do is I would want to make a bar plot for the top 5 players with most man of the match awards. And if I would want to make a bar plot, obviously I would have to use the Matplotlib library. So I have already imported the pyplot submodule from the Matplotlib library and have given it an alias of plt. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this, I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, we would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of or the result or the number of man of the match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator. Then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken the categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of man of the match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner, and Rohit Sharma. Now, we have the result column over here. So I would want to know the frequency or the different categories of this result column. And if I would want to know the frequency, again, what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame, and inside parenthesis, I will give in the name of the column. So here the name of the column is result, and I will use the value counts method when I click on run. As you see over here, I have 3 categories: normal, tie, and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the 3 different categories which we have. And out of all of these matches, most of the matches have been done normally, and there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here, which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that, you have RCB with 70 and so on. Now, I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match, which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here, between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Supergiants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization, and I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7x7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object, and I'll give in parenthesis and given the name of the column, which is win by runs. And I'll have plt.show. So here, this is interesting as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here. So this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very, very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xLabel and I'll just write down runs over here. And as you see, the X label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I'd want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first. But then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times, there's a difference of 14 times over here, or 14 wins over here, and that's a huge disparity. Now, what I want to do is, I want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'd have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size and I'll set the dimensions to be equal to 7,7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that, I will give in the keys method. And this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner value counts 0 to 3. And I'm setting colors for, or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference. But here, this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.pie. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7,7. And since I would want to make a pie chart, I will have plt.pie and over here. So the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities, and the second parameter we will give in the categorical values. So the first parameter will have batting first winner dot value counts. The second parameter is batting first winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f%%, which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8% and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now, similarly, I would want to look at those teams who have performed well after batting second. Now, for this, we have already seen this. So if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is, the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.his. And inside this, I will just pass in the win by wickets column. And I am setting the number of wins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this bin over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe let's say only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very, very few chances for the team to win the match after that. And also, if you look at this, there have been very, very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now, after this, again, I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really, really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind, you have Mumbai Indians who have won 44 matches batting second. Then you have Royal Challengers Bangalore, also close behind, who have won 42 matches. Then you have Delhi Daredevils who have won 41 matches after batting second. Now, similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7. Then I'll have plt.bar over here. Over here, the first parameter, I would have to set, or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians, and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys, since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green. And for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore. And for RCB, I will give in a red color over here, so that this represents their jersey color. And as you see, I have changed the color. The Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color. And Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams. And that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.py. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4%, and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here, in 2010, 14, and 16, we had exactly 60 matches played. So this is something which again is interesting. The most number of matches were played in 2013 and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that, you have Kolkata with 61. And now, I would want to do something interesting again. I'd want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the Numpy library, import Numpy as np. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now, after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here, match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. And this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls, David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match1. And let me have a glance at the first 5 records of this data frame. And thus we have already seen and I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side, and 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, from this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsmen. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours. We have 9 sixes. There were 9 couples as well. And there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen of the SRH team, and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to match 1, inning is equal to 2, and this I will store in this object called as RCB. Now, once that is done, I would want to know the different number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 622, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught. 2 of them have been bowled, and there were 2 runouts.
So here we have the FIFA 20 dataset, and we'll be performing exploratory data analysis on top of this dataset. And now we would have to import all of the required libraries. So we are importing Pandas for data manipulation, obviously. Then we have Matplotlib and Seaborn. So Matplotlib is a library which is used for data visualization. Seaborn is also a library which is used for data visualization. So Seaborn you can consider as it's an extension of Matplotlib. Extension in the sense that Seaborn is built on top of Matplotlib. So these are the 3 libraries which I would need. And what I'll do is I'll actually restart the kernel so that you're not able to see the output initially. So for you, it will be much more easier to understand. Now I'll hit on run and let's wait for these libraries to load. All right, so we have loaded the required libraries. Then going ahead, we have this file called as players20.csv. So this is a file which I have already loaded in Jupyter Notebook. And to read a CSV file, we would need this method called as read underscore CSV, and this method read underscore CSV is a part of the Pandas library. So here, since I have loaded Pandas, so I'll write down pd.read underscore CSV, and inside this, I will give in the name of the file, which is players20.csv, and I will go ahead and store it in this object called as FIFA. And I'll just hit on run. Now, if I would want to have a glance at the first 5 records which are there, so I need to use the head method. So by default, this head method gives you the first 5 records which are there in this data frame. So FIFA.head. And here you would see that you have all of the different columns. So you have the FIFA ID, you have the player URL. So if you'd, this is a column which just gives you the home page or the description of this player over here. Then you have the short name of this player. So here you have El Messi, obviously Messi. Long name is Lionel Messi. You have Cristiano Ronaldo, and you have Cristiano Ronaldo's long name. You have Neymar, you have Oblak, you have Eden Hazard. And here this column obviously tells you the age of this person. Here you have the date of birth. Then you have the height in centimeters of this player and the weight in kilograms of this player. Then you have the nationality. So Messi is obviously from Argentina. Ronaldo, we all know, is from Portugal. Neymar is from Brazil. Eden Hazard is from Belgium. And these are the clubs for which these folks play. Cristiano Ronaldo, he plays for Juventus. Messi plays for Barcelona. Neymar plays for PSG. Eden Hazard plays for Real Madrid. Then you've got all of these different stats over here. So for now, we'll just leave out those stats. So let's actually see how many columns are present in this particular data frame right now. So what we'll do is, I will start a for loop, and I would want to know all of the columns which are present. So what I'll write down is for call in FIFA.columns, and I will print out each of the column which is present in this entire data frame. So for call in FIFA.column, so what will happen is it will iterate from the first column. So it will start from this first column and it will go to the last column over here, and we are printing all of the columns which are present over here. So for call in FIFA.columns, print of call, when I hit on run, you would see that these are all of the columns which are present. You have FIFA ID, player URL, short name, long name, age, date of birth, height in centimeters, weight in kg, and so on. So you have a lot of columns over here. Now I'd want to know how many records are there and how many columns are actually present in this data frame. So for that purpose, I will use this shape method. I'll write down FIFA.shape and I will hit on run. And you would see that there are 18,278 records and 104 columns. So this is actually a huge data set. So, I mean, for performing a simple case study. So here, 18,278 records would mean that you have a list of 18,278 players in this entire data frame, and 104 columns are just the different features with all of these different players. So we've looked at the shape, and there is this column called as nationality in our data frame. So here, if you go up, you would see that there's this nationality column, and I would want to see how many players belong to which particular country over here. So since nationality is a categorical column, and if I'd want to understand more about a categorical column, I can use the value counts method. The value counts method gives me a frequency count of the different categories which are present. So what I'll do over here is, first I'll give in the name of the data frame, which is FIFA. Then inside the parenthesis, I'll give in the name of the column, which is nationality. Then I'll use the dot operator and use the value counts method. And when I run this, this is what I get. So you see that in this particular data frame, most of the players are from England. So you have 1,667 players from England. Then you have 1,216 players from Germany. And you have 1,035 players from Spain. Then you have 984 players from France. Then followed by 886 players in Argentina. So this basically tells you that in this data set, you have a lot of players from England, and that could also be a reason because you have more number of clubs participating in the English Premier League. So you also have all of these relegation zones. So you have tier 1 clubs, you have tier 2 clubs, you have tier 3 clubs. So maybe this data frame comprises of all of the players belonging to tier 1, tier 2, as well as tier 3. And that could tell you why, why there are more number of players belonging to England. Then, so let's say from this entire result, if I would only want to have a glance at the first 10 records or the top 10 countries where most of the players belong to, what I'll do is I'll write down FIFA nationality dot value counts. And again, I'll just give in 0 to 10 inside this. And when I hit on run, you would see that. So most of the players belong to these 10 countries over here. Again, at the top, you have England, Germany, and Spain. Then let's say instead of top 10, if I would only want to have a glance at the top 5. So over here, I'll write down 0:5. And you would see that I have these 5 countries. I have England, Germany, Spain, France, and Argentina. Now, I would want to make a bar plot for these top 5 countries where most of the players come from. So, if I would want to make a bar plot, I would need to use this library called as Matplotlib. And we have seen that we have imported the submodule, which is pyplot, and we have given it an alias of plt. So here, first I need to set the figure size. So as you see, I'm setting the figure size over here, plt.figure, and inside this fig size is a parameter inside this method. And using this parameter, I set the dimensions of the image. And as you see, I set the dimensions to be equal to 8,5. Now, once I set the dimensions, then I go ahead and create the bar plot using plt.bar. And when I write down plt.bar, you have all of these different parameters over here. So when we are creating a bar plot, the first parameter which we give inside it should be the categorical values. Now, after that, what we do is we give in the numerical entries over here. So what we do is first, if we say categorical entries, these are the categorical values over here. Now, if I only use dot value counts method, that gives me these categorical values along with these numerical values. But what if I only want the categorical values, only the names of the countries? So in that case, what I can do is I can use the keys method. So here, as you see, till here, the command is the same. FIFA nationality dot value count 0 to 5. Then I am using the dot keys method over here, and I will hit on run, and you would see that I am able to extract the names of these top 5 countries without the values. And since I need to pass in categories as my first parameter, this code is what I'm passing in as the first parameter over here. Then going ahead, the next value is the same command without the keys method. Then going ahead, I have another parameter called as color, and I set the color to be equal to green. So G is, again, it's just a short form for the green color. So I have first passed in the categorical entries, then I've passed in the numerical entries, then I have passed in the color over here. Then I hit on run. So here you see that this is the bar plot which we have created, and it's pretty evident, isn't it? This is what we saw in the list as well. So most of the players, they are from England. Then you have around 1200 odd players from Germany. Then you have 1000 odd players from Spain. Then you have France and Argentina falling behind. So right now we have looked at the nationality column. Now we will go ahead and do some more analysis. So we have the wage in euro column. Now I'll just show you if we can. So now as you see, like some of the columns wouldn't be listed over here because this is a huge data frame, but we have this column called as wage underscore euro. So this tells me the salary of these players in euros, and I'd want to see, I'd actually want to see over here which player gets, what is the salary of some of these players. So what I'd want to do is from the entire FIFA data frame, I'd want to extract only two columns. The first column would be the short name of the player, and the second column would be the wage in euro. And this I will go ahead and store in this object called as player salary. Now that I have created this sub data frame from my original data frame, then I would want to have a glance at the first 5 records of this. So here, player salary dot head, I will click on run. Here you see that in the first column, I have the short name of the player, and in the second column, I have the salary of the player. And here, as you see, Lionel Messi, his wage is, you have 65,000 euros. Then you have Ronaldo with 405,000 euros. Neymar is at 290,000 euros. Oblak is 125,000 euros. And Eden Hazard is at 470,000 euros. So I'm not sure if these are the latest salaries which these players get, but according to this particular data frame, it would seem that Eden Hazard and Lionel Messi actually get more salary than Cristiano Ronaldo. And now, what we will do is I'd want to see who is the highest paid football player. So from this data frame, from this sub data frame, what I'd want to do is I would want to sort this with respect to the wage column. So what I'll do is I'll write down player salary dot sort values, and inside this I have this parameter called as by. And what I'm doing is I'm just sorting this data frame with this column called as wage underscore euro. And I'll set ascending is equal to false because I would want that player with the highest salary at the top, and that is how it will proceed. And this again, I'm storing it back in the same object called as player salary. And I'll go ahead and hit on run. Now I will have a glance at the first few records of this. So when I say player salary dot head, so obviously, as you see over here, Lionel Messi is the highest paid football player at 565,000 euros. Then you have Eden Hazard at 470,000 euros, Ronaldo at 405,000, Kevin De Bruyne at 370,000. You have Griezmann at 370,000 euros. So quite an interesting analysis, isn't it? So again, we will do the same thing. We will make a bar plot for these top 5 football players with the highest salaries. And since we have these categorical entries over here, we would have to make a bar plot. So you'd have to understand why we're using a bar plot. So normally, whenever we do want to understand the distribution of a categorical entity, that is when we go ahead and make a bar plot. So here, what we are doing is first, the same thing, we will set the figure size. This time we are creating a bar plot for the players with highest salaries. Here, as you see, first I am setting the figure size. So I'll write down plt.figure. Inside this, I'm setting the figure size using this parameter called as fig size. And I given these dimensions. So the dimensions are 8, 5. 8, 5, 8 is the width, 5 is the height. So I've given the dimensions of the figure. Now, after I set the dimensions of the figure, I can just go ahead and create a bar plot. So to create a bar plot, I'd have to write down plt.bar. Inside this, so in a bar plot, always remember that the first parameter which you given has to be the categorical entries. The second parameter which you given has to be the numerical entries. So here, the first parameter, since it has to be capital, it has to be categorical. What I do is I would have to, so we have a categorical column, we have a numerical column. So obviously it is the names of the players which will be passing in over here. So this basically is your x-axis. So on the x-axis, we would need the names of the players. So I'll extract this particular column. So this short name column is from player salary data frame. So I'll write down player salary and I given the name of the column, which is short name. And obviously I'd want only the top 5 records. So I'll given 0 to 5 inside this. Then I will go ahead and in the next parameter, as you see, I have a wage in euro. So again, since it has to be numerical, this time I'm extracting the wage in euro column, and I'll go ahead and set the color over here. So color, as you see, is equal to red. Then I will go ahead and plot it out. I will hit on run. And as you see, this is the result which we get. So on the x-axis, we have the names of the players, and on the y-axis, we have the salaries. So Lionel Messi obviously is leading the chart. Then you have Eden Hazard, Cristiano Ronaldo, Kevin De Bruyne, and Annie Griezmann. Now let's say if I would want different colors for all of these different bars over here. So that is something which we can also do. Now let's say instead of just keeping this as red, if I would want different colors, so what I'll do is I'll pass in a list of colors over here. So for Lionel Messi, let's say I given blue color. Then for, let me just keep it small b. So for Lionel Messi, I'm keeping blue color. For Eden Hazard, I'll give green color. Then for Cristiano Ronaldo, maybe I'll give in red color. Then for Kevin De Bruyne, I'll give, let's make it pink. And finally for Griezmann, let's keep it, let's say orange. And let's hit run. Seems like we have an error over here. The spelling which I've given is incorrect. So let me just keep pink and I'll hit on run. And as you see, this is the result which we get. So we can change the colors which are there in all of these bars as well. And now what I'd want to do is I'd want to do a simple analysis for the players who belong to Germany. So what I'm doing is, so let's say if I, from this FIFA data frame, if I set the nationality is equal to Germany and I hit on run, I get a bunch of true and false values. So when you have these bunch of true and false values, what does this actually mean? So if you have a false over here, this means that in that particular record, the nationality of the player is not equal to Germany. And if it is actually equal to true, then it would mean that the nationality of the player is Germany. So what I'd want to do is, from this list, I would want to extract all of those records where the value is actually true. So I will take this command and I will paste it again inside the FIFA data frame, and I will store it in this object called as Germany, and then I'll print it out. So I'll write down Germany.head. And if I would want to have a glance at the first 10 records of it, so Germany.head, inside parenthesis, I'll write down 10 and I will hit on run. And this is the result which we'll get over here. So as you see, this is the list of all of the players whose nationality is Germany. And now What I'd want to know is I would want to see who is the tallest German player. So Germany dot sort values, I will use by, and I would want to sort this with the height in centimeters column, and I will set ascending is equal to false. And I would only want to have a glance at the top 5 records. So I would want the top 5 tallest players of German nationality, and I'll hit on run over here. And as you see, so you have Aaron Seidel right now as the tallest player of German nationality. His height is 199 centimeters. Then you have Michael Esser, whose height is 198. You have Lars Unestal, whose height is 198 again. Then you have Dominic. Then you have Lucas. So these are the players with the, these are the tallest players. Then similarly, let's say if I would want to sort these German players according to their weight, I would want to see which player has the maximum weight. So again, this will be similar. I'd have to write down Germany dot sort values, and I would have to sort it with respect to weight, and ascending, I'll set it to be false, and I'll hit on run. This time you would see that weight over here. So it's Lucas Woltowiak, who has the highest weight of 103 kgs. Then again, you have Lars Unestal, whose weight is 103 kg. Then you have Ralph Farman. Then again, you have Michael Esser, and you have Nicholas Sule. And then I would want to see who is the highest paid German player. So this time I have the wage in euro column, and I am sorting it with respect to the wage in euro. Ascending is equal to false, and dot head method. Now if I show you these players, let's see what are these names. So Tony Cruz is the highest paid German player, and he plays for Real Madrid. So obviously, if you're playing for Madrid or Barcelona, you would be paid a lot. Then you have Marc-Andre Stegen, and he plays for Barcelona, so he's the second highest player. And then you have Leroy Sané, who plays for Manchester City. Then you have LK, who plays for Manchester City as well. Then you have Thomas Müller, who plays for Bayern Munich. So top 5 players of German nationality who have the maximum wages. Now, again, what I want to do is I just want to make a simple data frame again. So I just want what I want is I would want 2 columns. The first column should have the name of the player, the short name of the player. The second column needs to have the wage in euros, and I would want to sort this with their salaries. So Germany, from this data frame, I'm selecting only short name and wage, and then I'm sorting this data frame by their salaries. And obviously I'm sorting this in descending order, and I would want to have a glance at the top 5 records. Now, if I click on run, you would see that this is what I get. So obviously, it is Tony Cruz, whose salary is 330,000 euros. Then Stegen has 250,000. Then you have Sani at 195. And at 5th place, you have Müller at 170,000 euros. Now, after this, what I want to do is from the original data frame, I would want to see who has the best rating for his shooting skills. So what I'll do is from the FIFA data frame, I'll extract only 2 columns. The first column is short name. The second column is shooting. And I'll extract these 2 and I'll store them in this object called as player shooting. I'll hit on run and I'll go ahead and sort it again. Now, when I hit on run, you would see that Cristiano Ronaldo has the highest rating for his shooting skills, so he's got a rating of 93. Then you have Lionel Messi, then you have Harry Kane, then you have Sergio Aguero, and you have Quagliarella. So these are the top 5 players with highest shooting skills. Now, similarly, I'd want to see which player has the maximum defending skills. So player defending. So this time from the original FIFA data frame, I'll be extracting the short name, the defending column, which would tell me his defending skills, the rating for his defending skills. I have his nationality, and I also have the club for which this person plays for. Player defending. And now I would want to sort this by his defending skills. So obviously player defending dot sort values by is equal to defending. And this has to be in descending order. Then I'll hit on run. So you see that you have Chiellini, who plays for Juventus, and he's from Italy. He's got the maximum defending skills. Then you have Van Dijk. Van Dijk plays for Liverpool, and his nationality is Netherlands. Then you have Koulibaly, then you have Gordon, and you have Hummels over here. So Hummels plays for Dortmund. And then finally, what I'd want to do is I'd want to analyze the list of players who play for Real Madrid. So Madrid is one of the topmost football clubs across the world, and I'd want to see what makes this club so special. I'd want to analyze some of the features of different players over there, and that would be the final analysis for today. So what we'll do is from the original data frame, which is FIFA, I will set the club value to be equal to Real Madrid. So from the original data frame, we are extracting only those records where the value is equal to Real Madrid, and that I'll go ahead and store in this object called as Real Madrid again. Now I would want to see who is the highest paid player in Real Madrid. So Real Madrid dot sort values, and I would want to sort it with respect to the wage in euro column. And when I hit on run, you would see that Eden Hazard is the highest paid player in Real Madrid currently. Then you have Luka Modric. So Luka Modric is the second highest paid. Then you have Toni Kroos, Sergio Ramos, and Karim Benzema. So Eden Hazard plays for Belgium, Luka Modric plays for Croatia, Toni Kroos plays for Germany, Sergio Ramos plays for Spain, and Benzema plays for France. And now we have looked at who are the highest paid players in Real Madrid. Now let's also see who has the best shooting skills in Real Madrid currently. So Real Madrid dot sort values, and I would have to sort it with respect to the shooting column. Ascending is equal to false because again I'd have to sort it in a descending order. And as you see, Gareth Bale has the best shooting skills currently in Real Madrid. Then you have Jimmy Rodriguez, who is the second best shooter, followed by Eden Hazard. Then you have Karim Benzema. Then you have Luka Jovic. Finally, I'd want to see who are the best defenders in Real Madrid. So Real Madrid dot sort values by is equal to defending, and I'll hit on run. And here, as you see, so it seems that Sergio Ramos is the best defender in Real Madrid currently. Then you have Casemiro. After that, you have Varane. Then you have Carvajal, and finally you have Militao. So these are the top 5 defenders currently who are playing for Real Madrid. So as I've told you, we'll be working with these 2 libraries. We will not actually require Seaborn. So Seaborn is also another visualization library, which we will not require today. So I'll just delete it from this command. So we would need Pandas. The alias for Pandas is PD. We would need PyPlot, which is a submodule in Matplotlib. And I'm giving this an alias of PLT. Again, let's just wait for these libraries to load. So that is done. What I'll do is I'll actually remove the results from over here so that it will be much more interactive so that you actually know what is happening over here. Now, let me start off by running this again. Now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the Pandas library, and we have a CSV file called as character stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now, I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default, this head method gives you first 5 records which are present. Now you see this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abincer, Abomination. Then you have the alignment, whether the superhero is good or so. Basically, we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So I guess there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abincer, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape, and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now, going ahead, I want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that sort of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains, and 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. So let me explain this command properly to you folks. So what I'm doing over here is, so first, when I given the name of the data frame, inside this, I given the column name. So let me write down alignment over here. And when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here. And if we go up, So we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now when I hit on run, and if you look at this particular data frame over here, so you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only, so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again, here you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why you have 3D man at the top. And now I'd want to see which of these superheroes has the maximum speed. So speed over here is a numerical column. And if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good.sort values, and I would want to sort this data frame with the help of the speed column. And I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have a Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So it seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have this speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to, again store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell above this and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you, so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3, and 4. So again, so you have different versions of Flash over here on the basis of the comic books. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd similarly, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1 and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be, that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Wizkid, Wandra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good.sort values. So I'll delete min speed good, and over here I'll also delete this. So now from this data frame good, I'd want to this time. So initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good.sort values, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. What do you guys think about that? So now, similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power, and I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame, and I will store in, let's say, I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here. So let me just good max powerful. And when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually see. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V dot shape. And when I hit on run, so you would see we have 33 superheroes who have a power of 100. And that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes, are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Where was that? Sort values, speed. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so seems like Superman does not have a power of 100. So that is something interesting to find out over here. So we have done analysis till till the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again, we will be needing Matplotlib, and Matplotlib again has a submodule called as PyPlot, for which we have given this alias of PLT. Now I will insert a cell above this, and what I'd want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now, what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power. So you have see this total column over here. So I'd want to look at the top 5 list of those who have the maximum total value, right? So here, as you see, Martian Manhunter seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. For in all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. But this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here, and these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is, I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions, and I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8,5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these 3 different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5, because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again, 0 to 5, because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have
Done. And we have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or supervillains: Ammo, Amazo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these supervillains. So again, it will be bad.sort values. And this time by it will be speed ascending is equal to false. So similar stuff what we've done. And as you see over here, so you see that a lot of these supervillains also have a speed of 100. So you have Zoom, Airwalker, you have Amazo, you also have General Zod over here. So then you have Superboy Prime. So all of these supervillains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run. And as you see over here, you have Mr. I'm not sure how you spell this, but this, so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing. Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most, badass of all of these supervillains. So again, I would want to look at the total column over here. So bad.sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amazo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that, how Doctor Strange, who is equally intelligent as Dormammu, who is able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 10,5. I don't know, 10,5 seems fine. plt.bar. So how to give different colors in the bar. So I'll show you how it's done. So plt.bar, here the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here. And I have plt.show. Why do we have an error over here? Bad max bar. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram. And here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now, on the other hand, if I just want a distribution of speed, so speed is only a numerical column, that is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. Right. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have two peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again, I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for supervillains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to supervillains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So out of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. What if I need only some selected columns as an output, not all columns? Sure, I will show how to do that. So let's say from the original data frame, which is Marvel. Now I'll write down Marvel. From the Marvel data frame, if I'd want only the name column and the total column, so this is how I'll do. First, I'll give in this column, the name of this column, then I'll give in the name of this column. Then maybe I'll store it in a new object, and I'll call it as Marvel total. I'd have to give in two braces over here. Let me cut this out. Let me paste it inside this. Now, let me print out the head of this. So it will be Marvel total.head. And as you see over here, I have extracted only two columns from the entire data frame. So you just need to give in the name of the data frame, and inside the parenthesis, you need to give in two braces over here. And inside those two braces, you need to give in the columns that you'd want to extract. So this was all about the exploratory data analysis for the Marvel and DC superheroes. Now, let me quickly jump onto this
So we would require with these two libraries which we have learnt about. So we have learnt about Pandas, we have learnt about Numpy. Now I have quickly loaded these two libraries. Now I have this data frame called as battles. So this is a CSV file which comprises of different battles which have happened in the Game of Thrones series. So to load this file, I'll just write down pd.read_csv. So this read_csv method helps us to load a CSV file. So this is how I'm loading this file, and I am storing it in this object called as battle. I have successfully stored it. Now I'll have a glance at the first 5 records which are present in this battles data frame. So we have our, this is the first of 2 data sets of the Game of Thrones. So here in this data frame, we have all of these columns over here. So this name which you see is the name of the battle. So we have around maybe 40 odd different battles which have occurred through the 7 books. So you have Battle of the Golden Tooth, you have Battle at the Mama's Ford, you have Battle of River Run, you have Battle of the Green Folk, and so on. This column tells us in which year the battle occurred in. So Game of Thrones was mostly based throughout the 298, 299 and 300 AC years. Then you have the this column which would tell you who is the attacker king. So here for this battle, which is Battle of Golden Tooth, the attacker king was Joffrey and Tommen Baratheon, and the defender king was Robb Stark. So here attacker 1 basically tells you who is the primary attacker. So primary attackers are Lannisters over here. I mean, we already know that the Lannisters have started most of these wars, so this is not really, not really new information. Then we have this major death column. This major death column tells us if any major death has occurred in this war. So let's say if someone such as maybe Jaime Lannister has died or Robb Stark has died. So if there's any major death involved in this battle, then we'll have the value 1. On the other hand, if there's no major death, then we'll have 0. Similarly, we have this major capture column. So if the value is 0, it would mean no major captures have occurred in this battle. Similarly, if we have the value 1, that would mean some major captures, someone really powerful has been captured. Then we have attacker size over here. Attacker size would tell you the number of people who have fought on the attacker side. Then you have who's the commander who is leading the army of the attacking side. Similarly, you have this column which would tell you who is the commander who is leading the defender side. Then you have the different regions in which all of these battles occurred. So let's say if we take this particular battle, which is Battle of the Golden Tooth. So this battle has occurred in Westerlands. So this is some basic information about our data frame. So before we do EDA, it's actually important to understand what is the data about. Now, if I want to know the number of rows and number of columns which are present in this data frame, I'll just have battle.shape. And you would see that we have this value 3825, which would basically mean there are 38 records present in this data frame and 25 columns present in this data frame. Now, some of these columns are not very intuitive. So let's say I have attacker 1 over here. Now, instead of attacker 1, I'd want this to be more intuitive. So I'd want to rename this column from attacker 1 to primary attacker. So for that purpose, I have this method called as rename. I'll use this rename method. I'm using this rename method on top of this battle object. And inside this, I have this parameter called as columns, which would help me to rename this column. So for this columns, I'll pass in a dictionary. Key would be the column which I'd want to rename. Value is to which particular value would I want to rename this column. So I am renaming this column attacker 1 to primary attacker. And when I set in place is equal to true, this would mean that the change directly happens in the data frame itself. Now, once I make that change, I'll just go ahead and have a glance at the change data frame. So you would see that initially the name of the column over here was attacker 1. But after using this particular method, we have changed the name of the column from attacker 1 to primary attacker. Similarly, we have the defender 1 column over here. Defender 1 means who is the primary defender. So here I'll use the same method, which is battle.rename. So rename is the method, and I'm using this method on top of the battle object, and I'll have this parameter columns, and you would see that I'm passing in this key value pair. Key is this particular column, value is to which value I'd want to change this name to. So I am renaming defender 1 to primary defender, and when I set in place is equal to true, the changes automatically are saved in this data frame. Then I'll have a glance at this modified data frame. So you would see that I have changed the name over here. So this was some basic pre-processing for this data frame. Now, if I'd want to know how many times a king has attacked, so I have this attacker king column. So let's say if I'd want to know the number of times Robb Stark has attacked someone, the number of times Joffrey and Tommen Baratheon have attacked someone, then I can use the value counts method, which would give me the frequency of a categorical column. So this is a categorical column, as you see. So all I'll do is I'll have battle, and inside this I'll give in the name of the column, which is attacker king. And when I use the value counts method on top of this column, this will give me the frequency of values. So here it would seem that Joffrey and Tommen Baratheon have attacked 14 times. So it seems like Joffrey and Tommen are mostly the starters of all of these wars which have happened in Game of Thrones. And over here, when we see Stannis Baratheon, so Stannis Baratheon has only attacked 5 times. Then similarly, we have Robb Stark over here. So Robb Stark has started an attack 10 times. Then we have the Greyjoys. So the Greyjoys have started the attack 7 times. So this is a simple information which you can find out about attacker king. And if I want to know how many battles have occurred in different locations, so we have the location column. Now, let's say if I want to know how many battles have occurred at Golden Tooth, how many battles have occurred at River Run, then I'll just use value counts again for this particular column. And you would see that Winterfell and River Run have the most number of battles. So at Winterfell, 3 battles have occurred. Similarly, at River Run, 3 battles have occurred. But from over here to here, you would see that only 1 battle has occurred at these different locations. And we have, let's say, we have Storm's End over here. Storm's End again has only 2 battles which have occurred. So that was understanding about those categorical columns. Now that is done, what we'll do is we'll do some basic visualization to understand this data frame better. So to do visualization, we have already imported the Seaborn and Matplotlib earlier. So these are the 2 important libraries for visualization. I'll go ahead and load these 2 up. Now that these 2 are loaded, I'd want to understand, how many. So over here we had looked at the frequency of attacker king. So now I'd want to know. So here what I'm doing is, let's say if a king has attacked, then I'd want to know what is the size of his army. So that is why I'll have attacker king mapped onto the x-axis, attacker size mapped onto the y-axis, and I am creating this bar plot on top of the battle data frame, obviously. So here this sns.set, I'm just setting the figure size over here because there are a lot of things which are present in this visualization. So here we have 4 attackers. We have Joffrey and Tommen Baratheon, then we've got Robb Stark, then we've got the Greyjoys, and then we've got Stannis Baratheon. So here, it seems that whenever Stannis Baratheon attacks, he has a huge army size. So if you look at Stannis Baratheon's army size to other Baratheons, or to even Robb Stark, or to even Greyjoy, so if we look at this, so Stannis Baratheon, he would have a size of around 30,000 in general. Similarly, if we look at Greyjoys would have the army, the size of their army would be somewhere maybe close to around 1,000 or 2,000, not more than that. Similarly, Joffrey and Tommen Baratheon, their army size would be around close to 10,000. So this is an interesting observation. So, it seems that Stannis Baratheon had a huge army along with him when compared to other attackers. Now, similarly, if I'd want to know the army size of the defender, so this time, what I'm doing is I am mapping the defender king onto the x-axis, and I'm mapping the defender size onto the y-axis. Now, when I run this, so these are all of the defenders. So this time we see that whenever, so out of all of these kings, whenever Renly Baratheon was attacked, he had the maximum army size. So maybe in some battle, Renly Baratheon would have been attacked, and in that particular battle, he had an army size of 20,000. Then followed by Joffrey and Tommen Baratheon over here. So it seems that whenever Joffrey and Tommen Baratheon are attacked, their army size is around 8,000 to 9,000. Then we've got Stannis Baratheon. Now compare this to this over here. So whenever Stannis Baratheon is attacking, it seems that he'll have a larger army. But on the contrary, whenever it's Stannis Baratheon who is being attacked, in that particular point, it seems that he'll have a very small army. So this is very interesting, isn't it? So that was about attacker size, and defender size. And now if I want to know what are the different battle types that these attackers have engaged in. So this time I'll be using this method called as count plot, and I am mapping the attacker king column onto the x-axis, and hue. Hue basically determines the color of these bars. So the color of these bars is being determined by the battle type. Now when I hit on run, so you would see that again we have these same attackers who are Joffrey, Tommen Baratheon, Robb Stark. So we've got the Greyjoys, then we've got only Stannis Baratheon. So it would seem that when it comes to Joffrey and Tommen Baratheon, they mostly engage in a pitched battle, and it's they have ambushed someone very few times, right? So Joffrey and Tommen Baratheon, they have been in a pitched battle 6 times, but they have only ambushed someone 3 times. But when you talk about Robb Stark, so it seems that Robb Stark mostly ambushes his enemies or ambushes, against someone else. So Robb Stark has ambushed the opponent 5 times. And then you have the Greyjoys. So it seems that it's only the Greyjoys who have engaged in this raising type of battle. Then you have Stannis Baratheon. So here, if you look at this, you have no orange color bar, which would mean that Stannis Baratheon has never ambushed anyone. So either Stannis Baratheon was part of a pitched battle or he was part of a siege battle. So quite interesting observations over here. Now there is another data set. So till now we were looking at the battles data set. Now we have another data set called as character deaths, which would tell me about the different deaths which have occurred over here. So I have this character death CSV file. I am storing it in this new object called as death. And then I'll have a glance at the first few records. So these are the names of all of the characters who have died in the series. So, and this is in alphabetical order over here. So you have Adam Marbrand, who was, whose allegiance is Lannister. You've got Adric Humble, who belongs to the Greyjoy clan. Then you have the death year over here. So death year, obviously, it has occurred either at the year 298, 299, or 300. Then you have the Book of Death. So in which book has this character died? So when you have 3.0, this would mean that this character has died in the 3rd book. When you have 5.0, this would mean that this character has died in the 5th book. Then you have the death chapter, which would mean, so in the 5th book, Adric Humble has died in the 20th chapter. Similarly, Aegon Frey has died in the 3rd book in the 51st chapter. So interesting observation again. Then you have the gender over here. So if the gender value is 1, that would mean this guy is male, and if the gender value is 0, that would mean this character is female. And then you have nobility, which would tell you if this person is is actually noble or not. Then you got then you basically have all of these names of different books over here. So this is the first book, this is the second book, and so on, which will tell you if this person has appeared in this particular book or not. So that is pretty much it about this. Now what we'll do is we will look at the shape of this. So we have 9, 17 and 13, which would mean that there are 917 records which are present in this data frame and 13 columns present. So overall we have 1917 deaths. Now if I want to do a gender comparison with respect to the number of deaths over here, so I will just pass in this gender column and I'll use the value counts method. And here you would see that out of these 917 characters who have died, 760 of them are male characters. So 760 male characters have died, and it's only 157 female characters who have died. Similarly, if I'd want to know how many people who have died belong to nobility and how many of them do not belong to nobility. So this is sort of even. So out of all of the people who have died, 487 are not nobility, and 430 of them do belong to nobility. Then similarly, what I'm going to do is, so this was with respect to the character categorical columns. Now, if I want to understand about the death year, which basically means in which year, how many number of deaths have occurred, I'll use count plot over here, and inside count plot, I am passing in the death year column. So you have this death year. This is the column which I'm passing over here. And when I hit on run, you would see that. So you have all of these years. So these books basically depict this particular decade or this particular time zone from 297 AC to 300 AC. So it would seem that most number of deaths have occurred in the year in the year 299. So you have close to 160 deaths. So that's huge, isn't it? So you have close to 160 deaths which have occurred in the year 299 AC. Similarly, in the year 300 AC, you have around 100 deaths occurring. Then in the year 298 AC, you have around 42 deaths occurring. So it seemed that there was a lot of peace in year 297. There were maybe a lot of battles did not occur in that year, or maybe people were just more, more peaceful. So maybe you would have around only 5 to 6 deaths occurring in this year. So interesting plot again over here. So after this, now I'd want to know, out of these characters who have died, to which allegiance do these people belong to? Allegiance is basically to which clan have they, do they fight from? So again, for this, I'm using a count plot. Let me zoom this for you guys so that the text over here is clear. This is too much of zoom, so let me reduce this a bit. So if we look at this, so this is none. So you basically, so basically these are people who have died, but the allegiance is not stated. So it would seem that most of the deaths belong to the Night's Watch. So you have around maybe 110 or 115 deaths from the Night's Watch side. Then you have some allegiance over here who have around close to 100 deaths. Then you have the Greyjoys. So the Greyjoys seem to have around 50 deaths. Then we have the let's say House of Stark. The House of Stark has around maybe 30 odd deaths over here. But if you compare the other houses, so let's say if you talk about House of Baratheon, seems like very few people have died from the House of Baratheon. And similarly, if you look at the House Tyrell or maybe even House Martell, very few deaths have occurred from their side. all of this is the exploratory data analysis, which I have done with respect to the different columns which are present in this data frame.
What is QR code? So, QR code stands for quick response code, right? The whole form of QR code is quick response code, and it is machine scannable image which can be read by instantly using a smartphone camera. If you have smartphone camera, yes, you can start read any QR code. So what is QR code? It will have few certain information. Every QR code has a number of black square. Can you see? This is the black square we have, and it's going to have this certain pieces of information, right? And this is how we are going to use QR code. It's going to take all the information and it will make a QR code like this. We use QR code in Paytm. We use QR code in Google Pay, Paytm, Phone Pay, right? Everywhere we know this QR code works. But how? Right? Yes, I'm not going to stop. I'm going to complete it and then I will stop, right? Okay, so basically, this QR code blocks has this particular certain pieces of information, right? Now, when this code is basically scanned by the camera, it translates that information into something that can be easily understood by the humans, right? Okay, yes. So what's happening here? So basically, a QR code is going to make particular block of codes where all the information is going to store, and it can be read by the camera, and from that camera that will become easily understood by humans way, right? And this is what QR code stands for, right? Now let's go to code, the most awaited part for all of you guys, right? So in order to make that, we are going to install two libraries. One is PyQR code, right? We have this library in Python. So what is this PyQR code module? It's a PyQR code library. It's a QR code generator library in Python. This module automates the most of the building process for creating QR code. This module attempts to follow the QR code standard as closely as possible. And the terminology and the encoding used in PyQR code come directly from the standard. So these are the basic, explanation of this particular library from the documentation itself. And this is basically we use this library to create our QR code. So what we are going to do, I have written pip install PyQR code. This is how you can install it, right? Now we have installed PyPNG. Why PyPNG? This is for image, to save your image, to create your image as well. So we have used this, right? So we have installed PyPNG. Now this is the most awaited part, and yes, I'm going to make 4-5 QR code, and then we will just talk about more, and then you guys will do that and let me know that are you going to also get this particular QR code is working in your phone as well. So I am going to show this QR code in my live session right here, and I just want to get a confirmation from you that that particular QR code is redirect to you the particular side I want to redirect you or not. Then you will understand, right, that QR code is going to work or not, right? So what we are going to do, we are going to import QR code from PyQR code. So we have written import PyQR code, right? I just make it big as much as I possible. Then what we have done, we have imported PNG. Okay, from there we have PyQR code import QR code, right? Now what we are going to do, string which represent the QR code. Suppose I have given the link for Great Learning Academy. Let me show you how I get the link, right? If I just double click over here, right? Can you see what I get? I get www.greatlearning.in, right? /academy, right? So if I just go back, let me show you how it's going to work. Can you see what site I get? I get www.greatlearning.in/academy, right? What I have done over here, I have written HTTP then www.greatlearning.in/academy. So this is how, suppose a particular restaurant, right? Okay, going slow. Am I going really fast over here? Okay, let me just, okay, take your time, try to understand what I'm just trying to portray over here. Here we are going to have a variable called site. Okay, then what you can do, suppose a particular company has their website, right? They have uploaded their menu over there, right? As they have uploaded their menu over there, what they want now, they want to use that particular menu using QR code. Now how they are going to do that? To make the QR code, you have to give what? You have to give the link for that. Okay? Okay. Now what we are going to do? We are going to write a variable, site variable equals to http www.greatlearning.in, because I want to make QR code for this particular site. Okay. Now how to generate QR code? You just need to write, let me just delete this part. Let me just put it over here, right? So what we have done, we are going to generate QR code. How to do that? Okay. So how to do that? I have again written a particular variable called URL underscore QR equals to pyqr code dot create. So now try to understand, we have used dot create. Okay. Yeah. Okay, so we have written pyqr code dot create, and then we have written which site I want to redirect you. So dot create function is used to create the QR code. I can see the lots of questions coming up. I will give the answer. Before that, first try to understand. If you get any error, I will help you to solve that. Right? So be patient and try to understand the code first. And again, if you like the video, do not forget to like it and do not forget to subscribe. Great Learning. So what we are going to do? We have written pyqr code dot create, and then we have created the site. Okay. What is that site? That site contains that where you want to redirect your customers or redirect your whole like traffic. Okay. Now, after you have done pyqr code dot create and then site, it will create the QR code. Now I want to create and save the SVG file naming. Like here, I have changed the name, right? Okay. Okay. Now I will talk about what is SVG file. That is scalable vector graphics. Okay, this is a term for particularly for image processing, you can say, and this is an extensible marker language based vector image. So this is something you don't need to understand now. So you can understand we use SVG because of to get a vector image, right, for the graphics. Okay, so guys, till now dot create, till whatever we have done till dot create. Let me tell you what is that. Now URL underscore QR and dot svg. I have said that why we use dot svg. Dot svg for scalable, right? For scalable vector graphics. Okay. So you don't need to understand this particularly. And guys, if you like the video, do not forget to like it and do not forget to subscribe. Great Learning. Now what I am going to do, I am going to save the PNG file name, right? So here you can see dot svg file also I get. Here I get the great PNG as well. If you do not want to SVG file, then what you can do, make it comment. So if you want to grade only the PNG file, what you need to write URL underscore QR where you have created your QR code dot PNG, right? Now grade.png, I have given the PNG name and scale equals to 5. The scale I give 6, right? Now if I want to show you what I have get, let me show you. Okay, and if you are using Google Colab and if you want to check what are the file you have saved, it's already there or not, there is a box sign over here, right? Can you see this? Just click on the box sign and can you see I get my SVG file and PNG file both, right? Let me show why it's not showing. Okay, it's came here. Okay, right. Can you see the QR code? Let me show you the normal Great Learning one as well. That not the Great Learning Academy, Great Learning where you will get all the PG courses, right? Let me show you if it's going to work or not. Okay, I think create one PNG I want to make. Right? Let me see if it's going to. Yes. Okay. Just check, is it there or not? Yes. Can you see great PNG file is also there? Yep. Can you scan this one and can you check it's going to redirect you to greatlearning.in or not?
Basically, I've just loaded up the Google Colab platform out here. I've already written down all the pieces of code that's required, that's just been put on here, that's ready, so that we don't have to sit and type it out as we go together. But then let me explain how all of these work, right? So let me zoom in a little so that you guys can see all of this screen better. Now, whenever we're working with a chatbot or anything as such, the first most important step is to ensure that we can bring in all the libraries that we're going to be using for that particular use case, right? Now, in this case, we're going to require 4 important libraries. The first library we're going to require is Numpy. Numpy is basically used for numerical computations in Python, an extremely popular library for data science. And then we have NLTK. NLTK is a superb library for natural language processing in Python. It's one of the most amazing libraries that you get to work with if you're very serious about working with chatbots. And of course, we have 2 other libraries as well, String and Random. String is to ensure that it can process and handle strings in Python, and Random, basically, you're going to see why we require Random as we go ahead as well, right? So as soon as I click that play button, as you saw, now I have imported Numpy, NLTK, String and Random with just a click of a single button. I can do this on my phone, I can do this on my iPad, I can do it wherever I have an internet connection and I can open a browser. How fantastic is this, right? Now, what's the next thing that we're gonna have to do? Now, the next thing is again another 4 or 5 lines of code. It's very simple. Let me explain. The first 2 lines of code, basically f equal to open raw equal to f dot read and dot lower. With these, all we're trying to do is we're trying to bring in our corpus, right? Our corpus is basically in the computer. I'm going to show you how we created the corpus also. So we're going to take a look at the corpus. We're going to make sure that our program has access to it. We're going to bring it, make sure our algorithm, basically our working environment has access to it. It can read it. Fine. That's first 2 lines, right? The next couple of lines, if you see line 3, 4, 5, what we're trying to do here is, first of all, you remember pre-processing where I told you either convert everything to lowercase or uppercase. Here that you can see with this particular dot lower function, I am taking the entire document, just bringing it down into its lowercase. Once it's been put into its lowercase, then we're going to be using this concept of a tokenizer that we discussed right now. In this case, you might see that we're using one particular tokenizer from the NLTK library called as the Punkt tokenizer. Now, Punkt tokenizer is basically a pre-trained tokenizer which has the complete capability to sort of build a model around what's required and to give you an answer, right? So tokenizer as the process itself, you might be wondering why we are only using the Punkt. Now, there are many other tokenizers in the picture that we have. We have the tweet tokenizer, we have something called as the regexp or the regular expression tokenizer that you can go on to use. But in this particular case, we're not trying to assess or we're not trying to import the corpus maybe from Twitter. If you were doing that, if you were maybe analyzing hundreds of thousands of tweets, you need to just copy all of them and bring it up, bring it together, right? That is when you'd be using something called as a tweet tokenizer. We're using the Punkt because it's already pre-trained. It is very easy and fantastic to work with it, right? Okay, perfect. Now, the next couple of lines that you see is basically how we are converting all the documents that we have right now into a couple of sentences, and all of these sentences into lists of words later, right? So we're going to have 2 documents created. Basically, it's called as sent tokens and word tokens. Sent tokens means they are sentence tokens, and then we have word tokens where each individual element is a word. In sentence token, each element is basically a sentence, right? As simple as that. All we're trying to do is split it into sentences, splitting into words, and bringing it into our working environment. Now, as soon as I click run on this will not run. It'll give me an error. Why? Because it does not have access to that particular corpus file. So it's in my desktop. Let me quickly open up the corpus file in my desktop. Now, while that is uploading, I'll tell you how I created the corpus, right? So basically, I just went to Google. I typed in, data science Wikipedia, and Wikipedia just gave me this particular page for data science, right? So all I did was I copied everything from first line here till the last line, and I put it in a text file, and I call that file chatbot.text. That's it, right? So this is literally everything that's copy pasted from our Wikipedia. Now this is a very simple chatbot, but I just want to give you a demonstration to show what the corpus itself looks like, right? Now let me run this again. It should run absolutely fine now. See, I told you, right? So it just didn't have access to it, and now that it has access to it, it can do it. Now what we'll do is we'll print a simple sentence token to see if the tokens are working fine, right? Now you can look at this. Data science is an interdisciplinary field that uses scientific methods, processes, all these. This is one sentence, right? So you can see below there is another sentence. Data science is related to data mining, machine learning, and big data. So with this piece of code, what I did was I printed two sentences out from the sentence tokens. Similarly, what I want to do is I want to print out the word tokens. Now I just want to print 2 words from the entire corpus that I have. Simple. I just printed the 2 words, data and science. So basically what I'm trying to do to print this is to not showcase that you can print it. Of course you can print it. I'm just trying to verify if my data that we have actually created. Let me just scroll up here. Here when we created this particular document where we are converting it into list of sentences and list of words, I want to see if it works or not. That's the reason why we have that. Right now, once that is done, the next step in the process is to basically pre-process the text, as I just mentioned. Right now, lemmatization, stemming, all of these processes are something that we took a look at, right? So this entire process of pre-processing basically works in this way. Either we're going to convert everything to lowercase or uppercase, and then the other thing what we're going to try to do is we want a normalized vector as a result of all of these. We can have a regular corpus data sent into it, and we want tokenized vectors. So we'll have to remove so many different things. Right? So first of all, there might be sentences which are not broken down into words. And if your sentences are broken down into words, what is happening to the punctuation marks? Did you guys think about that? Commas, full stops, and all of that, right? So you have to think about that as well. So to process all of these things, we'll be using a WordNet. WordNet is basically a dictionary that's already inbuilt and included with the NLTK library when we work with Python, right? So it makes this entire process of, if it weren't for this particular, these couple of functions that we're using, or if it weren't for WordNet, we would have to write a lot of code for this particular segment for pre-processing, right? Now, as soon as I click on it, my data is pre-processed. Next thing is the fun part. Now, this is a function where we are trying to build a greeting function. Now, a greeting function is very simple. What does it mean when I say greeting? When I say hello to my to my chatbot, I want it to give me a reply, but then I will not just say hello. I can say so many different things. I can say hi, I can say sup. Sup is basically the millennial short form for what's up, right? I can say what's up, I can say hey, I can say a ton of different things there, and you can understand that these are the inputs that I'm going to be giving it, right? It doesn't mean that I have to give it all. I can give any one of these inputs and it'll understand that, hey, this person is greeting me. And when I input either hi, hello, greetings, sup, what's up, and hey, it will give me a response back saying hey, hi, nods, hi there, hello, I am glad you're talking to me, right? So it will give you any one of these responses. This is why we require the random function at the start. You remember? Let me scroll up. Import random. Why we require that library is when I myself give it an input, it will basically give me a random output. Look at this word, random.choice, right? So it will just try to find my response, and as soon as it finds my greeting response, it's gonna my greeting input, it's gonna give me a greeting response, right? As soon as I run this, now it knows how to greet people, right? And what have we done? We have used 4, 5, 6, 7, 8, maybe 20, 25 lines of code, and we've come to a point where our chatbot can already say hi and bye to us, right? Now the next thing that we're gonna have to do is get some responses to the questions that we ask. To do that, we basically will be using two concepts called as the TF-IDF vectorization and something called as cosine similarity. Now, to quickly explain what this means without going into a lot of detail, TF-IDF basically stands for term frequency and inverse document frequency. Term frequency, as you might guess right now, talks about how many times all the words, each individual word is repeated in your corpus, right? That's term frequency, the frequency of occurrence of words. And then you have the IDF, the inverse document frequency. This is an absolutely fantastic metric because, see, to find term frequency is very simple. Just find out all the words, list them out, see how many times they're repeated, add them. It's a 10 lines of code and you can do it simple, right? But the IDF part of it is very interesting because here we are not just trying to pick up up words and say, hey, this is a word that's repeated 10 times, but here I'm trying to attach a sentence of, attach a component of how rare the word is. That is why we require the inverse document frequency. How rare is the occurrence of the word in the corpus, right? Now, there are so many words which can occur so many times. For example, if the word is data science, or if it is data, let me search for this. See, there is 120 times the word data has been used, but it is not very rare or something like that, right? It's used 120 times. But if I try another word which is not so popular, like the word explorer, it has been used, but it has only been used once, so it is super rare. The IDF picks this up and it realizes that, hey, okay, these words are rare, these words are repeated so many times and all of that, right? Cosine functionality does that. Once we have bag of words, once we have everything ready in terms of ones and zeros, it takes all of that and gives us a normalized output. Now, if you do not follow the technicalities of it, absolutely do not worry anything. So basically what we're trying to do is to find the number of times a word is repeated in our document to ensure that, we can have and map the rarity of it. And the third thing is we can have the normalized vectors so that whatever we are doing right now, our machine can understand that, right? That is the simple aspect of it. Now, the next process that we're going to do on the same lines of response generation is to make sure that we provide certain data to it and it gives us an answer. We've already provided the corpus, so now it has to give us the particular answer when you're building the entire neural network and giving us an answer out there, right? But then you also have to think about certain situations where you try to type in something your chatbot doesn't understand, so you have to also write. So if TF-IDF is 0, it means that your chatbot does not understand what's written on your screen or whatever you just gave it as an input. So there it will basically tell you, hey, I'm sorry, I don't understand whatever you are saying, right? So basically it can greet right now, and the next thing is it can know what it can understand and what it can not understand as well, right? So let me zoom out a little for the next one, and basically for the last piece of code, right? See, we are already at the last piece of code and we are not writing hundreds of lines of code here, right? Okay, perfect. Now this is where we're going to be defining the start and end of a conversation. The start of the conversation is basically a for loop where the bot will continuously keep waiting without any sort of timeout. It will forever wait if I do not talk to it, right? But then there also you can change. Maybe if the user has not responded for 30 seconds, you can actually close the bot. You can do a ton of these things. This is the most basic bot, just to showcase the power of how you guys can go on to use Python to get to at this point as the goal here, right? So let me actually in fact run this. Here all we're trying to do is as soon as you're trying to, the user says hi, it'll start talking to you back. If the user says bye, it's going to quit, and eventually it's going to give us all the responses in between that makes our chatbot intelligent, right? Let me run this piece of code. Now the piece of code is run. Let me just read what it says. It says, my name is Stark, let's have a conversation. Also, if you want to exit anytime, just type bye. Well, let's just see if the exit thing works, right? I'll just type in bye. As soon as I typed bye, it says goodbye, take care, and a small heart. That part of it, the code is right here, right? So when I said bye, it understands that this person wants to leave. Let me run it again. This time, you know what I'm going to say? I'm going to say hello. So when I say hello, it nods, as in it's shaking its head. It wants to listen, right? If I say hi, now it'll give me another reply, hey. So it basically is randomizing all of these inputs. Whenever I say hello, hi, greeting, what's up, and I say any of these things, it's basically giving us an output for this part of it, right? Okay, now hi worked, hello worked, and all of that worked. Now, since we're talking about data science, let's try to see if we can find out something about the corpus itself. So when we want to try to ask what is data science, right now the model is not, chatbot is not that intelligent enough where it'll understand all the questions directly. But if I wanted to print me, let's say the foundations of the data science, let's see if it can print something like that using the corpus, right? See, it found so many things when I said the word foundations. It says data science is an interdisciplinary field focused on extracting knowledge from data sets, which is typically large data sets, applying knowledge and deriving actionable insights to solve a wide range of problems or applications. Look at that. I just said I want the foundations of data science, and it basically gave me a one-line answer to what it understands as an answer to what data science is, right? How fantastic is that? Maybe I want to ask another thing. It says impact at third point here. I'm going to say impact of data science. Enter, And as soon as I have an impact, look, it gave me one more fantastic sentence. Of course, there are certain warnings which says your stop words are inconsistent because we do not have that big of a corpus to train. It says, as big data continues to have a major impact on the world, data science does as well due to the close relationship between the two. So it's telling me that, hey, big data has a huge impact in the world. Data science also has a huge impact into the world just because these two are tied very close to each other. I asked it saying, what's the impact of data science, right? And it gave me another answer. Now what happens if I just type data science? Now, if I just type data science, it says that, hey, it just picked up one random sentence. Now, this is where the bot might not give you as accurate answers as you might think. But then, hey, this is a very, very, very simple bot. It says, however, data science is different from computer science and information science. So basically, this is the line it first picked up from its corpus, and it's just giving us that particular answers, right? Now, maybe if I want to find out techniques in data science, right? Let me just type for techniques. And look, it found something in this particular domain called as technologies and techniques. They said there are varieties of different technologies and techniques that are used for data science, which depend on the application itself. Okay, this is a very good answer, right? So apart from one or two answers, you can see that once I quizzed it with 5-6 questions, it answers all of these things. And ladies and gentlemen, okay, let me just say bye to the chatbot. Let's close it first. Let me say bye to it, and it says goodbye. Take care with a heart. Okay, cool. Now let me actually go on to clear all the outputs first of all, and let me zoom out to show you how much of code that we have written, right? 4 lines, another couple of 6 lines, 10, 11, 12, 18, 24, 25, 26, 36, 46. All of this is less than 60 lines of code, guys. 60 or maximum 70 lines of code. And all of these are very, very simple pieces of code, right? Take a look at that. We have not done much. I'm just scrolling through it. If you can look at the scroller on your right, and all of this is an entire chatbot on its own. Of course, this chatbot is not as intelligent as Google. It is not intelligent as Siri. But at the end of the day, this is a chatbot that is going to give you, all the important answers that you require for your questions. And we never put in a lot of effort to go on to, showcase this, right? So yes, at this moment of time, the goal of the demo again is to not run through each and every line of syntax to tell you why this is called lem tokens, why is it not called anything else. No, my point here is to showcase that you can build a chatbot in Python without having to put much effort, and I think that was showcased beautifully with this particular demo, right?
So here we are onto the PyCharm IDE, and I'll be proceeding on with a hands-on for this respective image processing projects onto the PyCharm IDE only. Now you could use any of the IDEs respective to your convenience, like you could take up the VS Code or Jupyter Notebooks, whatever you feel like. But that shall be a offline IDE. You are not preferred to use of the online IDEs. The reason for that is because right here you'll be giving some access to your cameras. Secondly, you'll be having some XML files. So with the help of those XML files only, you'll be proceeding on with the program. So you should have a folder for storing up those XML files. And this respective method is not at all allowed onto the online IDEs. Okay. So please make sure that you are having any of the respective offline IDE. Okay. Great. So here I'll be starting up with a project, and that is the smile detection project. Okay, what does this mean and what we are going to have up in this? So as I mentioned up, we'll be using up the OpenCV library. So from that, with the help of OpenCV, I will be giving up the access to your camera. Okay, I'll be giving up the access to your camera, and your camera gets opened up after you wrote up the complete program, all the specifications, all the things you put up. When you run out your program, your camera gets the access and the camera has been opened. After that, now if you're smiling, then it will be absolutely making up a square besides you, and it will be showing that smiling. And if you're not at all smiling, so it's not gonna show out anything. So it's a sort of a smile detection project. It will detect that either you are smiling or not. If you are smiling, so a square box will be formed around you, and onto above of that it will be written as a smiling. But if you're not smiling, so nothing sort of things like that are gonna happen about. Okay, so hope I'm clear with that. First of all, that what is this project about? Now, second, what are the things that you will be needing up for this project? So, of course, you're gonna need up the one of the IDE, and secondly, if you have taken or if you have put out any restrictions to your camera, like any restriction on sort of that, so please make sure that you remove out that respective restrictions from your camera. Otherwise, if you do not allow the access, in that case it's gonna show you some different sort of errors, and that won't work out. Okay, so great. I hope I have just told about a little like more things regarding here, whatever is required. Second, one more thing is required, that is will be requiring up some XML files. I'll be letting you know from where to download and how to download those out. But if you're downloading that, please make sure that you are downloading that into the same folder where you have made up your Python file into which you are writing up your respective projects. Okay, great. So I did make up a file here, and that is smile underscore detect.py, my file. Okay, I'll be starting up here. So the very first thing that I'll be doing up here is that I'll be installing up the OpenCV library. Okay, so as I am using up the PyCharm, so under the PyCharm, we did already have the option for the terminal that's attached up here. Now, if you're not using this, or if you're not having any terminal attached onto your IDE, so you could simply refer up the command prompt. So here what I'm going to write up the command, and that's pip it's install, and my library is OpenCV. OpenCV, put up a dash, and here you go with the Python. This is how you have to do that out, and hit out enter. Okay. In this case, it's gonna install up this OpenCV library for you with the help of this. For me, the requirement is already satisfied. Okay, so for me, it's showing that requirement already satisfied. But if you haven't installed that up till now onto your device, so make sure that you install it out very quickly. Okay, so what I'm going to do is that I will copy out this command, and I would put this up here in the file as well. So if you want up the reference, yeah, you could do that out. So when the OpenCV library has been installed out for you, after that you could go ahead and start writing up your respective program. You could start writing up the importing of your libraries. So I'm going to write up here the very first one, and that is import, and here I'm going to write up CV2. Okay, so here I have imported up my CV2 library. That's from the OpenCV only. It's a part of that OpenCV library only. I just imported that out. Okay, now okay, I was just telling you about importing of the different things, right? I just mentioned to you about the XML, right? That you have to install some XML files for you, right? Now, into that respective case, what is it? When you are dealing up with the OpenCV libraries and sort of things like that, first of all, for detecting your face, you have to download an XML file, and that is the hair cascade frontal face default.xml. Okay, this is one of the files which you have to download it. Secondly, now here you are particularly working on the smile detection. So there is a cascade file for the smile as well. You have to download that out. What I'm going to do is that I'm going to put up the comment here, and I'm going to write up the file name which you have to download. Okay, it's cascade csc cascade underscore frontal face underscore default dot xml. Okay, first of all, this has to be downloaded. So what you do, just go onto your Google and simply write out this hair cascade frontal face default dot xml. When you do the search for that, you'll be getting up many options, such as you'll be getting up the some GitHub links, and you'll be having many sort of things like that. Okay, now from that you could just choose out any one and download that out for you. Now when you are downloading this XML file, first of all, make sure that it is in the format which is XML. Secondly, download that onto the respective folder where your file is saved, into which you are writing up this code. As I am having up this great learning folder, right? Into this only I am having up my file which is this smile underscore detect. Okay, I'm having this smile underscore detect in the folder which is great learning. And now here again I am having this hair cascade frontal face default.xml in the same folder. Okay, so please make sure that you do out this respective thing. Otherwise, further you are going to face up many sort of issues, many sort of errors, because you haven't been put out your respective file on the respective folder. Again, I'm repeating, guys, why I'm repeating this again and again, because yes, this is the most important part of your respective project. Fine. Make sure to download this XML file in the same folder where your file is saved, in which you are writing out this particular program. Okay. Great. This is the first file which has to be downloaded. Second file is Har Cascade. Har Cascade underscore. This one is smile.xml. Same for this as well. Make sure that you are downloading it in the XML format. And secondly, save that in the same folder where your file is saved, into which you are writing up the code. Okay, so great. Hope I'm clear with this. So let me show you how these files actually look like. I'll be opening up this, and yeah, it's some sort of this respective sort of things are there into these particular files. Okay, for these XML which I was talking about, this was the frontal face, and this one is for the XML. Okay, simply you could go onto the Google, write this out, and you'll be getting many GitHub links and many things like that. So you could download it from anywhere of your choice. Okay, there is no such compulsion from this GitHub or from that GitHub, but wherever you find it like relevant, you download that out. Great. Now I hope that you did have downloaded this XML files up till now. Now it's the time for giving up these XML files into our respective variables. So I'm going to make up the file that variable that is cascade underscore, and I'm going to just go do this for the face first of all. Okay, so cascade underscore face, and here I'm going to import up my same library. I use up my same library which I did import it above, cv2 dot, and here I'm having up the function that is cascade classifier. Cascade classifier. Now, what is this function about actually? Whatever the file you did have the XML file. So this cascade classifier is a respective function which helps you to read up those files and act accordingly. Okay, so into this I'm going to write up that particular file of mine. Okay, so it's har cascade underscore, it's frontal face underscore, it's 1 second, let me just get back right here. Yeah, it's default.xml right here. Okay, so yes, this is my file which I just wanted to download it, import it out here and use that out. So it's the har cascade underscore frontal face underscore default.xml, my very first file. Okay, second file again I'm having, I would use that out. So it's cascade underscore smile, and that's equal to again cv2 dot, here goes cascade, and again I'm going to use up this classifier function. Okay, now into the bracket I'm going to use up this respective har cascade file which I did import it. So har cascade underscore, here goes my smile.xml. Fine. So pretty much sorted. I just wrote up both of these respective things right here. First one is for my frontal face and second one is for my smile. What is the frontal face gonna check? This frontal face XML file is gonna catch up your front face. The front face, as your your face is towards the front, so it's gonna catch up that respective face. And this cascade smile, what it is gonna do? It is gonna detect up the smile onto your respective face. Fine. So as I'm very much clear with these two things which I just did up right here. Fine. Now what I'm going to do is that I'm going to open up the camera, and with the help of my video capture function, I'm going to capture up my video. Okay. So for that I'll be having cap as a variable. So it's cv2 dot, and my function name which I'm going to use out is video cap. Now into the bracket I'm going to use up the number which is 0. Fine. So I'm going to capture up my video with the help of this respective function, and that's so into the variable which is cap. Okay, so great. Hope I'm clear with that now. Now I'm going to put up an infinite loop. So while true, I'm going to put up an infinite loop. This true. So it means that up till my condition is true, please running out. It means that it's not the case that once I smiled and it captured up that respective point and showed smiling. And further, if I again smile, so it's not gonna show out the next time. No, it's not that case. The number of times I'm gonna smile, that number of times it's gonna show that is smiling. It's gonna capture out that respective time. It's going to capture that respective face with the help of the square, and it's going to show up that smile. Okay, this is how it's going to be. So for this I just put that at an infinite loop. Okay, the number of times I'm going to smile, the number of times it's going to show is smiling. And if I again come back to the real real face, if I do not smile, so in that case it's quickly going to remove out that smiling thing from that respective video. Right, so hope I'm clear with this. So that is the reason I just put up this while true to put up this as an infinite loop. The number of times I smile, it will be showing the number, it will be showing out the same thing that number of times. Okay. Now, great. So now next thing goes that I'm going to use of the read function. Okay, from my video capture function, the video which has been captured, now we are going to read out that respective video. Okay, it means that my face which has been captured, we are going to read out that respective face. Okay, so here goes RE3 comma img, and that so is equal to, here we have cap. Okay, my variable into which I did the video capture, and I'm going to use up the function that's read. Okay, pretty much sorted. Now what I'm going to do is that I'm going to convert this BGR to gray. Now what's the use of this? Okay, I don't know that you did heard about this respective thing or not, but whenever we just try to do up some sort of things with the images, so whatever the BGR colors we are having, we convert that onto the gray scale. Okay, so after converting the things onto the gray scale, further we do out our respective things, whatever are required, whatever are supposed to be actually done out. Right. So this is again the same reason that why I am going to convert up my captured image into the into the gray color. Okay, into the gray scale. It's not that whatever the image you are going to show up onto the camera, that's going to show up in the gray color. No, it's not that case. Scales are different. Okay, like whatever the pixels we are having, those are onto the BGR colors, right? That we are going to convert onto the gray scale, not your complete image. Okay, so I'm going to use up the variable that's c, and which is equal to cv2 dot my library first of all. And next what we are having the function which is cvt colors, cvt and color. Okay, this is the one only which converts the color from BGR to gray. Now what I'm going to put, first of all I'm going to put up the variable that's img, for which variable I want to convert. I want to convert it for the img, and now where I want to convert it from cv2 dot its color underscore its bgr, it's bgr2, and here we have the gray. Okay, so this is what we are actually writing up here, that whatever my image is there, I want to convert that from BGR to gray scale. Okay, so for that only we just reduced up the CVT color. This CVT is for the convert color. Okay, CVT is the short form for convert, and that CVT means convert here. And the convert color, what to convert, the image has to be converted from BGR to gray, from BGR scale to the gray scale, it has to be converted. Okay, next, getting down here, now what I'm going to use is that I'm going to use up the face cascade, this cascade underscore face variable which we did made above, and whatever the scale, whatever multi scales I'm having up there, I'm going to use out that perspective. Okay, so for that I'll be using let's say f. Okay, f is equal to, I'm going to use up here face, yeah, It would be 1 second. It will be cascade underscore face. First of all, I'm working upon the face. Then I'll be moving on to the smile. This is how we'll be doing up the thing. Okay. So yes, cascade underscore face dot, and now I am having up the function which is detect multi scale. Detect multi scale. Okay, this is the function which I'm using up here. Cascade underscore face dot detect multi-scale. Now here with the help of this, it's going to detect up the multi-scale. Now I'll be using up that respective variable which I did use above. That's the G, right? Because onto that only I just did converted my BGI scale to the gray scale. Okay, so here we are having up the multi-scale, right? So this detect multi-scale is going to detect out this multi-scale conversions which has been done up. And in which variable we did? We did this into the variable which is G. So I just simply wrote that out, right? Getting down, we have a variable that's the scale factor. Not a variable, it's a function actually. 1 second, let me first of all get down. Great. We have a function which is scale factor. So you didn't actually need to put up the scale factor accordingly. So here the scale factor is 1.3. Okay. Now, whatever the neighbors are there, I'm going to put up a function which is min neighbors, NEIGHBOURS. Okay, min neighbors. This is one of, okay, I guess the spelling is, yeah, that's fine enough. No, it's not fine enough. NEIGH, okay, BORS. Yeah, so this min neighbors is one of the next variable, next, you could say parameter which we have up here, and we need to put that out as well. The value for that will be 5. And now I'm going to put up the minimum size of the image which has to be captured about. That respective one, I'm going to set it as 30, 30. Okay, so these are the things which I did set up right above, right here actually. Okay, yeah, my bracket will be closed up here. That's very okay. Now getting down, I will be using up my for loop. Now, what do we have? We have the values for the x. We have the values for the y, right? X and y values are there. Next, we have the width, and as well we have of the height, right? These are the 4 factors which you have up into a square, right? This is the 4 factors which whenever rectangle is formed, whenever a square is formed, these are the 4 factors which you are having. So now I'll be using up these all of 4, that is the x, y, width and the height into the faces. That is into this respective thing, the variable which is if. I'll be using up the for loop for that, and I'll be now using up the function which is rectangle. As I told you that around your face, when the video will be captured, so when your face will be displayed, into that around all the 4 sides, a rectangle will be like formed out, right? So now what we have to do, we have to give up the values for the formation of that respective rectangle. Okay, that I am doing. Let's do that out. I'm going to use up the for loop here. So here it goes like this, for. Okay, next what I have to do, I'll be writing up x, y, w and h. That is my value for the x, value for the y, my width and my height. All of these things are there, right? And now what I'm going to use up the variable which is f. Like what we did save in the if, we did save up this multi-scale, right? We just used up this detect multi-scale function, and inside that whatever the parameters were there, we just did up all and give up all of those respective parameters, right? So into all of those things were done into the variable which is f. So yes, I'm again doing out the same thing. So for x, y, w, h in f. Okay, get down here. Now use up my CV2 library and use up the function which is rectangle. Okay, rectangle, TANGLE. Okay, CV2 dot rectangle. Fine. Now what is the variable onto which we did have up the image, right? We now will be using up the image. So onto that case, I did make up the variable here, IMG, right, in which we are reading out our image. So I'll be using up the same right here. I'll be using up IMG. Okay. And now what I'll be doing is that first of all, I'll be passing up x, y. both of these respective parameters which I did have taken up onto my for loop, the x values and the y values. Now, what I'll be doing is that I'll be adding x with the width and y with the height, right? Because if we talk about the width, so that's the horizontal one, right? And onto the horizontal line, we have the values for the x. If I talk about the height, so height is in the vertical format. And if I talk about the vertical, so y is as well into the vertical. So that is the reason horizontal and horizontal are added together. Vertical and vertical are added together. That's the reason I'm going to add up x plus w and y plus h. I hope I'm clear with that, because x is going to lie up onto the horizontal line, right? And that horizontal line is as well depicting your width. Whenever you visualize up a rectangle here, okay, visualize up a rectangle. Now talking with that rectangle, if I have to take some x value, so x where lies, it lies onto the horizontal line, the straight line it lies upon, right? And if we talk about the width of that rectangle, so that's again that same horizontal line, right? So in that particular case, I'm gonna add x plus w. Now, next if I talk about the y and the h, so for y, what do we have? We have that y is one of the other axes, and that's the vertical one, the line which is straight, right? A vertical one. And what is the height? Height is as well the vertical one, because when we have to compare up the height, you go up like this, right? So that is again a vertical one. So into that respective case, x is added with the width and y is added with the height. So let's do out that respective thing very quickly. I'm going to write up x plus w, comma. Okay, let me get up some space here in between of these things. Right, x plus w, and now I'm going to write up y plus h. Okay, this was the reason. This is how we are going to do up these respective things. Now put up the comma. Next, what I'm going to do is that I am going to give up some values here. What are those values about actually? Now that will be my this values, which is BGR values. My BGR scale values, I am going to give that out right here. Okay. So I'm going to write up 255, 0, 0. Okay, so B is 255 and rest both of the values are my zeros. Okay, separated by a comma, and I'm going to use up here the 2. Fine. Let's get down, and now here I'm going to use up the values for the gray scale. Okay, now again that is completely same, nothing more change, only a slight change has to be made up for the converting of onto the gray scale, for putting the values onto the gray scale. Okay, so I am going to use up gray underscore r. Okay, and that's equal to, I'm going to use up the function here, that's the gray. Okay, 1 second, this is not the gray. The gray, instead of that, I'll be using up simple g. Okay, because we did made up the g above. Now what was stored onto that? Into this we were having the colors, right? We are converting BGR to gray. So now what I'm doing is that I'm converting that onto the, from BGR to the gray. I'm giving up the values for the gray. Okay, not like this. Here goes my list. Inside this, my y will refer to y plus height, comma, my x is gonna refer to x plus w. The same thing which we did above, only a little change has been made, that I have assigned up these values, these new values to the x and y. Nothing more than that. Okay, I simply assigned up the new values to this x and y. So that's the idea what I did just do here. Fine. That is completely done. My rectangle is done. Now next comes about my smile. Okay. So as we did this for the rectangle, the above one, 1 second, as we did this one, for the same manner, we are going to do that out for the smile as well. Okay, so I'm going to write up here, inside the for loop only, I'm going to write up else. Okay, so now here I'm going to use up the variable which is cascade underscore 1 second. Cascade underscore smile, because for the face we already did above. Right here we already did for the face. Right now it's the turn for doing up it for smile. So cascade underscore smile dot. Here goes my function, which is detect multi-scale. And here goes my skill, detect multi-scale. Right, again here I'm going to give up the same values, same sort of things. First of all, I'm going to give up this variable, which is gray underscore r, into which I just set out the gray values for my respective image. Okay, that has been done. Next comes my scale factor, scale factor. Okay, so my scale factor is going to be equal to 1.5, just similar to the above one which we did put up. Okay, it's just similar to the above one, a slight change only. Okay, sorry, here we put up the comma. Getting down here, I have again the minimum neighbors. So min, NEIGHBORS. Okay, so that's gonna be equal to 15. Okay, and next we are having up the minimum size. Okay, so now I'm going to set up the minimum size, slight change, that is 25, 25. Previously we did 30, 30, right? So I just did put that out very quickly here. Okay, okay, S would be capital for the size. I'm so sorry, size. Okay, did I put up the comma here? Okay, comma is required here as well. Okay, fine, great enough. This is done. Yeah, we just put up the things for the smile, for detecting up the smile as well. We had put up the different sort of things, whatever are required. Now, next thing that goes up here is that I now simply have to use up the for loop for my smile. So here goes that for I in S, because S is a variable into which I had used up my cascade smile to detect up the multi-scale. Right, so for detecting up my multi-scale, I simply used up all of these things, and that all are stored up in the variable which is S. Right, so for the same, I'm going to use up this onto the for loop only. So for I in S, now I'm going to compare out that if the length of the smile, okay, if length of the S is greater than 1, okay, I'm going to compare out that if the length of S is greater than equal to 1, so it's simply greater than 1. So what you have to do, you have to CV2 dot put text. You have to write CV2 dot put text. Now, where to put up the text? You have to put up the text into the image, right? Where you are actually simply reading up your respective video, which has been captured. So that has been stored up into the variable which is image, right? So onto that only you have to write if the length of the smile is greater than 1. Into that you have to write up something. So you could simply write up smiling. Okay, this is the thing which you could simply put up there when you find up the length that is greater than 1, length of the S greater than 1, you could put that out. Okay, now here I'm going to put up the respective variables, that X and Y values which we did give already. So I would simply write X comma Y minus 30. So whatever the X and Y values we are having up here, so for those respective, I did simply put up this particular thing. So simply the X and the Y values are to be done up here, and these are simply to be used up. Okay. After this, I'll be again putting up a comma, and now I'll be using up one more function. Let me get down and use it out here. So that function is CV2 dot. I'm going to use up this font. Okay, font. Now you have different types of fonts here. So you could use any font of your choice, whatever you are actually wanting to use. So font underscore. See, these are the types of fonts which you are having up here. For this, you could use up a Hershey Simplex or Script or plain or complex, whatever you like, triplex, whatever you feel like you could use. I'll be using up this one. Okay. So font underscore Hershey underscore Simplex. Okay, this is my font which I wanted. This is the font style actually, which I want to be printed up. This was my font which is gonna print, and this is the respective font type into which it is gonna be printed up. Comma. Here is my 2 comma. I'm gonna put up the values. It will be 0 comma 255 comma 0. Okay. Fine. Okay, 1 second. Here will be the 0 comma. Okay, here goes my comma. Again, getting down. Here you have the third one. And for the third one, what do you have now? You have the CV2 dot, okay, CV2 dot, it's line, we have line underscore AA, this respective function, line underscore AA. So whatever is written up there, we just simply line that out. Right, so this is what is actually mentioned up onto this line underscore AA1. Fine. Great, this is all sorted. I'll be getting out of my for loop, and after getting out of my for loop, I'll be now using up my CV2 function. So CV2 dot, here goes my IM show. Okay, this is done. Now here we have the video. Okay, here we have the video, comma, and this has to be done up into the image. Fine, this has to be done up into the image. So image, again, I would be like telling you that into this only we read out our respective video which has been captured. Fine. So yes, that has been done. Image is completed. Right here coming down, I'll be using up a variable, let's say that's k, and here I'm going to use that cv2 dot weight key. Okay, into the bracket, and here I'm going to put up some value like 1 second. The key for the key k would be capital 30, and here I'm going to put up an ampersand, and here I'm going to use up a code which is which is 0 1 second, yeah, 0x, this is the multiplication sign. Okay, great. And now I'm going to apply out one of my conditions, that if k is equal to 27, if k is equal to 27, so now onto that case, what I have to do, you simply have to break up my loop from there. Okay, if this is the respective one which has been followed and which has been used, so simply break up my respective loop from that particular place. Okay, and here we have the capture, the capture dot capture dot release my function, and here goes again now cv2 dot destroy all windows. The cv2 destroy all windows. So it means that as soon as all of these respective loop is done, this for loop has been done, this while condition has been finished up, simply now release up my camera. It means that release up my camera and destroy all the windows. What are the windows are open? It means in the sense that for the camera, a new window will be appearing for this, right? For this project, we will be having up a small new window, and onto that only the smile will be detected. So now as soon as that respective window has been opened, all the things have been done. Now when you just want to close that out, to simply destroy out all windows. It means that whatever the different windows have been opened up for the demonstration of the output, destroy all of those. It means that simply close out all of those respective values or windows that have been opened out here for the demonstration of the respective project which we did do out. Right. So hope I am very much clear with this respective things what I did here. Let me quickly go above here once explain you a very quick way that what would we do, and after that we'll be proceeding above with the output for this. Okay. So here we have imported up the CV2 library. That is pretty much clear, I guess, because we are going to use up and give the access to our cameras and detecting up some sort of things. So those things will be done up with the help of the OpenCV library, right? So that is the reason we just simply imported up here CV2. Now we'll be using up two cascade files, two XML files. First one is to capture up your front face, and second is to capture up your smile. So these two actually will be used up here into this respective project. So I just used up and simply written up both of those here. Getting down, here we made up a cap variable, and that is going to capture up my video. Further, we read out our image, we converted the BGR to the gray, and we did detect up the multi-scale, right? Then we have defined up the X, Y, W, and H, that is the XY values, width, and the height values. After that, further, we defined up a rectangle, that respective rectangle shall be of which respective shape. Okay, that respective rectangle shall be of which respective size, right? That all things will be defined. So as we did this respective thing, this multi-scale for the face, first of all, further we are doing up this particular same thing for the respective smile. Okay, now here this is written 025 to 12,0. This is because you what sort of writing, what sort of color you want to give for your rectangle. That is what is done up here. If you write 255, 0, so in that case blue will come. In this case the green color will be coming. Okay, and if you write 255 at the place of this 0, so in that case red will be coming. So this is the sort of things difference which will be there. I'll be showing you that as well in a short while. Fine. Simply after that video was captured, and after that all of the things were done, your windows, all of the windows were destroyed simply. Okay. Now what I'm going to do is that I'm going to simply run out this project. I'll be running this out because I'm not sure that will this work about with this camera, because once my camera is already opened out, so I don't think so it's going to work about. So what I'm going to do is that I'll be closing out this respective camera from here. Okay, I'll be closing this out. Now I'll be simply running out my project, and let's see that how it's gonna be and how it's gonna detect up the respective output of our particular project. So first of all, how it will be doing is that it will be giving up the access to your camera, and yeah, here we are. See, as I'm smiling, it's simply showing that smiling, right? So simply as soon as I am smiling, it's simply showing you that yes, you are actually smiling. And see, onto the above side it's written up smiling right here, right? And it's capturing up this respective square for you. Now if I just close this out right here, 1 second, it has to be closed out from here. Okay, if I close that out now, and what do? I simply change up these respective values. Now instead of this I put up 0, and instead of this if I put up 255. Okay, moving down, what do? Right here it is done. And here as well, if I for the rectangular again, I change up the color. I put up 0 here and 255 here. Now just have up a look at what's gonna happen up and how it's gonna respond up. So yeah, it would be taking some time. Right, now just have up a look that right here above it's showing a smiling, right? Okay. Great, right? So hope I am very much clear with this respective project to you, that how is this project actually gonna be and how is it gonna work about in the complete idea, right?
And in this project, whatever the data we are going to use, I need my own data set. So basically what you guys can do, you guys can make a folder, and I will show you how can you make your own data set. So if you start doing these things using your own data set, there is a plus point that you can change them according to your users, right? So I did not take my data from anywhere, like not from Kaggle, not from anywhere. So in today's video, whatever the data set I'm showing, this is made by me. So you can see in this here you will get this symbol, right? So you need to click over here. You can see already I have stored my data into Dropbox, right? And if you want to fetch your Dropbox data, how can you do that? Write wget and then your Dropbox shareable link. Okay, so from that it will directly fetch your data. Now what I'm going to do, you can see I'm going to unzip my data writing this. But how can you get the path for that? You can see over here there is a 3 dot, click on there and call the copy path, right? So this is how you can do that, and just paste the path over here, right? Control V, just do that. Okay, so it's going to unzip my data, whatever the data I have put in. So here it will be NU, so I don't want that. Okay, so you can see what I have over here. Now I am going to write my image width and image heights. So in my case, whenever you are going to, not in my case basically, whenever you are going to do any image processing, you need to provide your image width and image height, right? So for my case, I took 150 and 150. Now I just want to mention the directory I have for my training data. So if you can go over here, and from there, if you can go over here, right? Okay, so I have done this, so it's not unzipped. Let me do that again. Yes, just a second. Yes, okay, it's taking Okay. Oh my god. Why it's going to take so long? Let me just check over here. Okay. Interrupt execution. Already it's there, but it's not unzipped. I feel like. Let me just try it once. Okay. Just a second, guys. I'm just trying to figure it out. Okay, right. I got it. Okay, so if you can look at over here, what I got the problem. So you can see when I'm trying to do the unzip part, so that time my data is unzipped, right? So already as my data is unzipped, is going to ask me that, do you want to just replace all your images? So I said yes. So it's trying to like replace all my images, right? So basically it's taking a lot time there because I have almost more than thousands images in my data set. So if you look at my data set, you can see I have two parts in my data. One is training set, one is testing set. From there, if you can see, I have two folder. One is main folder, one is women folder, right? So main folder, I have lots of main images, and for women folder, I have lots of, you can see, these are the images I have. I will show you, and there is a woman image I have. So this is how I make my data set, right? Now, what I am going to do, I am going to fetch those data. So I have already said that we are going to mention our image width and image height. Okay. From there, I am going to take, say, this is my directory. So you can see from gender dataset phase, I have training set, right? And I also have testing dataset, right? So this is how I have cleared my directory. Now I said for my training sample, I am going to take 10 for each batch. But what does that mean? So basically, when we talk about epochs, epoch is basically the how many times your full dataset will be trained using the algorithm, right? So it's basically, it will try to take batch wise. So now we have batch. So how does this batch works? So you have, suppose, a batch size of 5, right? So it will take different type of batch, like one batch will have 5 images, right? So it will take each batch and it will just keep on training your model, right? So in that case, how many times it will train your model? It will train your model for 50 times. So this is the actual concepts of epochs and batch size. Now we are going to use a channel first. So what does that mean basically? So when I was talking that, okay, my image is basically going to have a dimension of 3. Then it will become image. Then you should have image width and image height. That is 150 and 150, right? So first check my image is already channel first or channel last. That is 2 options we have, right? So in any one option you can take for your images, right? So this is the format we want our data to be in, that channel first or channel last. Now I am going to import some of the Keras like libraries. But Keras is basically a API that is based on TensorFlow, right? And it already have this predefined algorithms we have for our convolutional neural network. Maybe this is come under GAN or whatever the algorithm we have under deep learning, right? This is already predefined and we just need to call those things, right? You can see over here, I said the convolutional neural network is always a sequential model. And you can see we have dense layer. Dense is basically the fully connected layer we have talked about. Now this is convolutional 2D. See, this convolutional 2D is basically, you can see it's already came convolutional layer, right? Then we have flattened layer that we have seen over there, that flattening your data to 1D array before you put your data into a fully connected network, right? Then we have max pooling layer, the pooling layer we have, right? Lastly, we are going to use an activation function. Okay, so activation function will be Vinay, I have one doubt. What doubt you have? Okay, cool. What doubt you have? Can you please let me know in the live chat? Yes. Fine. So activation is function is basically when we are going to already put our input data and we are going through a hidden layers. That time we use an activation function, right? So this is all the layer I have imported from Keras. Now what I need to do, now I am going to write our image generator. But what is this image generator stands for? So basically this image generator helped us to make different type of images, right? So rescale equals to 1 by 255 is basically normalizing your data. Okay, so basically this is something normalizing your data. And then there is called zoom range. It will going to zoom your like images, right? So why do we need that? Horizontal flip. So basically it will make one image into different type of images, right? So one image will convert into 3-4 images, like maybe one image will be more zoom, one image will be horizontal flip, someone is like the different flip, right? So basically why this is we are going to do it, basically taking the feature from an image, right? From one image you will not always get the proper high featured portion. So this is why we need to use image generator, right? So this is, you can see from here we found 1641 images we have belonging to two classes. That two classes our main and woman class, right? And the same way we are going to do for our taste data gen as well. This is basically we got how many from the taste data set, that 666 images that is belonging from two classes. Now let's have a look at how this basically this zoom in range and the strain generator works. So what I just said, let me just execute that. So just to do that, what we do, we use a Matplotlib, right? So Matplotlib is basically used for like visualizing our data, right? Okay. Now you can see over here this one image is more zoomed, right? You can see most of the images are zoomed and some of the images are flipped, because this is something we use to get, okay, what are the features we have from an image, try to read those images, right? A computer basically try to do that. Now comes the building your model. So how can you build your model? You can see I have written model equals to sequential. You need to call the function. So basically sequential we call when we know our convolutional neural network is a sequential model. Now we are going to add the layers. So what was the right? So basically we are going to use the convolutional layer, the first layer, right? Now you can see I have written convolutional 2D and then this 64. But wait, what is this 64 stands for? This 64 is basically how many neurons you want to have, right? So I want my output should be 64, right? Now this is 3 cross 3. This 3 cross 3 is basically your filter, right? The filter we are using 0, -1, 1, -1, right? So this is how your parameters works for convolutional 2D. Okay. Lastly, I said input shape equals to input shape. This is basically the channel first or channel last, that what way you want to use your data. You can see for my case it's already coming 150, 153. So this 150 is basically input image width, image height, and lastly the 3, that is what. So now from here what you need to do, now as you get it, now I'm going to use a ReLU layer, right? So ReLU layers is our activation function, right? So I'm going to call our activation function, and under that in the quotation I'm writing that what activation I want a ReLU layer. Then I am going to use a max pooling 2D. I hope I am doing the same thing, the thing I have shown in the presentation, right? You guys are actually understanding what we have. Now I say pool size equals to 2 cross 2. So you got it in the pooling layer also we have a matrix, right? So for my case, I given a size of 2 cross 2. Okay, so this is how our this is how our max pooling is working. It's actually help us to reduce the size of the data. And lastly, we have flattening way. So we also talked about now as you get your like most featured indexes, now you need to flat them to 1D array, right? That is 1D channel. And lastly, I need to put those data into fully connected layer. So this fully connected layer is known as dense layer. So what is the 64 basically? The 64 neuron you will have, if you can see over here, I have 64 neuron over here. If you want to change, you can change it, right? So I am going to put the 64 neurons with 3 cross 3 filter, right? Now again in the hidden layer, I am going to use our activation function ReLU. So this is optional. If you want to use, you can use it. So I used it because I don't want any unwanted value in my data, right? Lastly, you need to have a output layer. So that output layer will also be a fully connected layer, but in that case, you need to write how many neurons will be there. There will be only one neuron, right? So this is how our output layer works. Lastly, I want to, you know what? In the last layer, you will get a probability, right? In that time, you need to use a activation function again. So I use sigmoid for activation function. If you want, you can use ReLU layer as well. And lastly, I have a model summary. If you look at over here, so you can see I have 148, 148, 64. So what is this? This 64 is your neuron, right? After using activation function, again you have a 64 neuron. You can see I will constantly have 64 neurons. And lastly, I will get my output, right? That is 1. Okay. Now I am going to compile or train my model. So when we are going to compile, we need to use some optimizer. But why do we need to use optimizer, right? So optimizer is basically used because we need to have an idea how can you optimize your model, right? And loss, I say this is binary cross entropy. Why? Because I have 2 classes, right? So let me just do that. Okay. Now what I need to do, I need to feed. Basically, I need to train my model. How can we do that? Using, first you need to give that train generator your data, then your epochs, right? You can see your epochs, validation data, and these are all the things you need to have when you go for train your model. It will take few time because training model is actually taking few time. Yes, let me just check. Okay, you can see for per epoch it's getting trained, right? So our model got actually trained and the accuracy is kind of a 68%, right? For the training data set. Now let's have a look at what is for the testing data set. Let's just, okay, so model accuracy is not bad. So you can see over here, yes, so this is the model accuracy is not that bad. You can still improve your model. Now I am going to take a picture and I'm going to check if it's going to work or not. So if I need to check my picture, so maybe first I need to go for printing my image, right? So let me just do that. img is equals to, or maybe we can do it over here. Okay, so let me just show you guys if I can show you. Yes, there is a sad.jpg image I have. Yes, you can see I have this image for the prediction, right? So I want to predict this picture and the gender for this particular image, right? So let's have a look at that. So this is my image, right? So that is sad.jpg picture I have. And let's see what my model is going to say. It's a man or a woman. I don't know. My model is going to say this is a woman as well. Let's see what's my model is going to say. Oh my God, my model is actually giving a good answer. So let me give you an answer like what is actually working over here. So image dot load image is basically just to read your images, and my target image size will be 150 and 150. Why? Because I have trained my model into 150 image width, 150 image height, right? Then I have changed my images to image to array. You can see image dot image to array is basically changing your image to array, right? Now I am going to write that if my result is the array is equals to 1, the prediction will be woman, otherwise the prediction will be male. So lastly, I have printed my prediction, that is my prediction is male. That's quite right. Now I want to just print that to my image itself. Let me do that. Yes, in my image, when I have give that image to my model is saying, okay, it's a male. You can see it's already coming over here. It's a male. But how can we do that? Right? So we are going to use CV to put text. Right? So some of you are asking about OpenCV. So this OpenCV is basically a, how can I say, it's a computer vision library we have under Python. So if you want to do any kind of a computer vision, you can use this OpenCV. Right? So here we use a cv2.putText method or the function basically just to show our prediction. So we got our prediction over here. You can see that is male. I just put that in my image, right? So you can see we have got our answer that our image is basically a main image, right?
Now, next we are having out the demo for our Python project, that's our language translator. So from this particular place, I'll be taking you to my IDE, and that's my PyCharm IDE. You can use any IDE of your choice. Let's say Visual Studio Code, Jupyter Notebook, Sublime, Spider, PyCharm, whatever you prefer, like you can use about, but not the online IDEs. Only use the offline IDEs. Okay. Now let me take you further onto my PyCharm IDE, and let's first of all see the installation process. Further, we'll be writing out our project for the language translator. So here I am onto my PyCharm IDE, and let's first of all see the installation. Further, I'll be demonstrating you the importing and the rest of the things of the libraries. Okay, so let me go on to the terminal here. Great. You can use the command prompt or whatever you prefer like for the installation process. Okay. So my very first command for the installation is I'll be installing the GTTS. So pip install GTTS. I would zoom in and you can have a clear look. This is my command which you have to write up here once again. That's my command. Okay. You have to write up pip. Then you have to write up here install, and further you have to write up here GTTS. G will be small and TTS will be in the cap. Hit out enter. It will install up this particular library for you in some time. But for me, I did already install out this library. So it's showing me that the requirement is already satisfied. But for you, if you haven't downloaded this up till now, so it will take up some time in the installation, and further it will show you that successfully installed. Okay. I could do one more thing. I could write up the same command here as well. Once I could put that out. I could put up right and like this. My first command is pip install and GTTS. Okay, that's my first command. Now, further, what do I need? I need to install up my second library. Okay, so Tkinter doesn't need an installation, so that's pretty fine. I'll be installing up my Google Trans. Again, the command is same, pip install, and you're going to write Google Trans. Okay, Trans. Hit out enter. This is how your Google Trans library will be installed. In Google Trans, you do not need out any capitals or anything like that. Let me highlight that. This is the command. Okay, pip install Google Trans. For me, this is as well already installed, so it is showing me requirement already satisfied. But if you haven't installed that up till now, so for you it will show that installing, and at last it will show in successfully installed. Okay, Google, and here goes your trans. And let me close out this right here. Tkinter doesn't need installation, that I had already mentioned you about. So these are the two commands. You can write them onto you can use them onto the command prompt, or you are using Jupyter Notebook, whatever you are comfortable with. Okay, installation. Now I'll be taking you to a new notebook, and into that notebook we'll be learning about the practical implementation of our project for the language translator. Okay, so here I am onto my PyCharm IDE, and further I'll be writing up all of my codes onto this respective IDE only. Okay, before moving forward with any of the things, let me quickly tell you about this particular IDE, that what is it actually, and how to be use this out. So this is one of an offline IDEs where you write up the Python program to use up the Python programming language for making up your projects and even for writing up your codes. Okay. Now, I would refer you that you can use any of the respective IDEs according to your choice. You want to use Visual Studio Code? Yes, you can. You want to use Jupyter Notebooks? Yes, you can. If you want to use PyCharm, you want to use Sublime, whatever you just want to use, you can use that out. But one exception is there, that do not use the online IDEs. Okay. Because now this is a GUI project. That's the graphical user interface. It's a that sort of project. Okay. Now, the library which we'll be using up here, that is tkinter. So that tkinter library, you can't use that out onto the any of the online IDEs. Okay, you can use that out into the offline IDEs only. Okay, so I recommend you to use any of the offline IDEs according to your choice, according to your easiness. Okay, so I'll be using a PyCharm throughout this respective video for making up my project. Okay, so let's get started with making up of our language translator. Okay, the libraries which will be used, I did already give you the idea regarding all the three libraries that I used up into this particular project. The GTTS, the tkinter, and the Google Trans. All three I gave you the overview that what are these library about and what do these libraries actually do. Okay, so further now I'll be moving up and I'll be start installing up the libraries for me, and I'll be writing up the respective codes for me. Okay, so first of all, my libraries which I'm having, I'll be importing them out. So for the very first, I'll be importing up my tkinter library from tkinter import asterisk. Okay, now what does this line actually means? This line means that from my tkinter library, okay, from a tkinter library, I am importing up all of the functions which I am having up into this particular library. Now, why I am actually importing up all the functions? Because it can be the case that at some point I could put up the buttons, at some point I would need up a box, or let's say at some time I need up the drop down menu, the things like that. Okay, so individually importing all of these functions, it's not a tedious task, but yeah, it's going to take up some time for you to import all of these functions individually, right? So as to avoid up that particular thing, I am simply importing up all of the functions from my tkinter library. So that's from tkinter import asterisk. Okay, hope I'm pretty much clear with this. Now next I'm going to import up from Google Trans. From Google Trans, I'm going to import up the translator. Now, what is this about? Google Trans is yet another library with which we help, it is a sort of a library. With the help of Google, we use to translate out our languages into different language. Right, so this Google Trans is all about that. And from that, I imported up a respective function, that's my translator. Because what project I am making up a language translator, right? So into that, I will be needing up that function which will help me to translate one language into another. So if you want to do so, into that case, translator is the function which helps you to translate one language onto the other language. Let's say I want to translate English to German, or English to French, or English to Hindi, or Hindi to English, any sort of things like that. So translator is the function which will help me to do so. And this translator is a function which comes under the Google Trans library. Okay, so hope you got the idea that why from the Google Trans I imported up the translator. Okay. Next, my third library goes from GTTS. Okay, from GTTS, you have to import GTT capital S. Okay, so this GTTS is as well the Google Trans library. It is as well a sort of library which will be helping you to translate up your language into different types of languages. Okay. So that's the complete and even that's the clear idea regarding all of the three libraries which I'm using up here. Okay. Now, what will be the layout of my project? What will be the layout of my program? So what we'll be doing is that we'll be giving up the dimensions. I just want it in a rectangular manner. So I'll be giving up some dimensions according to that. Like my length will be somewhat larger and my height would be somewhat smaller. Okay, so I want it in a rectangular shape, so I'll be giving up the dimensions accordingly. Further, at one side it will be written that from which language you want to convert into which language. So let's say on the left hand side it would be written that I want to convert from English. On to the right hand side you will be having up a drop down menu. Under that drop down menu, as soon as you click, you will be having many options of different languages into which you want to convert your written text. Okay, then you'll be having up a space for writing that what text you want to convert. So into that, whatever the text you want to convert, you have to write that down. And in the center of that rectangle, I'll be having up a box, and that box will actually into that respective box, my converted language will be displayed. Let's say I want to convert English to Hindi. Okay, so when I wrote that I want to convert this sentence, let's say how are you. Okay, I want to convert this sentence how are you of English into Hindi. So in the center I'll be having up a box, and into that box only my translated, my converted sentence will be shown, and that's so into my Hindi language. Okay, that's the idea of my language translator program. Okay, now further into this perspective, accordingly you could put up some background colors, accordingly you could give different sort of colors so as to make it look more feasible. Okay, so I'll be letting you know those as well in the respective video only. Pretty fine. Let me just get forward here. And now the very first thing that you always have to do whenever you are using up the tkinter library is that you have to make up a window of that tkinter library. Okay, so I'll be giving up the variable tk underscore window. Again, the variable you could give according to your choice, whatever you want. Now, if you're using up the tkinter library, so into that the output which you will be able to see, a new window will open for you, and into that respective window you'll be able to see your final output. Okay, that is why it's our duty first of all to make up that respective window into which you will be able to see your output. Okay, so tk underscore window is equal to, I'll be writing up tk like this. This is what is actually my tkinter window. With the help of this respective line, I am making up my tkinter window. Okay. Further getting down here, I'll be setting up a geometry. So I'll be writing up tk underscore window, because tk underscore window is the variable into which I had made my tkinter window. Right? So for rest of my program, at each and every place, if I want to insert something, if I want to put some color, if I want to give some dimensions, if I want to put up any button, or if I want to put up any box, anything like that, I will be using up this tk underscore window variable. Okay, for the rest of my complete program. So tk underscore window, and here I'll be having up the geometry function. So geometry. Okay, and into the bracket I'll be setting up the geometry. Let's say it's 600 cross 300. Now, one very important thing to mention up here, where many people actually made the mistakes and finally they are not able to figure out the error which they are making. So it's not that multiplication sign. Okay, it's the character which is x, a small x alphabet. Okay, that is it which we had put it up here. So make sure not to put up the multiplication sign, put up this x here. Okay. Now, if you just want to give up any background color to your tkinter window which is gonna appear, so yes, you could do so as well. Let me tell you how. So it's tk underscore window dot, it will be config. Yes, config. Into the bracket, write up bg. bg is referring to your background. Okay, and what background color you want to give? Let's say I want to give it here as light pink. So I did mention that out. Now, whenever you are using up the tkinter library, Let's say whatever the things you did want to write, you wrote up everything. Now, further you want to finish up your program, let's say. Okay. Now, into the tkinter library, it's very, very, very much necessary for you to put up a function which is main loop at the last. Let me show you how. So, tk_window dot main loop. What this main loop does, it actually a sort of it gives the indication that yes, at this particular place your complete program has been completed. Now when you run up your program, you will be able to see your final output. And if you are not using up the main loop function, so into that respective case, you won't be able to see any of the output of your program. Either you are getting the error or you are not getting the error. If your program is completely error free, then also if you haven't mentioned up this main loop function at the last of your program, you won't be able to see your final output. Okay, so make sure. And this respective line has to be written at the very last of your program. Okay. So yes, this is what it is appearing. Now let me show you that how the tkinter window actually looks like, and then further we'll be moving forward with the rest of our things. Okay. So yes, this is how my tkinter window actually looks like. Pretty fine. So this is how my tkinter live window actually looks like. So this is a light pink color which we did give up, and tk is already mentioned up here. That's my tkinter window. Okay. I haven't mentioned up anything inside that, so nothing is coming up here, simply my screen is coming. Okay, it is of the dimension 600 cross 300. Okay, I would just now stop running this out now. Fine, done. This is all sorted. Now what is my next task that I have to do? My next task is that I have to put up the boxes here, the entry boxes, the buttons for translating the language, and all those things I have to put it up here. Okay, so let me just get down from this particular place and let's start writing up all of those respective things. Okay, so first of all, what I'll be making up an entry window. Okay, so my variable goes entry underscore window. Entry window means that into which you will be able to write what is the text which you want to convert. Okay. So into that I'll be using up the function which is entry function. Okay, I'll be using up the entry function because this is the function which allows you to make up the entry window into which you will be able to type or write anything. Okay. Into the bracket, I'll be writing a first of all tk underscore window variable into which I have made up my tkinter window. Okay, comma. What will be the background of the entry box? So BG I want to be in, let's say, BG I want to be in the black color. Okay. And what about my FG? FG is my font color. Okay, you can say it as foreground, or FG is my font color as well. Okay. Font color I want to be the white. So my background will be black and my font color will be the white. Okay. Further, what will be the font size for you? So font size I will be just defining those about. Let's say my first of all the writing of my font will be Arial. The size I want it to be 16, let's say, and I want the writing to be in bold. Okay. Let me do out one thing. Yes. Okay. So my font will be the Arial. The respective size for my font will be 16. And I want my font to be in the bold handwriting. So this is what I did. Now here you could give any of the respective fonts according to your choice. Okay. No issues in that case. That's done. Now what I would do is that I would simply give up here the dimension where this entry window has to be placed about. Okay, this entry box has to be placed about. So entry underscore window, okay, dot, and here I have the function which is place. Now place is a function which allows you to give up the x and y dimensions, x and y values to place up any of your respective thing. Okay. Let's see now into this particular case, I want to place up my entry box. Okay. So onto that particular case, this respective function, that is the place, which will help me to allow and it will help me to put up the entry box onto a respective place. So pack, and here my let's dimensions are 20. And let's say I want to be 60. Okay, 60. Fine. Pretty fine, that's done. Now if I run out my program here for a quick, so see here you are able to see up this entry box, and yes, you could write up anything onto this respective one. Okay, done. I would just close this out now. Okay, fine. And is y value, I could take it as 40. That would be, I guess, more feasible. Let me just check it out once. Yes, it's a little bit upper only, and then that's working. Fine. Okay, fine, that's done. Entry window has been made up. Now next, what do I have to make? I have to make up that drop down menu. Okay, with that drop down menu will be having different sort of languages which I want, right? Onto which I want to convert up my text. So drop down. Okay, drop underscore drop down. That's my variable name. Into that, first of all, I just want to write up here that what sort of things will be giving. So that will be all will be my string var, right? So string var, that whatever the like names will be there into this drop down menu, all will be belonging to the string into this particular case. Okay, great. Now further, what do I have to do? I will simply once again use up this drop underscore down variable which we did make, drop underscore down. I'll be putting up a dot and I'll be using up the set function. Now what has to be set up here? Like that drop down which is gonna come up in the very starting, what do you want to write? I want to give it a text in such a way that it will be select, or I could just try choose language, but select would be more like good. Okay, select lang. Like this, right? So this is the drop down menu which I just wanted to write up here, and this is the respective text which I wanted to be displayed up. Okay, now what I'll be doing is that I'll be giving it up the dimensions and setting up the background color, setting up the foreground color, the size, everything I'll be doing up here. Okay, so how to do that out? Okay, drop underscore down was a variable which is actually already made it out. Now what I could do is that I could simply make a one more variable. Okay, so okay, list underscore lang. Okay, my variable name, language list. Okay, so into this I could give up the function which is option menu, my respective function which will help me to make up the drop down menu, and into that you'll be having up different options of different languages into which you want to translate your text. Okay, so option menu is the function which will help you to do so. So option menu, into this I'll be first of all writing up my variable into which my tk enter window is there. So tk underscore window, right? Next, what's my option? So that will be my drop down, the respective variable which we did make. So drop underscore down. Okay, and what do I have? I actually have to make up a variable. Okay, for right now I'll be making up an empty list. That will be lang underscore choose, lang underscore options. Okay, and I'll be making up an empty list right now. I'll be afterwards filling that out. Okay, and this respective I'll be putting up here. So lang underscore option. Fine, that's pretty much done. I guess I just did out. Further, I will have to give up some configurations about my background, about my foreground, about my font and everything. Okay, so now what I'll be doing is that I'll be getting up here, I'll be writing list underscore language, my variable, But I'll be using up the configure function. Okay, now into the bracket, I'll be using up the BG color. So my background color, I want it to be, let's want it to be yellow. Okay. Okay, I have to put up the double quotes and let me just get up some space here. Yeah. Yellow will work. And then after that, I just want the FG color. That's my foreground and my font color. I want that to be into the black. Okay. What will be the font size and everything? So I want my font equal to, that will be Arial. Rather than I want the size to be in the 16. And even I want all the languages to be in the bold. Okay, this was all which I wanted, so I'll note that down. Further, I have to give up the dimensions that where to put that out. So list underscore language variable dot, here will be my function. This is placed, which will help me to give up some x and y dimensions, x and y values. So x will be equal to the 400, and let's say my y is equal to 4. Okay. So this is something which I did give up here. This is something which is simply mentioned by me at this particular place. That's my option menu, my drop down menu. Okay. Now, next what I'll be making up, I'll be making up the second label. Okay. Now I'll be making up some few labels here. And those respective labels will help me to display up my translated text and all those particular things. Okay, let's make those things out. So I'll be writing up one underscore label. Okay, my variable name. So that will be equal to here, as I'll be using up the label function. Now, whenever you want to write up something onto the tick enter window, you always use up this label function. Okay, whenever you want to write up anything, you always use up this label function. So into this, I'll be writing up tk underscore window. Okay, tk underscore window. Comma, what about my text? So I want my text, okay, I want my text to be like this something. Okay, that will be 6 right here. Now, okay, I am simply giving up the spaces here, nothing more than that. Okay, fine. Now, what about my background color? So, my background color, I want up to be for this label as, let's say, black only. Okay, comma. And what about my FG color? FG would be white only, let's see. Okay, putting up a comma, getting down. Let me just get down here. Again, displaying up my font values. So font values, I'll be writing up into a form like here I have the Arial. Size I would be increasing up now, let's say 42. And I'll be writing that up into the bold language. Okay. Getting down and placing this one underscore label. So one underscore label dot place function will come up here. And now I have to give up the value. So value for x will be 0. And the value for the y will be 120. Okay, let's say these are my values which I want to give. Fine. This one is made. Now, second, I will be simply making, okay, first of all, I will be writing up a translated text. I'll be having up a text place. And into that place, it will be showing translated text. So after that translate text, I'll be having up a button of translating. So as soon as I click on that respective button for translating, what will happen? At the place where it is written translated text, my real translated text will come up there and show us as an output. Okay, this is what is going to happen about. So here I'll be writing up a 2 underscore label. That's equal to, I'll be writing up the label function here. Okay, inside that I'll be giving up the tk enter window. So tk underscore window. Okay. Comma, what's my text which I want to mention up here? So text I want it to be in the form in the translated language. Let's say this is the thing which I want it to be. Okay, comma. Now, what about my background color? So I want this background color of mine to be in the white color. Okay. And what about the FG color? That's my font color. And this time I want it to be in the red. What about the font values? So font will be equal to here as like Arial. Okay. Then we'll be having the size again 42. And then here I am having the bold. This is the font size which I want. Okay. Further getting down, I will be rounding up to underscore label dot. Here I'm having up the place function, that's where to place that out. Okay. So value for the x will be 180 and value for the y will be 140. Okay, value for x will be 180 and y will be 140. Okay, that's pretty much done. Now, next what do I want? One second, let me get down right here. Now I'll be making up a button. So that will be a button onto which it will written translate. That will be written onto that particular button. As soon as I click onto the button, it will show me the translated text. Okay. So here I'll be making that out. So translate underscore b. Okay, my variable name. The function which I'll be using for making up a button is this button function only. But b will be capital for this. Okay. Further, I'll be writing up the tick enter window into which my tick enter window is stored. Next, what is the text which you want to write up onto that button? So I want to write up onto that button somewhat in the way, let's say, translate. Okay. Further, what will be the background color for that button? So background color, I want it to be into a manner, let's say it would be green. Okay. And what about my FG? FG, I will be keeping this as white. Okay. And about the font, so yeah, font will again be somewhat the same values only a little change will be there. Font is equal to, firstly it will be my Arial. Okay, let's say it will be 26, the font size, and it will be in the bold as well. Okay. Now, further after this, what I'll be doing is that I will be having up an option for simply giving up the command as well. Okay, I have to give up the command here as well. So what I would do, I'll put up a comma and here goes my command function. Now, into this command, what I will be giving, I will be simply giving up the values. I'll be simply giving up my command function at this particular place. So for that, I have to define up a new function, and into that respective function, I'll be writing up the main command of my complete program. Okay. So first I'll be going above and defining up that command function. So let's say I'll be coming up somewhat at this particular place. One second. Right here. And I'll be writing div. And let's say it will be translate underscore language, my function name. And simply I would be writing up here as pass for now. Okay. And inside this, I'll be passing up the same function, translate underscore language, but make sure one thing, that you do not put up the brackets after this translate language function. Okay, after this particular function, you do not put up the brackets because that's not at all needed. Right, so hope I am pretty much clear up to this particular place, whatever I did wrote up. Now further we'll be defining up the functions, giving up the choices, and rest everything now we'll be doing about. Okay, so now further I'll be giving up, first of all I'll be filling up this lang underscore or function, then I'll be moving up forward with the rest of my things. Okay, so now into this particular case, what I'll be doing is that I'll be giving up different languages. Now I'll be giving up those respective languages in, I'm sorry, I have to put up equal to. Right, now I'll be giving up the languages in such a way as I want them to appear into my drop down menu. Okay, we want that to be appearing in the one by one format. So that is the reason. I'll be giving up all of the languages in the 1 by 1 format. Let's say I would just put up here, let's say it's Hindi, okay, comma. Let's say it's English, comma. Let's say I am having Spanish. Okay, let me put that double inverted commas. Spanish, okay. Then let's say I'm having a German. Let's say then I'm having a French. Okay, let's say I'm having this French. Where is that F gone? Great. Okay, let's say these are the only languages in which I just wanted up the conversions. Further, according to your choice, you could add n number of languages, whichever you prefer like. Okay, that's done. Now let's do it one quick thing. Let's run out our program up till this particular place and let's see what's gonna happen and like what sort of output we are getting up here. Okay, so translated language is too big. This is my button, I guess. So yeah, this was my translated language or some button. And this is okay, pretty fine. So select languages option is, let's say I select French. Yeah, this is coming. It's pretty fine. Okay, translated language is to be changed upon because the dimensions actually have to be changed, right? I would just close this out about. Okay, what did I give here? Did I give any button value? I guess I didn't give. Yes, that was the mistake. Let's give out a button value here. Let's write up here in the form button. What was the variable name? It was translate underscore b. Okay, so it is translate underscore b dot. Here we'll be having the place function. Okay, now where do I have to place it about? So I want to place it at, let's say 220. X will be 220. And let's say y value will be here again, let's say same 220. Okay. Yes, that's pretty much done, I guess. Let this be in the 25. Command is done. This is done. This is done. Okay, let's run that out now. Let's check it about. Okay, this is my button, my translate button, which is coming up, and this translated language has to be a little bit more above. Okay, pretty fine. That works. Let's make that a little bit more above. So what I could do is that simply I could just give up the different sort of values. Okay, let's do that afterwards. First of all, let me define up the complete function. Then we can do up that respective thing afterwards. Okay, let's first of all define up the complete function of ours. Right, so now this language underscore option, I just filled up all of those like languages, and those are completely coming up correctly into the drop down menu. Right, now what do I have to do is that I have to make up this particular function. Okay, that is translate underscore language. Okay, now into this I'll be writing up, let's say O1. Right, okay, let that not be, let it be N1. My variable name, okay? And you remember I made up an entry box. Right, that was entry underscore window. So I'll be using up that same entry underscore window variable dot get. What it will help me to do, it will help me to get the like whatever text I have written onto the entry box, whatever the entry box we did made and whatever the text I have written, it will help me to get up that respective up here. It will help me to get up that respective box here. Okay, now that's the particular thing which is coming out. Okay, so that is the reason we used up this get function here. Let me now just get down at this particular place, and I could use N2, my next variable, and into that I'll be using up my translator function, which we did actually import it out from my Google Trans library. Remember, the second line which we wrote out of our program was from Google Trans import translator. So now this is the thing which we didn't import out, that from my Google Trans library, I am importing up the translator. Okay, let me just get down here. Further, I'm having N3 as my variable, and into that now I'll be having up a respective function, and that respective will help me to get up the value. So we did made up that downside. Remember, I just made this drop underscore down. But I'll be using that up to this particular place. So it will be drop underscore down dot, and it will be again my get, because drop down, whatever is saved up into the drop down function, I will be wanting up that, so that in whichever the language we want to convert about dot get. Okay, now in after this, now if my drop down list which is being selected, if my n3, okay, if the drop down one which I have selected, if that is, first of all I did wrote up, what did I wrote? Okay, first was in Hindi. Okay, if this is equal to Hindi, then in that case, what do you have to do? You have to write up here a variable. Let's say it's CVT. Okay, and not CVT. Let that be change. Okay, so now we have to change it into change is equal to HI. You remember that these are the short forms which you have for different languages. Okay, you can go onto the Google and there you could get up the different abbreviations for the languages that you have to use about. Okay, in Hindi is done. Now elif, my next condition goes elif entry, like whatever the language which is chosen by the drop down menu. Now if that language is English, so into that case, what do you have to do? You have to write change. Now change will equal to en, right? En is the abbreviation for English. So it again goes elif. What's my next language? Hindi, English, Spanish. Now if entry is equal to Spanish, okay, then into that case, what will be the change? So change will be equal to ES. ES is for the Spanish. Okay. Next, again your condition goes after Spanish. What do we have? We have German, then we have French. Now if entry is equal to German. Okay, if entry is equal to German, so into that case, so change will be to, it will be DE. This is the abbreviation for German. And here my last condition, elif entry is equal to, and this time it is French, right? Yeah. So my change will be equal to, let's say FR. Okay. So you can get up these abbreviations onto Google and you can just simply use that out. Now I did use up only 5 languages here. So I wrote that out only for 5 languages. The number of languages you are writing, for that number of languages, you'll be putting up different conditions. Okay, great. Now here we'll be having up a function, a variable that is text underscore translate. Now that will be equal to, now right, you remember above we just made up N2. N2, what was it having? It was having my translator function. Right, so I'll be now calling that out. So here goes my N2 dot. Here we have the translate, N2 dot translate. Now what do you want to translate out actually? I want to translate up this respective. Okay, whatever the N1 we did give up here, I want to, one second, I want to translate that out. First of all, I'll be writing up here N1, comma. What will be the destination of the translation? So destination will be the change variable, which we did actually have made up here. This one. Okay, this is done. And now getting down, I'll be writing up here again. It will be text underscore translate is equal to, and again it will be here text underscore translate dot, and this time it will be my text. Okay, dot text. So whatever the text you're having, that respective one would be actually changed out here. Right, now further getting down, now what do I have? I'll be making up one more function. Let's say that one more variable. Let's say that's N4. What will be that about? Into this I'll be using up my GTTS library. Okay, what is my text actually? So my text is my text underscore translate variable, right? Text underscore translate variable, comma, and now here I'm going to use up the function which is slow. Okay, so for slow, I'm going to do it as, set it as false for now. And what is my language? So my language is here change. Okay, this respective one, that is my change. And getting down here, you remember we just made up two labels, right? We made up two labels. This label I'm talking about now. Okay, this two label, 1 second, this one label and this two label. Let me do out one simple thing. Okay, let me do it one simple thing. This one label and this two label. These two are I have written up here differently, right? Let me just give them a similar one. Okay, I'll be making this as two underscore label, and this as well I'll be making it up as two underscore label. And now here what I'm going to do is that getting language is equal to change. Okay, now getting down at this particular place, I'll be using up that yes, two underscore label, two underscore label dot. Here we have the config. Okay, and now what's the text into that? So my text will be my text underscore translate. Okay, my text underscore translate will be my real text. Okay, so now what I have to do, I have to copy this out, Control C, and I'll be putting this out just below the respective function here. So just below this, I'll be putting it about, and I'll be removing this out from here. Okay, like this. And yeah, my tick enter window is actually already made it out. Right, so translate underscore language was the function I did already give up here as in the command. Right, that's pretty much done. Now what do I have to do? I have to simply do up one single thing, that I have to make up the things in a clear way, right? That I have to give up the things in a clear way. So what I could do is that I could do up a one thing. Yeah, here what I could do, whatever the values I have given, it is white and red, and this as well I could give it as white, 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 and this as well I could set it up here as in the red. Okay, like it was coming up a different line, remember? So I could give up the similar values to these respective positions. And now what if I run out my program now? So let's see that what's gonna come up as an output. Okay, this translated language is quite large, which is written up. Let me reduce up let's reduce up the size for this, because yeah, it's coming too much bigger as coming up there, right? So I could do up one single thing. I could give this value as a 40. Translated language, yeah, that's pretty much done. 180, it's 180, 140, that's done. Yes, we could give up these respective values, but instead of that, what if I go with 30? I guess that would somewhat work. Let's see that out. So I could run it out here. Yeah, translated language, now it's looking a pretty fine thing. Now here I have to write out what I want to translate it out here. I could just increase up the size like this, yeah. Let's say I want to write up that how are you. Okay, this is my term which I want to this is the thing which I actually want to translate. In which language I want to do it in the Hindi, let's say. And if I click on the translate button, okay, we are having an exception. Let's read that out here. So error, get data info fin correction error. Okay, let me do out one simple thing. Self 20, line 75, 75, 85, 12, line number 12. Okay, let's take that out. So right here above, we are having okay, change is equal to HRM. That's pretty much done. Okay, so now let's check out the final output of our program for the language translator. Okay, but before moving forward with the checking of my program, I just want to make up a quick correction into my program, and that's I just want to make up this entry window. Like we had given up the font size here as 16. Right. I just want to change out that and make it a little larger, because in between of the project, when we just when we just ran out of program, so into that case, I hope that you have noticed that on left hand side corner, we were having up our entry box of the black color, right? And it was pretty looking small. So let's do it one thing. Let's change up that out. Let me write up the size for my entry box as 20. I guess this would actually work out here. Okay, now let's run out our program. Let's check out the final output. Then further, I'll be giving you once a recap of what we did in this particular project. Okay. So let me run that out very quickly here. So yes, here we click on the run. Great. So yeah, it would take up quite a little time because, okay, one more thing, that it's necessary for you to be connected to the internet for running out your particular program. Okay, pretty fine. So yes, here's my final output. Here, this is my entry box, is black color. Okay, I'm gonna write up here. Let's say that how are you? Okay, let's say my text which I want to convert in some other different language. Okay. From here, I could just click on the drop down menu, and here we have different languages for which I could select out that for which respective language you want to translate out the text. Let's say I want to do it for Hindi. Okay, I clicked on that. Simply, I can click on the translate, and where it is written translated language. See, here I got up my output, that's aap kaise hain. That's the conversion of how are you. That's in English in Hindi, right? Now, let's say I want to convert this how are you, that same thing, onto, let's say, German. Okay, I clicked on German and I click on translate. See, at that respective place only, my text got changed, right? So that was the reason actually. At every time, you remember, I used to write up here, and 1 second, let me get above here. Not that place, yes, this respective place. I used to write up here somewhat like this, somewhat like false and all those respective things, right? So that is the reason that I was writing about all of those particular things. So that again and again, I do not have any of the need for running about my project. If I go up here and now if I just erase that out and I'm just, let's say I write, I am going good, okay? And I want to convert that into Hindi, let's say. And I'm going to click on translate. So into that respective case, see, it translated my English text, I'm doing good, into Hindi, that's मैं अच्छा कर रहा हूँ, right? So onto that respective case, you do not need to again close your app and again open out your language translator app. If I click on, let's say, French, and I click on translate, so yeah, here that's the third term which is I'm doing good into the French language, right? So I'm going to close out the output from here. Okay, now what are the changes that you could make up onto this particular project according to you? So you could add some more languages, like I did add up only 5 languages. You could add any n number of languages according to your choice. Further, you could change the dimensions, you could change the color of these respective things, and yes, you could just change up all of these respective things, right, according to your choice, whatever is actually needed about. So what we did into this particular project is that we imported out our libraries, tkinter, Google Trans, and GTTS, right? These were the 3 libraries. Further, I did wrote up here translate underscore language, and that was the respective function which we did made out for translating out text that is written to English in any other different language. All of the things were done up here. Here we made up our tkinter window. The dimension is given up here. Here goes my background color. Further, now what are the requirements I wanted up here? I wanted up an entry box. Further, I wanted up a drop-down list where I'll be having an option for selecting any language in which I want to convert. Then I wanted up a space where my final output will be displayed. And further, I wanted up a button. So a translate button. So as soon as I click onto that respective button, my final output should come up there. Right, these were all of my requirements which I actually wanted up. So onto that particular case, this was the output which we actually get out here, right, after writing up this complete program. That was our final project, which is actually here for us. Right, so I hope that you are pretty much clear with this particular project. Hope you got up the idea as well, that how to implement out and how to make up a language translator app with the Python programming language. As I have used up the tkinter libraries, it automatically becomes up an app right here. Okay, so hope I'm pretty much clear with all of these respective things.
Introduction to generative AI applications, which is the core concept which we have to learn. Generative AI refers to algorithms which enables machines to produce content that is not only new and original but also includes a reflective data, and it will be always trained according to the requirement. Right? Generative AI deals with a lot of models. What does these models include? GANs, that is Generative Adversarial Networks, VAEs, variational autoencoders, and transformer-based models such as ChatGPT, right? What do we do with this generative AI applications? It's very important in order to train the algorithm or the machine in order to keep it updated. The more you interact with this, the more it gets trained. That's how simple it will work. And generative AI helps you to generate your own models. How you want to train that particular model, you can train it accordingly. Just like simple example, how does the scientist train the robots? Each robot will do its own different work, right? Hope you would have seen. The requirements are different. The catering of requirements is different. Hence, the models will be trained accordingly with the help of generative AI. Yes, it includes a lot of other technologies, deep learning, neural networks, etc. But still, generative AI is also a base of it. What is the significance? Creativity boost. It creates enhances processes by providing very good content ideas, new content ideas, the new way to approach the problem. Efficiency. It is giving a helping hand to human beings in order to be more efficient. The more good you use, the more productive you will be. Automates the content creation or saving time is very much important. It's an important resource now. It aids to this particular saving time resource. Then personalization. It generates particular personalized content as per your requirement, as per the prompts you give to ChatGPT. That's how it works, right? So it will cater various applications for the same. This is the overall picture of generative AI applications. Now, let's talk about the next concept, development environment setup. How do we do this? What is it all about? You have to have a platform in order to work with. You need to have a basement in order to build a building, right? So let's learn how do we build this particular basement. So what does this thing consist? It consists of few steps in order to set up a particular environment. It is not dealing with much higher softwares or something from moon and stars. It's very simple. You have to go to Python official website and download the latest version. For now, it is 3.12. You can download that Python into your local system and you can execute this via command prompt, right? First step, we have to open command prompt, which we have in our local system. And then we'll have to navigate to the location where the Python is installed. Hope everyone are having a clear idea of how do you work with Linux and Unix. At least basic commands like cd, change directory, mk, make directory. So only these two commands are mostly used in this complete session. I'm not going deep into advanced level of Unix, Linux and all. If you want to work with a command prompt, you have to just use cd and mk command and you can make directory or change directory. Simple as that. If you're using Windows, you can use command prompt or PowerShell. For Mac OS or Linux, you can use terminal. This is the platform you need in order to work with. After navigating to the location where the Python has been installed, you can install all the libraries using pip command, right? So pip install is a basic command and you can change the libraries you want accordingly. First, we will talk about Numpy. Numpy is very well known amongst the domain called data science. Why? The first thing is Numpy will always cater in order to help the mathematical calculations, also working with high-level data structures and give you the complete access to the functionalities and arithmetic and logics. That is why data science is dealt with lot of data, numbers and other elements. We use Numpy for the same. Then we talk about Flask. When you hear the word Flask, it is a library which is related to Python where it is web-based framework. You can create web application using this particular Flask framework. That is the major help of using Flask. The next one is Streamlit or Streamlit. This particular library deals with visualizing the models created. Then you have Torch Vision and Torch Audio. Basically, this library caters computer vision models. You can work with the model creation, you can view the model, and also you can add certain multimedia to the model created, right? You have this Torch library in order to cater computer vision projects, models, etc. You have Transformers next. Transformers will always help you in classification, text summarization, many other aspects, again dealing with data. And majorly, we use all these libraries in machine learning, artificial intelligence, NLP, natural language processing, and deep learning, also computer vision. This is the applications of where this particular library will be used. Using pip install, we are always installing all this library single-handedly, not in mass library installation. Every library will be installed along with the execution output command stating it has been installed. It will show you it is installed. Now, still you don't trust. How do you check it? Verification of the installation is very important because since we are working with machines, sometimes it might help you to have a better vision when you verify. If you don't verify, if the installation is crashed, you never know. It will affect your project. So better verify once you install. It's very simple. In order to verify as well, you can open command prompt and type Python _version. It will ensure it returns the installed Python version. What is this particular version you're working with? Next, you verify the installation of the libraries. For that, you have to just go open Python interactive shell, type Python, and then import every library which you have already installed. If it is imported properly without any error, then it is installed properly, right? So this is the overall development environment setup idea which you have to have and which you have to create in order to do coding, in order to create certain applications or work with a project. Now, we are in the command prompt. In theoretical aspect, we have known about various libraries in Python, that is Numpy, Flask, Streamlit, Torch, Transformers. Let's install the same libraries with the help of command prompt. First, if you could see, it's in a general path. It's in my personal path, but yeah, it is in C drive. Now, in my personal laptop, the location of the Python is being fetched. For that, I have to use cd command, change directory, paste the location where your Python has been installed, and then press enter. When you do this, the command prompt goes to this particular folder. Let's start with the first command, pip install Numpy. Now, since I've already been working with Python a lot many times for many projects, you will get an output. Just wait and watch. I'll click on enter. It might take some time. It will try to analyze what's happening, what they are trying to install, and requirement already satisfied. This is what you'll get the output. That means Numpy is already installed in your particular system because we were already working. And there is a warning message you could notice. If you want to upgrade the particular library which you are using, you can go for the version mentioned. I am currently using 21.2.3. It is suggesting upgrade for 24.1.2. Then what is the command for the same is also been mentioned here. You can use that command. We have now installed Numpy, which was already existing. It is given the message. If in case it's a new installation of library, how it will display? Let's try with other libraries as well. Pip install Flask. I'm giving enter. Let's wait for the results. Again, if you could see, it states Flask is already present, that is satisfied. Again, you have a warning regards to the version. I have almost installed all the libraries, but let me check for the next one. Streamlit. If you could see how it is downloading the Streamlit library, if you are trying to install the library which is not in the current local system in your Python, this is how it will start loading. If it is already existing, this is the message which you got for Numpy and Flask. When you try to install Streamlit library which is not present in your Python, this is how it starts downloading, and it takes 5 to 10 minutes at least to complete the download depending upon your system configuration. Likewise, you can install all the libraries required for you into your system, right? So I have given 2 examples. One, how it will download the library which is not in your system. If you already have downloaded the library, how the message will pop up. That is, requirement is already satisfied. That means it is already installed, right? So this is how you import your libraries in Python. Now, in order to verify is your particular library is installed or not, first it will try to prompt you that it is already existing. If it is not, it will start downloading as mentioned. Now again, in order to verify that, you have to go to Python interpreter. So I'll click onto the same particular location, type Python here. When you click enter, it will go to the Python interface where you can execute your code. Now what you do is you try to import Numpy. When you try to give this particular instruction to the Python prompt inside the command prompt which we have logged in, it will try to enter or import this Numpy library which is already existing. When you type the statement import Numpy, if your Numpy is present, it will not throw up any error. It will look just like this. This indicates your Numpy is there in the Python library folder. This is how you verify the libraries which is already installed before using it. Or else if you mention in your code as well, it will throw up an error if it is not installed before. Make sure you install the libraries, then use it in your code. This was a simple demonstration of how you install and verify if the library is present in your Python with the help of command prompt. Now let's understand introduction to OpenAI GPT API. How this particular thing works and what is OpenAI first of all. What is OpenAI? It's a company where it will cater in order to work with chatbots, generative AI applications, different kinds of models, LLMs, etc. Basically, it is dealing complete artificial intelligence domain which is booming nowadays. OpenAI has a platform where you can generate the API keys and you can integrate those into your applications. API features. What are the features it will cater for? Text generation, completion, and conversation capabilities. So, talking about text generation, it is always dealing with providing a new text which is not in your imagination with one small question. Say, I want a poetry on so and so. It will give you a complete poetry where it is not plagiarized. It has been trained in that level. It can think about writing poetry. It has lots and lots of data behind how it is dealing with that, what is to be categorized. There comes classification, summarization, and many other machine learning and data science models, artificial intelligence models, which is giving you the answer pre-op. Next, completion. If you give a prompt in an incomplete way, it will try to complete that. If you give with a spelling mistake, it will correct your spelling and ask you back, was this your idea? do you want to search so and so thing? It will question you back in an interactive conversational way. What we do with ChatGPT? It's the conversation. How it will answer us? With the help of already available data. It has been trained on and it is updated every time you talk to it. That's how the model works with. So these are the few features we have. Next comes to fine-tuning and customization for specific tasks. Say you are building certain module which has been integrated to your application. You are using OpenAI platform. You can generate your own model. It can cater to your own set of questions. Say, for example, chatbots in some or the other shopping websites or jewelry shop websites. It will try to ask you what you want. There are lots of chatbots which will address and also will help certain percentage of customer care services without human intervention, which can be done with the help of machine. 100% it will be solved. Other aspects it cannot. A very good example for this is Swiggy, right? You can give a set of questions which is already present. Where is my order? Delivery guy is not moving. So when you put this, my order is getting delayed. It will give a set of answer which is already there. What is the current status? Still, if you're not convinced by the bot answer, you can go for an agent talk. You can talk to a human being where they'll interact, they'll call the delivery guy and ask what is the situation and update you. Something like that might happen. Before introducing your particular chat directly to the agent, they'll try to solve with the help of bot. That means we are trying to reduce the work which is put upon humans. We are using the technology in order to address the same. This is the best example for the feature which is currently in use in the apps which we use in our day-to-day life. How do we get started with this API? We have to just log on to OpenAI website, create your account, sign up, or if you already have an account, sign in, log in, generate a API key and keep it. Why you have to generate a API key? I'll let you. After $5 of content, you have to pay in order to improvise your API key. In order to improvise your API key usage, right? You want to know more about what is OpenAI, how does it help for GPT API, everything, you can just go to the official API documentation and understand more about this. Now, let's understand how do we generate a OpenAI API key. For that, you have to go to Google, type OpenAI login. Once you click on login, if you've already logged in, you will get two options. One is to go to ChatGPT, another one is for API. You click on API. Once you click on the API, this is how your OpenAPI platform look like. You could see a menu here towards your left stating API keys. If you click on that, it will launch API keys. Before that, I would like to tell you, I was talking about the GPT models, right? So these are the models available for now. GPT 3.5, Turbo, 0125, 1106 and 16K. These are the models. You can select the model and you can work on. Let's come back to API keys. I'll click on the API keys. This is how the API keys generation look like. And if you want to create a new API key, click on create new secret key and you can name that particular one. I'm naming it as demo. You can also give the restrictions if you have to control certain things. It can be a read-only, restricted or all, just like the share option you have in your Google Drive for your Google content, right? So create a secret key and it will generate and display the secret key there. You can copy and paste it in one particular notepad so that you can use it again and again. It is taking certain time to generate the key. Once it is done, it will display and you will also have an option called copy for it. Here we are. It states API key is generated and you can copy the key. You can press as done. See, you have to save the secret key somewhere. because it won't be viewed again due to security reasons. That's why you have to keep it discreet and noted in a notepad separately. You cannot get it back again. If you want to, again you have to create a new API. You cannot copy this complete API key again. The created API key is listed in the list here. Again, you have the options to edit the key. You can just change the name and permission, nothing else. You don't have access to again copy the complete key, and you can also delete the existing key. This is how your API key page look like in OpenAI platform. Hope you are clear how to generate these and save it in a place and use it for your coding. Now let's talk about Flask ChatGPT app. We are integrating OpenAI source to our application. That is the main agenda of it. Let's understand more about this application. How do we work with this, and also look at the demo for the same. What is the basic setup we need is as simple as that, which is mentioned before. You have to have Python installed in your system and all the libraries mentioned to be installed in your system. That's the basic ideology for all the demonstration which is carried in this session hereafter. The components we need is Flask for web framework. As I mentioned, we use Flask of Python library for web framework, and then OpenAI GPT API for generating responses. A simple logic, we are taking a API key of OpenAPI, putting that in your Python code, and then we are trying to execute the same. First, we will check how this particular code look like and what are the in detail steps in our Google Colab. Note, I am not executing this in Google Colab. I am executing this in command prompt. But for a better clarity, I am using the online coding platform, that is Google Colab, in order to have a good interactive and bifurcation between the text and the code, right? Google Colab is a very good place in order to work, in order to have a good Python content on. Let's check out the code and understand what all does it do in order to create ChatGPT app using Flask library in Python. Now, here we are on the Google Colab. First step we have to is set up the environment. As I told, we will activate the virtual environment of Python. What is this Python MVENV? Let's understand one by one. Python invokes the Python interpreter, which is already installed in your system. Then MVENV. This option always tells Python to run VENV module as a script. This module is used in order to create virtual environments on that. That is why we try to invoke this. Next, again you have VENV. This is the name of the directory where the virtual environment will be created. And it is not mandatory that you have to keep the second VENV as it is. You can change this to be ABCD also, or you can also put it as virtual environment. It is not mandatory that you have to use the same name, but with M, you have to use VENV. This is mandatory, and the second VENV is optional. You can change the name accordingly. Naming convention can be changed according to the requirements. Next, after doing that setup, we create the Flask application. As I told you, we are using only 2 commands of Unix since we are working in command prompt. First is make directory, MKDIR. That is, we are creating a folder with the help of command prompt. That's it. There is nothing great that's happening. Creating a new folder. The folder name is GPT Chat App, and you are trying to change the path, change directory CD to that particular location. And remember, wherever you have installed your Python software, that folder itself, these things to be created. We have to first navigate to that particular Python location. Then only we can create a new folder. Else there will be an execution problem and path issues. After doing the folder creation, we will have to create code file. First is a Python code file. which I would like to name it as app.py, application.py. Again, this is not mandatory. You have to have app. You can name it accordingly, but you have to remember what you have named. While you're executing this, you have to remember the exact Python file name, including the cases. It is case sensitive. Okay. First, we will import the Flask elements. First is Flask library. Next, request, JSONify, and render template. Then we will import the requests and also import time. These are the libraries we'll try to import, which is available in Python to our particular code. We will try to use request and render template, also the timing, in order to have the conversation between the system, that is ChatGPT, which we are trying to create, and our questions. Then we will initialize the Flask application. This is the Flask application initialization syntax. We will try to give a open API key. This is a secured key which you should not share with anybody else, or else they can utilize and you have to pay the bill for the same. Better you keep the API keys very discreet. This is a random API key. It's a sample API key, or else you can just put in your code, enter your API key here. This is far better rather than giving people your original API. Once you put this API key, you will next define the root of the home page, where it has to interact from. Obviously, you cannot show this backend code to the user. You have to have a front end. You have a front end that is called index.html. There comes the second core file. First one is having app.py core Python file. Next, it has to be integrated to the front end, that is index.html. Right? We will render the particular HTML template. That is why we'll be using render template library. Okay? We have usage of these libraries everywhere. Then we'll define the root for chat endpoint, which accepts the post request. Post request is nothing but what message you put to the GPT and what it has to respond back. And this complete thing will happen with the help of JSON. Then you get the response from GPT-3. And remember, there's lots of GPT models. Which one you are using, you have to have the knowledge about it. You have GPT 3.5 Turbo 16K. You also have just GPT 3.5 Turbo. You have many kinds of model. The current model which we use, you have to mention it here. And you also have to carry the input given by the user from the front end to the back end with the help of this messages. The data should be transferred from the front end to back end. What is the maximum limit of the response is 150 letters, characters. It's not words. Okay, it is very minimal. If you want to make it more, obviously you can make it 300. Again, it is according to the requirement you are catering for. Then you have to attempt to get a response from API, which tries in case if it fails. Now comes the word of error handling. The code which is not having error handling capacity is not a worthy code. Simple as that. If something goes wrong, first you have to let the system give you the message that something is wrong, not directly land to a error page. It should be interactive and it should tell the user whatever you have entered is wrong or something has happened. What has happened? This particular responses should always be there. For example, I'm giving you possibilities. It's not that every coder will be knowing everything what they have to do, right? But still, there are few standard error handling techniques when you work. You have status code 200. When this particular 200 status code comes, 404 error comes, 429 comes, right? How do you handle that? What is the error? What is the particular response you give? For example, if it is for 200, we can return the message to the user. Rather than going to a random wrong page, you have to give a message. An error occurred while processing the response from OpenAI. That means if your GPT is not connected properly, it is not able to give response, then you have to just not push that particular code to a error page. You have to send an error message. You have to tell this. Next, you have 429. Here, we are trying to request OpenAI if failed status. Again, we are trying to re-attempt. How many times? Back off, retrying attempts are 2. We will try to do 2 time attempts and then we will go for sleep. That means we are putting this particular system into sleep that it is not able to solve. The more you work with it, the more limit exceeding will happen. And 429 also deals with if your particular OpenAI is out of limits. It is not having any limits left. It is exceeded. You have to buy new. You have to put your billing again. It will say you have exceeded your current quota. Please check your plan and billing details. So that's how you have to try to give error message to the user so that they understand something is happening. We have to go and address, because nobody will go to backend and debug what is the error, right? In the front end itself, you have to show what is happening. So this is sample example of error handling. Then if any other error comes more than this, there are 2 errors which I have listed. If anything else comes up, you have to just give the status code directly. 404 error or internet disconnectivity error, anything might come. An error occurred while communicating with OpenAI is a standard default error message you can send. If you don't know what you have to do, just put there is an error, please decode. Then comes run the Flask application. This is the main method which we create for this code, and the code execution starts from the main method here. Now comes the second part of it, the front end, which we had discussed already there. And what are the complete content of that? We'll have a quick overview. That is index.html. Here you can see people who know HTML will always know this. Doctype HTML, you have head, you have HTML, lang, English, and meta character set is always there. You have style for your particular page, and you also have the body. Here you have a chat box, you have a text box, you want a button. It's a simple thing. You have to have a text box where the user will put their input. Click on send button so that it will interact with the ChatGPT. In order to display the ChatGPT message, you have to have a label or again a text box. So that's how it will work. It's a simple JavaScript which is being used in order to have this interactivity, that is fetching the information from the input and putting that to GPT and taking the response from the GPT and putting back on the front end to view for user. So this is the simple fundamental function that happens in this script section. How do you run this? Just you have to be in the location where you have created the folder, that is GPT chat app, right? I'll just go back and just give you an overview. GPT chat app, that is the location where the command prompt should be pointing out. Then you can execute Python app.py. When you do this, you will be able to access a browser where it is loading in this particular address. What is this address? Why only 5000? Why not 4000? You might question. As you all know, HTTP 127.0.0.1 will always deal with local hosting. When you do this local hosting, you have separate ports for every library or every kind of execution you do. 5000 is the port number which is allocated in every local system for Flask library of Python. Any Flask web framework code execution you do, it will launch on the Chrome with this particular address. Hope you had a complete detailed view of how this particular application will work. A quick recap, you have to install Python and necessary libraries. Then you have to create a main Python code file, that is app.py. Then client side, that is front end interface, you have to make it index.html. Again, this is as per your requirement. This is a common name which we keep. That's why I've used the same. You can create a simple HTML interface to interact with the ChatGPT. Then you can run the application and check for the output, right? So now that we have understood what is the code at the back end, front end, and every aspect, let's execute this code and check for the output. Before going to the demonstration of Flask ChatGPT app, let's understand the folder structure. I am here in the location where my Python has been installed. Since we've already worked on, you could see many folders here. We are trying to create GPT chat app, right? According to our steps, we've already done it. So if you go to this particular folder, you can find two different elements. One is templates, another one is app. What is template? Template is actually the index file which we had discussed, the HTML file. App is a main program. Once you execute this, the back file will be created. If the execution is successful or not successful, doesn't matter. Once you run this through interpreter, it will generate automatically. That's why it is present. If you're executing for the first time, this will not be there. Okay. Now, let's hop on to the command prompt and check how does we work with this. Here we are in the command prompt and in the location where our file is. Am I right? No, I'm actually wrong. We are in the location where Python is. Now we have to enter to the folder created. What is the folder we created? We have to change directory to that particular folder. GPT underscore chat underscore app. This is the folder name which we generated, right? Let me enter to that. See, now we are in that folder. How do we execute? The steps which I mentioned, we have to type Python and we have to mention the app.py or the name which you have given to your main Python file. You have to mention that and click on enter. Once you click enter, after executing this app.py file, this is how the output looks like. Are we in the right output screen? No, it is just indicating that it has been executing, it is running. The location is we have to go to HTTP 127.0.0.1 5000, the port number. Let's quickly hop on to that location on our search engine. Any browser you can use, you can go to this particular port number. Let's hop on to that. Once you go, click on HTTP, the same ID where it has been launched across, you will find the interface. Now, what you have to do? You have to communicate with the GPT. So, I'll press hi and click on send button. It will say, hello, how can I assist you today? The next question which I ask is, how are you? When you do this, you send this, I'm just a computer program, so I don't have any feelings, but thanks for asking, how can I help you? So this is how it is trying to interact with the human being. If you try to give something which is not existing, still your chat GPT is not trained to that level. It is a normal basic model. I'll say, where do you live? I'll click on the send button. You have exceeded your current quota. Please check your plan and billing details. It will not throw up this errors. Really, if your limits are exceeded, right, that is when it will show this error. It will try to do that error handling which I've already mentioned. So, for the third conversation itself, how did we get this message? You might be having this particular doubt. The thing is, OpenAPI API key is not very much free to everything. You only have access for $5 worth of conversation that can happen, API key that can generate. That is how you can converse. After it exceeds $5, it will try to ask you to fill up and select the plan and do the billing, right? The payment should be done for the same. So this is just a simple example. You can enhance, create, you can buy a paid version and start building the projects and help your small scale business if you own any, in order to have a private chatbot so customers can interact without any actual agent service required. Customer service, you need not take it. You can use the bots there on your website, right? This is a simple idea. This is how the execution looks like. By now, we have understood how does ChatGPT, while using Flask, how we can execute, what are the code required and how the outputs look like. Now that we have understood and also saw the demonstration, how does a ChatGPT app work when you create with the help of Flask library using Python? Now, let's check out the next topic. Using the same Flask, how do you use text-to-image application? Here, the simple idea is text-to-image generation involves creating images for textual description using AI models. You will give a simple description. Here, we are not focusing on description. We are trying to get a image for the word which we give. As I told, cat, dog, any animal or what you want to fetch for. Significance of this particular application: enhances creativity and design processes, useful in various fields like advertising, entertainment and virtual environment. Say you want to get an image, you can give a description: cat which is sitting on a mat or dog which is sitting on a bed. You can give certain description, you will get images in certain way. Or sketched cat image, drawing of a cow. So you can give a certain description to AI, it will generate back the output for you. How do you implement this particular text-to-image app? First is we build a web application that converts text description into images. Again, if you want to build a web framework, it is about Flask. Then you use OpenAI. Again, HTML, CSS for the front end. That is very much mandatory and basic. What are the prerequisites you want for this? First is Python to be installed in your system. Next, you have to have a required library, that is Flask and OpenAPI, and you have to have a API key from OpenAI. This is the basic requirements it should have in order to start off with the development of this application. Now, let's understand what is the code for this particular app. What is the purpose and what all we use here. Then later we will execute this. Hope we are clear. Now let's quickly hop on to Google Colab, understand more about this application. Here we are on the Google Colab. First step, if your Python is not installed, install your Python. If already exists, ignore. Simple as that. Again, create virtual environment. We already had the description about each and every element of this particular code statement. Then we activate the virtual environment by using this particular code here. Next comes installation of Flask and OpenAI. It's very important to install the libraries which is necessary for your coding. First place, we'll be using pip command to install Flask OpenAI. It's a simple statement here. The code line, you can just execute the same. Then we have to create the project directory. Again, nothing but the new folder. It is named as Flask _text_to_image. If you want to put some other name, it's left to you. You have to go to the folder which you have created. Then only you can start creating your Python code file and HTML code file. First thing is main Python application code file, which is again named as app.py. It gives you a proper signification. It will not mix with the previous one because the folder is different. So again, we have to import the necessary libraries. We are initializing the Flask application. You have to have a Open API key. You can replace this your Open API key into your original Open API key. How do we do that? Then you have routing which has to go, that is index.html. In this HTML file, you have all the designs related, front end related, that has been fetched, and you will be routed with the help of function called generate image as a post method. We will be using JSON. Post method means the response which you get from ChatGPT, right? Either it might be your user input also acts as a post, and also the response will be also a post. Use OpenAPI to generate image based according to the prompt which has been received. The size should be only this much, and the number of images generated at once should be one only. Then the prompt which is given by the user will be pushed to OpenAPI. It will get a response, and then that particular image will be displayed. If you want a detailed explanation of what does every line means, I have it for you. You can just read it. What are the different elements we use and why do we use, right? Next, you have to create this HTML interface, that is the front end. Again, you have to have a text box, a button, and where you print your prompt, and then you will put that inside the GPT. It will fetch the output on the same screen, right? You have to have a simple text box and a button. That's it. If you want to do more styling, you can more welcome use CSS files and you can do it. This is a general basic setup or the front end which you need. And you have a script. Again, you have a function called generate image. Here what happens? It will fetch the information, the prompt from the user, and then it will put that particular prompt to OpenAPI. Once you get the response from OpenAPI, it will push back the response on the front end. This is the code for the same, right? It's just an interaction code between the front end and back end. We'll be using JavaScript. This is about the HTML file we'll be using. Again, if you want to run this code, you have to type python app.py. And you have to be on the same folder where you have created at the start. If you go somewhere, navigate to some other location on your command prompt, and if you try to give, it will not execute. Let's have a quick recap. Here, first is we'll be installing Python. Next, the library is called Flask and OpenAI. Later, we will create a Flask application, that is app.py. Then we will also try to include the functionality of converting text to image, that whatever the text we have given, related image will be provided. So we have to root for that, and you have to have a simple HTML interface in order to have the connection between the user and the system. Then you have to access and run the code, start the Flask server, and again you have to go to the same location, that is the same IP address which ends with the port number 5000. So this will be your particular location address. It will run there. You can execute the same. Now, let's quickly check how does this work in our demo. Now, here we are in the Python location of the local system. We are trying to execute Flask Text-to-Image App. If you try to go to that particular folder, you could find the same folder structure. It is having a main Python code, and then you also have index in the template, right? Once it is executed, backfile has been created. So that is why they are here. This is the structure. Now what we have to do, go to command prompt, type this particular location and try to execute with the help of Python app.py command. So I am copying this location completely, going to command prompt and changing the directory to the copied location. Now we are in the folder Flask Text-to-Image application, which has been generated. We straight away try to execute this with the help of Python app.py command. Once we do that, we will click on enter. This is where the Flask server has been running. It is active now. We have to go to the location, which is mentioned right here with 5000 port number. Let's hop on to that particular location. Once you come to this location, you could see the basic HTML design which we have made, and it's our time now to give certain description regarding the image and try to generate the image. I'll give just one line of description. If you want, you can give in detail description so that the GPT will give you a right perfect required image as per the command. I'll try to give mountain with skylights. Okay, so let's mention color also. That will be good. So mountain with green skylights. This is my description of an image which I need. I'll try to generate. Okay, this is how we got the image from the GPT. It has given the lights which is in green color on the sky, and mountains are right here. So this is how the descriptions will be taken care of. The more precise description you give, the more precise image you will get as an output. So this is how text-to-image application will work with the help of Flask OpenAI in your Python, which also help to generate the images for digital content creators or any kind of creative people who work in that particular field. Let's understand how does Langchain apps work. What is Langchain in Python? Overview of Langchain. Langchain always streamlines the development process of the application and utilize the LLMs by offering a extensible architecture. Generally, simple words, Langchain is a library of Python just like Numpy and others. Okay, it supports wide range of use cases. Generally, we use Langchain in order to create assistants, chatbots, and many complex NLP tasks and data analysis aspect. This is the application of using Langchain. Then the framework is built with highly customizable interiors of the code, and then we also develop to tailor specific needs, and we also integrate the same tailored code or module to the external data sources using API keys. This is the simple work which we do with the help of Langchain app. It is just that we are using this library in order to create good model which acts to be a chatbot or personal assistant, or any other requirement will be catered with the help of Langchain application. Now, in order to understand more about this, we will try to know the case study for this Langchain app. Let's explore more. Again, I'm going towards Google Colab. Let's understand the code, and later part we execute that in the command prompt. Here you have to note one thing. We are not going to the Google Chrome where the IP address ends with 5000. We are executing this in the command prompt itself. This is one of the differentiation between what we have already seen and what we're going to see. Let's hop on to Google Colab. Now, here we are on the Google Colab. What we are trying to understand, what is the case study? First thing, personalized story generator. That means it will try to take certain inputs from the user and try to generate the story for the user. This project will take inputs, might be the character names, settings, and theme of the story. It will generate unique story every time you try to communicate with ChatGPT 3.5. Why I'm stuck with 3.5? There is 4 and 4.0 that's coming, right? But when you go to OpenAI, it's still at the 3.5 version itself. It is having 16K, 1105. There is some other codes that's going on. It's just a turbo GPT 3.5. There are many kinds of models. But for now, it is 3.5 in OpenAI platform. Not talking about the ChatGPT 4 or 4.0. Okay? Don't get confused with that. Steps in order to create this project, very simple. Set up the environment, collect the user inputs, generate story using AI model, and display the generated story. Simple as that. First, when we talk about the installing of libraries, here we have to install OpenAI Langchain. It is related to OpenAI, also related to Python. So, pip install OpenAI and Langchain. Both of these libraries we have to install. Then, in order to collect the input from the user, you have to have two different Python files here. So that is the differentiation. Previous demonstration, we had only one Python file, one front-end file. We used to work with the code. Here, you have two files. What does this do? First one says user input.py. That means we are trying to welcome the user and take the input from the user. Here you could see, welcome to the personalized story generator. You have entered the main character's name. Please enter that. Then enter the setting of the story and enter the theme of the story. For example, adventure, mystery, horror, anything as such. Return the character setting theme to the particular file called storygenerator.py. You are taking input with the help of one Python file and you are trying to give that particular collected input to another Python file, that is storygenerator.py. From Langchain, import chain prompt text model, then user input. As I told you, user input file, you have to take all the user input, get user inputs. What is collected? Character name, settings, and theme. This is collected. You have to take this as an input and import that into this particular story generator Python file. This is the function where you can just create certain story according to the inputs given by the particular user. Then you will have a prompt. You will have to work with a text model. As I told you, this is GPT 3.5 Turbo here, and here comes your OpenAI key. You have to put your secret key here, and then you have to execute this particular main block. It will try to give you the story generated here in the print statement. generated story is so and so. A paragraph of a story will be displayed for you. So this is how the main block will get executed, and these are the commands or the codes which we use. Every code is having a self-explanatory comment that you can read and understand once again if you don't follow it here. Okay, this particular learning material or code is always provided. No worries, you can go back, rework on this again. Then what do you do? In order to display the story, you have to execute the file. How do you execute? Story generated.py. Here, why are we not using Python? We have to use Python, right? It should be Python story generated.py. That's how it will execute. Simple as that. You will have a quick recap here. First is environment setup, that is you are having Python in your system. You have two libraries, that is OpenAI and Langchain. Then you have to have your own API key, which is discrete. You have to create main script, that is story generator. And you also have to create a subscript, that is user inputs. Then you have to generate the story functionality, that is OpenAI's ChatGPT. You have to use that and you have to give them the character, name, setting, theme, etc. It will develop the story, and if you execute, it will give back the story which is already developed. As simple as that. Hope this is very clear for you. Now let's see the demonstration. What is the output and how it will work? We are trying to execute personalized story generator, which we have already discussed that we are using the library called Langchain. Here it is. You have two different Python files. One is story generator, one is user input. It is already explained. User input is used to take the input from the user, and story generator is the main app. You should not execute Python user underscore input.py. You have to execute story underscore generator.py. That's how you will get the output screen. This is kind of special execution that every output is seen on the command prompt itself. We need not navigate between any other locations for output. What is this PyCache? If you click on this folder, after you compile your code, this is actually generated. Compiled Python file will be generated. So that is why it is here. Now, let's quickly hop on to our command prompt and try to execute this particular code file. In order to do that, first what we need is we have to copy this location where it is actually situated, the folder of your app. Now we are on the command prompt. We are changing the directory and pasting the location which we copied and clicking on enter. We are in the folder called personalized story generator. What we have to do, we'll try to execute Python story underscore generator dot py. Once you click on enter, this is how it starts executing. Welcome to the personalized story generator, and I'll type a name of the main character as Alice, and it will ask setting of the story where it has to happen. I can say Enchanted Forest. I'll give the location, visualization idea for the GPT. I'll click on enter. It should be a mystery one or adventure one or horror one, whatever you can mention that. I'll mention as adventure story. I'll click on enter. See, the story is generated in this form. You can read the story pausing the screen, but yeah, it will include the main character, the setting of the story, also what kind of story, what is the theme of the story. It will try to give you the complete paragraph which you can use it for your requirement. This is how a story generator will work. Using Langchain, you can create much more applications. This is of one basic example. Hope this is clear for you. We have executed the code. We saw the output. How does the story will be generated with the help of GPT, which we have connected with the help of the API key.
We will be building an Android application that generates email templates for sick leave and casual leave using GPT. As you know that we are going to create an email generator app, first let me tell you what are the different softwares which are required for having this app being generated. Since we are implementing an Android app, we need to have an Android Studio editor. So for that, you need to go to the website of Android Studio Editor, which is developer.android.com studio. And then when you open the website there, you can see a link called as Download Android Studio. And once you click on download, it will ask for your terms and conditions to be accepted. So you can read these terms and conditions, and in the end, you can just click on I have agreed on the terms and conditions and click on download, and you can see that the file is being downloaded. Once you download the file from your Android Studio website, you need to see this Android Studio 2024 and the version of it. So you have to click on this and execute the steps which it follows. Since I have already installed Android Studio, I'm not going to follow the steps. So you can just carefully follow the steps which it is giving on the screen and try to install the software IDE onto your laptop. The next thing which we will be doing is we will try to create an API key here. So to have this API key, I'm using ChatGPT OpenAI platform for creating this key. So I have already logged into my ChatGPT OpenAI key. Even if you have a free version or a paid version, it's fine. Free version will have the usage limits for your API keys, but still you can be able to use those API keys and have your apps being generated there. So as you open your platform.openai.com, this is the page what you see when the website is open. You have to go to your login, to your user profile over here. And then if you see over here, you can see user API keys, right? Since we are trying to create a new API key, we need to set create new API key. This field is optional, so I will just give it as app here, just to say that I'm creating an API for this email template generator app here. And then when I click on create secret key, the key is being generated. So we have given the permission read and write API resources, right? So this secret API key is needs to be kept very confidentially because there can be some data breaches which can happen. So you just have to copy this and keep it very safely. So I'm just trying to open a notepad over here, and I will try to have this generated key saved over here so that I can use that in my program when I'm trying to implement this email generator app. As you can see that my Android Studio is being installed and we are opening the Android Studio here. So now we will try to create a project for your email generator app using your LLMs. So what is the first step which you need to do is you need to go to File, go to New and then New Project. And then you can just click on Empty Activity and go to Next over here. And then you can give a name for your app. Here I'm trying to give a name like Email Generator App. Okay. And you can see that the package name is com.example.emailgenerator.app, and this is my save location. And my SDK is the default SDK which I'm using over here, and my build configuration is Kotlin DSL, which is the recommended version for this app. I'm not changing any of the default configurations here, so I'm just trying to click on Finish. This will take some time and a new project will be created. So now you can see that the project is open and we have two folders called as app and then Gradle script. So we will see one by one what are these folders and how will they help us in trying to implement this app over here. So we'll just open Gradle scripts over here. We have some of the configuration files you can see over here like build.gradle.kts, and then you have libs.version.toml. All these files are actually required for having your configurations being run there. Okay. The only thing what we will be changing over here is your build.gradle.kts file. This build.gradle file will help you in trying to add those configurations and the required dependencies which will help you in trying to have this app being generated over there, right? And then we will also, this build.gradle file will also help you in trying to figure out or you can say debug or try to test your tool and help you analyze with how the configurations are being set and how the dependencies are being used over there, right? So the only thing which we would be changing over here is we will be trying to add the dependencies which are required for our app here. Okay, so you can see that I have just added the dependencies of your Android and JUnit and Expresso. All these dependencies I have added based on our app here. And once you have modified your Gradle file, you need to actually sync your project, which will help you in trying to work properly with those dependencies. So I'm trying to sync the project now. So this will also take a while, but you can see if the sync is successful or not. If the sync is successful, it means that the dependencies are added successfully. If not, you need to check out on the errors and try to debug what sort of errors are there, and you need to figure out what the problems are and try to fix that. Basically, you will not have any errors there though, because we are only adding the dependencies. Now you can see that the sync is successful. If the sync is not successful, it will show you errors in this problems terminal over here. There are some warnings, but we can just leave those warnings as such over here because it's just telling us to update the newer version, but we are just trying to use the versions which are apt for our email generator app now. So that's all about your Gradle script. Now moving to this folder app, which is our main folder, which will help you in trying to add those functionalities to your app, wherein you will be able to add those input text fields, your buttons, all those things, and how to interface between your front end and your backend over here with the help of your API keys over here, right? So you can see that in app we have manifest file, we have Kotlin Java file, and then we have your REST file over here. So we will just explore one by one what exactly these are and what are the changes are we going to have being incorporated in these files. So in your manifest file, you have Android manifest.xml file. So if you see this Android manifest.xml file, this file will help you in trying to give the critical informations for your Android system, and also it will help you in trying to access the permissions which you're trying to give over here. So we will just try to not modify much over here, but we will just try to add the connectivity with the help of one line, that is your internet access. We'll try to add that over here. So you can see that the only thing which I added over here is the user permission, wherein I'm telling that the user Android needs the internet permission since we are trying to interact with the APIs over here. So this is the only one line change which we are doing in this file. Okay, next we will move on to this kotlin.java file. This is our main package, that is your com.example.email generator app. So we'll just try to explore this, what exactly it is there. This is our main activity.kotlin file. It is actually the main entry point for your app, wherein you will be trying to define the user interfaces. You will be also giving the API key which you have just generated, and try to have that functionality being added there. Right? So we will first try to create the user interface, then we will try to add the functionalities of your fetching APIs and trying to have those request and responses in your main.kt file. So what exactly do we have to do when we are trying to have the layout set for your app? So you just have to go to this res folder over here. You can see that there are few files over here, drawable map values in XML. So we will just try to create a folder called as layout folder. So when you're trying to create, just right click on the res folder and then go to your Android resource directory, and then you just try to give your resource type as layout and then click on OK. Okay, so you can see that the folder has been created over here. Now we just have to create a file over here. Again, we will right click on it, go to new, go to your layout resource file over here. It will ask you for the name. So we will just give the name as activity main, and then you can see that the file is being created. So this will give you the layout of how the app will look like. So I'm just going to go on the constraint layout and go to XML because I need to do some modifications in trying to add your text buttons and your radio buttons over here, right? So we'll try to add those text and radio buttons over here. Okay, so you can see that I have created a linear layout over here, wherein I have an edit text, and then I have two buttons over here, one for generating a sick leave email and the other one for generating a casual leave email. And then I have a text view which will actually give the response. In this text view, it will give the response of my generate casual leave email and your sick leave email. Then what's the next thing which we need to do? The next thing which we need to do is we need to try to modify your colors, strings, and your themes.xml file. Next thing we need to do is we need to check out on the user interactions. We will try to modify your colors.xml, string.xml, and we'll also try to add some of the styles for your XML. So I'm just opening colors.xml and I'm just trying to refine it based on the details of your color formats based on how I want the app to be as. This string.xml manages your text resources. The color.xml manages your color resources. Now we will try to create the styles.xml. Again, right click, go to new, values resource file over here, and then you can give the file name as styles. Click on OK. A file is opened over there. This file will help you in trying to manage and theme your text. Now that we have created the layout, we will just try to add the API which we created in our main activity file so that we can have that interface being generated. So this is our main activity.kt file. Here you can see that I have created a private function over here to send the query, and I'm using the URL https://api.openapi.com, which is the URL which we use for creating your API. And the model which we are using here is GPT 3.5 Turbo, and then the prompt is query, and then the maximum token what we have defined is 150 over here, right? And then we have defined the request body, and on response what the body has to be given over here. So it's just a simple file wherein you're just trying to use your API keys, try to send a request and try to retrieve a response file there, right? And you can see that you have created a variable called as API key, and the generated API key which we had generated using our ChatGPT, you can just copy paste the API here, right? Now we will try to execute the files, and we will try to see if the app is generated on the Android mobile or not, right? So to do that, we will first try to figure out if there are any errors or not. So we will go to the file, we will go to build, we will first try to clean the project. It will take some time. Okay, we have cleaned the project now. Now we will try to rebuild the project. So now you can see that the Gradle build has been finished. So you can just see over here if there are any errors or not, you'll be able to figure out here, right? To run this application, we will be using an Android mobile. So I will be telling you what are the settings which you need to do so that you will be able to access your Android mobile for this app. Let me tell you how the settings you need to do when you're trying to have your Android app as your physical device to run this app, right? You just have to go to settings over here, and then go to your about phone, and after you have clicked your about phone, go to your software information, and here you can see there is something called as build number. So you try to tap that build number, and it will tell you how many times it has to tap for the developer options to open. And then it is asking for my PIN here. I'm just trying to give my password here of the mobile, and then you can see that a message popped in like developer options have been enabled. So how do we check that? Go back to the screen, and then you can see that after your about home page, you have your developer options being installed here, right? So just click on your developer options over here, and then after that, you can see that the developer options have been on over here, since we need to sync your app, whatever you have constructed in your Android IDE to this mobile. So what you just need to do is click on enable your USB debugging. You need to enable your USB debugging. So it will ask you whether USB debugging is intended for development. You just say OK, and then you will be able to access your device through your Android mobile. So I'm trying to click on OK, allow. Now we will click on the run tab here. So we'll see that the project is built and it is launched onto your Android mobile. Now you can see that the app is successfully installed onto your mobile. So we'll just check this out. So you can see over here, so I'll just try to give a prompt here that I have fever and need 2 days rest. So after this, I'm just trying to click on generate, and when I click on generate casual leave email, it will create a casual leave email. So this is how it is easy to build your LLM app. A simple app is what we have created here.
We are going to use Replit, an online code editor, to run, write, and test our code. Replit makes it easy to collaborate and share your projects with others. Now I will walk you through the steps of building the rock, paper, scissors game. We will start by setting up the front-end files, then move on to the back-end with Flask, and finally connect everything together.
So here I can go to Google and I can log in into my Reflect account. I have already logged in. So you can create one account for your own. So this is my Reflect account. Next, it is telling me to create a new project. So it is telling me to click on the create button and choose Flask as the template. So I can go and click on the create Reflect option here. I should select Flask as an option. That is your template. Now, I have to give a title to it. So, what can we give? We can give it as Rock, Paper, Scissor, Game App. Okay. So, now create Reflect. Now, once you click on create, it will open a new page for us. So, now here we will be copy pasting our code. So, we'll see what is our next step. Our next step is to set up the backend, that is Python with Flask. So, we have to open main.py and copy this code. That is your Python code. So, click on copy code here, go to your Replit. So, this is our main.py. So, here I am copy pasting my code which I have got it from ChatGPT. Next, after this step, it is telling us the step 3, that is to set up the front end. So, to set up the front end, we have to create templates folder first. So, let me go back and I am in main.py now, and here there is an option of new folder. So, click on this new folder and name it as templates. Okay. Now, it is also telling me create a new folder named templates. Inside this folder, we have to create a file named index.html. So, I'll copy the same name and I'll go back, and here it is telling me file. So, I will copy paste my HTML file now. So, I have created an index.html file. Now, next after creating it, it is telling me to add HTML code. So, I will just copy this code and I will paste it here in my HTML file, that is index.html. Okay, we'll see what we have to do next. Next, it is telling me to create static folder. So, I'll go back on the main.py, click on main.py, again create a new folder by name static. Okay, and inside that we have to create 2 files now. So, one is style.css. I will name a file as static.css. So, now after naming my one file name as CSS, other file name is script.js. I will create another file inside this by name script.js. I have created 2 files inside static folder now. So, now I have to add CSS code. So, I have to copy my CSS code and I will go to my CSS file and I will paste the code here. Next, it is telling me to add the JavaScript code. So, let me copy the JavaScript code from here and I will click on the JavaScript file and let me paste my code here. Next, we will see what it is telling. So, step 4 is nothing but running the application on Replit. So, before we run into our execution, let us see the main gist of what these files are now. So, this is the Python file where you are setting the actual context, where it is actually playing rock, paper, scissors and all of that, taking the input from the user. HTML file where it is used for structuring your code. So, your entire web page will be set up using this HTML structure. Then is your CSS where you are styling your entire web page. And then is your JavaScript, which helps you to interactively connect everything on your code that you are developed. So, now once you understand the gist about it, we will move on to our step 4, that is your running the application on Replit. So, to run, we have to just click the run button on top of the Replit. Then you can access the game is what it is telling. So, now I will go here and I will run. So, when I run this code, you can see that you have got an output. So, it is telling rock, paper, scissors. So, if I click on rock, it will tell you chose rock, but computer also chose rock. So, it is a tie. So, when I click paper, you chose paper, but computer chose rock. So, you win. So, this is how you can get the output for a single player, computer being your another player.
So now we will actually define our code. We will refine our code using ChatGPT better for 2 players. So I am just giving the prompt as rock, paper, scissors should be for 2-person game. So when I give this prompt here, again it will refine the code and it will give me the code. So simply we will copy paste all the codes of Python, HTML, CSS and Java from here on the same document that we have created. So copy the Python code. I will go here and I will paste it in my Python file. So select all, select V. So I pasted it here. Now, next let me copy HTML code. So copy code, go back to your Replit. In your HTML file, let me paste the HTML code. Next, it is giving me the CSS code. So copy the code, go back to your Replit, go to your CSS file and paste your CSS code. Then go back to your ChatGPT and copy your JavaScript code. Get back to our Replit. Let me paste my JavaScript code. So after doing everything, let me run my project now. Right? So let me run. So when you click on your run button, again, you got your new output for 2 different players. So player 1, let me choose rock and it is telling waiting for the other player. Player 2, let me choose paper. So it will tell paper is the winner, right? So it will tell player 2 is the winner. Like this, you can test for n number of options. You will get the output as who is the winner in particular option or game. So this is how you can develop the app using ChatGPT. We'll be using HTML, CSS and JavaScript as our basic programming languages. The coding playground of choice will be an online editor, one compiler. With ChatGPT 4o by our side, creating our dream website is as simple as describing what we envision. Whether it's a portfolio, a blog or an interactive application, GPT-4o will guide us through the process, ensuring we achieve our goals efficiently and creatively. Let's roll. First, let's open our ChatGPT playground and let me select 4o. Now, let's see what will be our prompts. I want to build a portfolio website. Let our front end be HTML, CSS and JavaScript. I want to execute this on an online editor, namely one compiler. This goes our instruction constraint to the GPT. I want this for the target audience who have zero coding knowledge or at their learning phase like college students and early professionals. So let it be simple and easy to execute and understand by them. This sets target audience to the GPT. Let the creation of this be very responsive, creative and with simple explanation and step-by-step process which helps them to understand and create these easily. This sets context to our ChatGPT. Please explain everything from scratch. We are instructing ChatGPT how it has to give us the steps. Great. Now that we understand our prompt, let's execute this on ChatGPT 4o and see the results. Wow, we got the results so fast and in a well-structured manner.
Hey everyone, you made it to the end of this Python journey. Congratulations, whether you were here to sharpen your skills, explore AI or just have fun with coding, you have accomplished so much. Let's quickly recap what we covered. We started with the basics, understanding why Python is so popular and how to install it. From there, we jumped right into beginner-friendly projects like building a word counter and a fun word game to boost your programming confidence. As we progressed, things got more exciting. We built real-world tools like a password generator, an Amazon price tracker, and even explored face recognition. These projects gave you hands-on experience with Python libraries and APIs. Next, we dove deep into data science and machine learning. We worked on analyzing football data, predicting Uber fares, and detecting credit card fraud. We even created a movie recommendation system just like the ones used by streaming platforms. Python isn't just about numbers and algorithms, it's also a great tool for creative projects. We explored IPL and FIFA data, compared Marvel and DC characters, and even took a look at Game of Thrones data. Who says coding can't be fun? We didn't stop there. We built practical apps like a QR code generator, a smile detection tool, and even a gender detection system using OpenCV. And we built a translator app too. Finally, we peeked into the future of building generative AI apps with Python leading the way. You now have the tools to create chatbots, art generators, and other exciting AI-powered projects. Throughout this video, you also learned to tell compelling stories with data using visualization tools like Matplotlib and Seaborn. Now you are ready to create beautiful graphs and dashboards. And there you have it. You have explored Python from the basics to advanced AI, from analyzing sports data to detecting faces in real time. Whether you use these skills for work, hobbies, or building the next big app, you are now equipped to do amazing things with Python. Thank you for being the part of this journey. Remember, the key to mastering Python is practice. So keep experimenting, keep coding, and most importantly, have fun with it. Until next time, happy coding.